Welcome back, everybody. So before we start this episode, and yes, the anticipation is real. We've been waiting for this. This is a flat earth debate. This is probably the most compelling, fascinating episode that I've ever done. John is going to join me afterwards. We're going to do a little after show once we're done, a little wrap up. But the thing I want to let you guys know, because this is such a long episode, the chapter feature on YouTube, you can go to you can jump to different chapters. For those of you who want to watch the whole thing, please do. I please encourage that you do that. For those of you who just want to skip to certain points, like for instance, when I do counterpoints, proving the Earth is round, there's going to be the word counterpoint. You'll see that in the chapters, and then also the 3 proofs. There's 3 empirical proofs. Just go look up in the chapters for proof 1, proof 2, proof 3. So I want to make sure that you guys do that. Make sure you like, share, and subscribe. Also, for those of you who are listening on Apple Podcasts or listening on Spotify, the chapters are also going to be in the description, so you guys can skip around to that. It's incredible. I really, really hope that you guys enjoy this. If you have a real hard time with this, let me recommend try listening to it at 1.5 speed, because this is an intense episode. I do believe, John, this is probably the longest, most thorough live debate between people who don't believe the Earth is flat and people who do, where the ideas are thought out and educated, guys. So stay tuned. The podcast starts right now, and we will see you right after this. All right, guys, we are back, and I have promised you, I've said for several times that I wanted to have flat earthers on here, so we did it. I'm really excited. We got 5 people on the podcast today, so I want to hurry up and introduce them all. First, I'm going to introduce my co-host from the United States Navy, a former U.S. Marine. He is Lieutenant Adam Butel. He is an F-18 instructor fighter pilot. There he is. You can smile at him. It's good. We're going to have a good time today. There we go. I got Adam on here. He has a PhD in theoretical physics from Cornell University. He is formerly of Cambridge and currently on the staff at the University of Virginia. It is Sergey Dida. Dr. Dida, you there?
Thanks for having me back.
Beautiful, beautiful. And our guest today, we're super excited to have him from the Flat Earth Podcast. It is Mr. Flat Earth Dave Weiss. How you doing, Dave?
Doing great. Glad to be here. Looking forward to the conversation, guys.
I'm excited too. And then also his partner, Jaron himself. Jaron, you there, brother?
What's up, guys? Thanks for having me.
Awesome. So I just want to say this real quick. I've seen a ton of these interviews. I'm sure I've gotten a bunch of responses when I told my friends that I was going to do this, like, oh, don't do this, or ask them this question. I'm just going to let you guys know this is going to be a very cordial conversation. Dave, I've listened to maybe a dozen of your podcasts. You're very compelling. You're a charming guy. Like I totally get where the whole thing comes from. The 3 of us do not believe the Earth is flat, but we want to have a discussion here, a full, thorough discussion where you describe your model, we describe ours, and then at the end we can just sort of rectify. And I think this whole thing will work. The other thing is I've done a lot of, I'd say in the last 6 months I've watched 5 or 6 documentaries and I've listened, like I said, to several dozen podcasts. I was briefly dating a flat earther, very briefly, and we had the discussion about this for a while. So that's why I wanted to do this podcast.
But she couldn't convert you, so she broke up with you?
That is not inaccurate. That is not inaccurate, actually. That is not too far from being inaccurate. If she's listening to right now, she's laughing her ass off. Yeah. All right, so let's go ahead and start with a couple of things. Let's try to get this, because there's so much we're going to talk about, and we will go as long as you want, okay? So the first thing is for those in my audience. I don't have a flat earth audience, and we're going to discuss both sides of this, is the dimensions of the flat earth and the characteristics of the sun and the moon. This is going to be the original question. So what I would like is the quote-unquote physics of how the flat earth model works, and it just be as specific as you want to be here.
Well, let me just start real quick for those of you that are new to flat Earth. This is not the flat Earth. No flat earther thinks that we're a disk floating in space with other spherical planets or even other flat planets. You got to take that entire universal solar system out of your thinking, because that's not what the flat Earth is. We're not a bunch of disks floating in space. You Google flat Earth, you can end up at the Flat Earth Society. You can end up with images like this. No flat earther thinks this is what flat Earth is. So if it's not a disk floating in space with other disk planets, what is flat Earth? Flat Earth is like a pond. A pond is where water is at rest in its basin, and the edge of the pond is where the land is higher than the water. Lower the edge of the pond, the water will flow out. So large bodies of water at rest need a container. Here is our pond, right? All of the continents and islands are surrounded by water, but the water is surrounded by land. That land is Antarctica. Antarctica is not a continent at the bottom of a ball. They tell us Antarctica is the highest land on Earth, which is kind of weird. It's, this continent is the bottom of a ball. Why is it higher than everywhere else? It's higher because it is the basin of our world. So large bodies of water at rest are testably, measurably, scientifically, provably flat. Nowhere in nature does water, the surface of water, mirror the contour of its base?
Right.
So if the Earth is, just real quick, and I'll toss it back. If the Earth is 24,901 miles around, like they tell us, there's a curvature formula that dictates if a 6-foot tall person is standing at the edge of calm water, he should see a physical horizon no farther than 3 miles away. And with our naked eyes, without the assistance of super zoom lenses, we can see that that's not true.
Okay, so there's a couple of issues here. So if it is 24,900 miles, then that, if we multiply that times 3.14, then that means the area, the surface area, or rather the coast of Antarctica is over 75,000 miles around. Empirically, have you seen a 75,000 mile coast around Antarctica?
So the last person that, so if you want to prove that the Earth is flat, I mean, a globe, what we do is we get 2 airplanes. We go over here to the base in Antarctica. One plane flies 1,000 feet in the air, follows the shoreline around this way. The other plane goes this way, and 6,500 miles later, both planes should meet on the other side. But that's never happened. It's been tried. The last person to really try it was Captain Cook. And it took him 3.5 years. And he went over 60,000 miles, 80,000 miles.
Right, but his intention was not to map Antarctica. His intention was to go to the
it was to circumnavigate.
Yes.
No. It was to circumnavigate, and nobody has ever done it. 13,000 miles. They've gone over 60,000 miles. That's a problem.
Okay, so you're saying that it is empirical that the coastline of Antarctica is over 60,000 miles around.
So there's go ahead.
Oh, go ahead.
There's a boat race that goes down. They don't quite go below the 60, but they do a circumnavigation, kind of show them where they would go around, Dave. So they have this boat race, and the guy who has the record did it in 100 days going around the Earth. The weird thing about that is if you look up the type of boat that he has, that boat maxes at 40 knots. And if you look at the speed that he went around the world, he went 3 knots. And that includes a 2.5 mile per hour supposed stream. What's it called? The current.
Okay,
right.
Got it. Okay.
So that tells us there's a problem.
Got it. Okay.
So and the way he determined his speed was what GPS was telling him he was traveling and the time. And so the boat's going 3 miles an hour. That boat goes 10 miles an hour when there's no wind.
Okay. Got it. I understand. The problem is empirically I can't prove whether or not that did or did not happen. I'm going to take your word for it right now. But you guys don't believe in GPS to begin with, right? There's no global positioning system with 21 satellites going. There is, but what is it? It's balloons?
Go ahead, Jaron.
I think it's mostly ground towers. There's probably some balloons out over ocean areas, but it's mostly ground towers.
Okay, so that was another thing. We're skipping around here, but real quick, just to let you know, we're both military aviators. I'm a KC-135 instructor navigator, and he's an instructor pilot in an F-18. I can tell you unequivocally that GPS does work quite well over the Pacific because I had to do a rescue mission for a child that was from Anderson Air Force Base in Guam all the way back to Hickam Air Force Base in Honolulu, Hawaii. We had to fly the entire way at 10,000 feet because of the air pressure. Obviously, we can't go up too high because there's not enough air pressure. This child had a fluid in its stomach, so we weren't able to depressure or go to a lower pressure in the cabin. And in order to do that, I had to fly, and I had to use a great circle route in order to make my way back to Hickam. I am a navigator. I have to draw some of these on my own, some of these pathways on my own, and we got back there. So I will tell you, GPS does work over the Pacific. So you're saying it's balloons that make up the coverage loss whenever we're not?
Well, there's a lot of things could be. Go ahead, Dave.
Okay.
Yeah, no, I was just reiterating what Jaron was about to say. There could be balloons. There could be AWACS planes. There could be some sort of bounce off of what they call the ionosphere. We call it the dome. There's all sorts of different things. But what we have noticed that there's many spots in the Southern Oceans that don't have GPS. When you're going from California to Hawaii, you drop off the GPS.
So just
when you go over the
right.
Amazon, when you go over the center of the Amazon, there's no GPS there.
Okay, so I'm gonna tell you my empirical
but not
experience.
all of the time.
Right.
This changes.
Right.
This changes because they have balloons, they have airplanes, all sorts of stuff. So, are they getting better with their GPS? Absolutely.
Okay, so I'm going to tell you just my empirical experience leaving Travis Air Force Base, which is in Northern California, and then flying to Hickam Air Force Base in Honolulu, Hawaii. I actually put a TomTom in the window, and I was actually able to track ground speed, which is about 520 knots. Actually, it was slower than that, 420 knots. And then we did not lose GPS coverage. So I'm saying that the military GPS worked. We have 2 of them in the KC-135, and also my civilian GPS worked. This was in 06, so we didn't even didn't have an iPhone back then. I would have done it with my iPhone at that time. So I'll tell you that GPS does seem to be very, very robust for something that seems to be kind of patchwork together, balloons and towers. The other issue that I'm having is, so when I did air refueling over Iraq and Afghanistan, we had to have two aircraft meet together in the air, and those two aircraft had to be at the same bearing, the same altitude, the same airspeed, in the same location at the same time. And I was able to make those calculations using GPS, and once again, great circle routes that I use for navigation. And somehow I was able to make those air refuelings happen over Balad and over Jalalabad and all those other different places, Karachi, those places. So the thing is, one of the problems that I'm having, I guess, a little bit is that what our globist model seems to be able to predict things like my ability to make it to Iraq or Afghanistan, or my ability to predict every single eclipse with 100% accuracy. How is it that my model is able to do those things?
So the eclipses were predicted with accuracy thousands of years before your model. So that's certainly has nothing to do with that.
But also thousands of years ago, we also believed the Earth was round.
That's not true.
Well, there are absolutely, the Greeks did believe that the Earth was round. I'm not going to deny that there may have been some civilization somewhere thousands of years ago that thought the Earth was flat, but we had a pretty clear understanding. The Greek civilization did, that the Earth was round. So did the Egyptians.
What year are you talking?
Well, I mean, I'm not going to go specific, but 3,000 years ago, we were pretty apparent that, well, definitely 2,000 years ago during the Greek civilization, we certainly did. So 2,500 years ago, 3,000 years ago, most likely we also did. Okay.
So what do you think the oldest globe is? Because if they knew that for that long, there should be a globe 2,000 years old, right?
Well, yeah, but globe. So we're talking about what? During the agricultural revolution, we're actually putting putty together and making globes? No, probably not.
Really? You know? Have you seen some of the buildings they built? You're telling me they wouldn't have built a globe?
At the beginning of the agricultural revolution, there were no buildings that we built. I'm talking about 11,000 years ago. Huh?
How about the year 600?
The beginning of the agricultural revolution was 11,000 years ago. So
and you're saying that but they didn't believe the Earth was around then?
Some people probably did, based on what they saw with eclipses. They did believe the Earth was round. I can't. So neither can you, because until the Sumerians put stuff down on paper, we did not have a written language. So we're going to go ahead and speculate about what people did thousands of years ago, and whatever they believed thousands of years ago does not change whether or not the Earth is flat or round.
Let us get a little couple words in here.
Yeah.
So you say that the Greeks figured it out 2,000, 3,000 years ago, whatever. Are you talking, how did they figure it out? Was it the sticks and shadows? What are we talking about?
I mean, it's whichever one you want, but the conventional Greek wisdom was that the Earth was round. We can talk about Episthenes. You know, I have a hard time saying Aristophanes. Yeah, sorry, I apologize.
Right.
And as well, we could talk about that, but there were other ones. There were other civilizations that believed the Earth was round based on what they saw with eclipses.
Again, you're going back into things that the history is telling you. History. The victors dictate our history. Aristophanes said that this was a story that they teach all of us, that since sun rays come in parallel, even though no one's ever seen parallel sun rays.
But I've heard this argument before. It's not that sun rays come in parallel. It's that when you were standing in the well, if you looked up, you could see the sun. When you were standing in a different well that was in Alexandria, you looked up, you could not see the sun. It had nothing to do with parallel rays. Let me finish my point.
Okay. Let me finish my point. So you can.
Hold on, that has nothing. Okay, but that has nothing to do with him being able to figure out the shape of the Earth. Just because you could see the sun in one and not in the other, how would you measure any angles? What
you would measure is the angle that the sun was outside. Like, so, for instance, when I'm in, is it Syria? What was the I forgot the city where he takes the first measurement. No, the first one starts with a C. I forgot. Said. Yeah, Sain, and then the other one I believe is in Alexandria. I can't remember exactly the places.
Correct.
But in one of them, he looks up and he can see directly up into the sun. In the other one, there is an angle, a different angle, but it's the same time of day. And through those two measurements and trigonometry, he is able to calculate, again, globist view here, that the Earth was around 25,000 miles. He's wrong by about a couple hundred miles. But
all right, Michael.
Go ahead.
Michael, let me, without interrupting, let me explain.
Go ahead.
So here's Aristophanes sitting here. He has a sun ray going directly to the bottom of his well, or a stick not making any shadow. Here's his buddy 500 miles away, and you could measure the length of the shadow and the angle. You could do some perfectly good math to figure out the sphericity of this, all right? So you have to assume that the rays are coming in parallel for this to work. If they're corpuscular rays, well, then that entire thing's wrong. But that doesn't even matter, because on a flat Earth with a small local sun, we have the sun here, right? No shadow here. Here you can measure the shadow, you can measure the angle, and you can do the same exact math and figure out the sphericity of this flat plane. This does not prove that the Earth is flat or round because it works on both models.
It doesn't work. It doesn't work the same on both. Yeah, go ahead. Sorry.
Yes, it works perfectly the same on both models because there's no shadow here. Just get a just get 2 beer bottles, put a light above one of them. There's no shadow here. There's a shadow here. So according to your belief that this floor is spherical, so that doesn't work, right? It works on
how close does the sun have to be for
Yeah,
that?
this is my next question. How close would the sun have to be? You believe it's 3,000 miles away, the sun is?
No, I don't believe that.
How far away do you think the sun is?
I don't know
but
how
you
far.
should be able to calculate it.
Yeah,
Well, you should
exactly.
be able to calculate how far your sun is.
Yeah, it's 94 million miles on average. It goes
because
between.
that's the point. The point is like with if you assume the world is round, right? Then this entire experiment is predicated on the fact that the light rays come in parallel, right? Now there is a way of getting around that, like Dave just explained, is that okay? You can assume that you're on a plane, and now you have a point source. So instead of having rays coming in parallel, they're coming in from a point source.
That is exactly my point.
The trade-off is that now the sun's going to have to be hella close, and so you should be able to just calculate how close it is, and you can just calculate it. So you claim it's 3,000 miles.
Well, when they do calculate it, that's what they come up with is 3,000 miles.
Right. Well, the problem is with the situation is you guys keep talking about
parallel. Take that and just run with it, right? All right. So now we have this this point source 3,000 miles away. Okay, and now let's see what other consequences that has.
Right.
So you should be able to call your buddies and you'll agree that the sun's not in the right place in the sky.
Why not?
Because it's so close.
Why wouldn't it be at the same place in the sky?
Well, you'd have 2 options.
You're talking about it still being 867,000 miles wide?
No, the problem with that the sun being that close and being a static size is that the angular side for us would change drastically depending on what size of the Earth it is, and the speed which the sun would process over the Earth would change dramatically. That's the problem. You would not have a consistent the sun going over the Earth at a very, very consistent rate throughout recorded history. That's where the problem comes from. The second part, let's go back to this real quick. He does talk about parallel lines. The argument from the Globers is not that the lines are parallel. The argument is that the sun is 94 million miles away. It is a single point that is far, far away. So the whole parallel line thing doesn't really, it's almost like a straw man that you guys are making up. We're not arguing that. That's not our argument. Our argument was that the sun is 94 million miles away, and using trigonometry, we could come up with an idea for how large the Earth was. Now, here's the problem, okay? Our model of how big the Earth is happens to fit with what his model was, and he did this before there were airplanes and satellites. So you're saying that we just sort of made up the difference and agreed with us. Man, I'm going to say his name wrong. This Greek scientist, and we just have. Oh, he said 24-1. Okay, we're 24-1. Is that what you guys think? We just sort of rewrote history to fit what this Greek scientist said.
Well, I don't even know. He wasn't even mentioned by Herodotus, Hero, who was. Library of Alexandria as well. He's a librarian there 150 years after Aristophanes. Never mentions him once, even though they both were in geography. They both were librarians, so I'm not even sure he existed, to be honest with you. But none of his works exist. So
right, but we can still
Alexandria burned down.
Yeah,
right. Of course, it's a good story that all the books in the world were stuck into Alexandria and it burned down.
Yeah, not all the books, not all the books in the world, but all the books written by Greeks pretty much were in the Library of Alexandria, which did burn down, and there are multiple witnesses to this thing happening. Right, so that is kind of problematic.
There's no chance. Do you think there's any chance it didn't happen?
Of course, there's a chance it didn't happen, but the problem is The problem is I can still go into 2 wells 500 miles apart and do the same experiment. That's the problem. Yeah. It doesn't make any difference.
Perfectly on a flat Earth.
Okay, I don't think it works perfectly. It works perfectly.
It does work perfectly on a flat Earth.
Hold on, let's let Sergey talk. Sergey, go ahead.
Yeah. So yeah, you can assume the sun's a point source and it's super close, like 3,000 miles or whatever. But then, like, what other predictions does that?
So let's go into that.
Dave, you want to show the clock? You want to show the app?
Let's do it.
Or not yet.
Sure. Not yet. But I want to go back to the sun. Science has told us the sun is all sorts of different distances. Now it's 94 million miles away.
Just so we're clear, it's 92 on January 3rd, and that is the.
That's fine. How did you guys figure that out?
We figured. I mean, several sources, several recurring sources.
What is the source?
Well, so let's go.
Hold on. Let me, Mike. I'm just going to interrupt right here. I haven't been able to get a full sentence out the entire show.
Go ahead.
And I talk in short bits. Okay. I need to know. You can't say I read it in a book or somebody smarter than me figured it out. Tell me how they figured out the distance to the sun.
Okay, so the first one would probably be Galileo in 1601.
No, I'm talking about now. I'm talking about the 93 million mile measurement.
Okay,
I'll
tell you what, Sergey, do you have any ones for this? I mean, because he wants one today. Do we have any measurements for the distance to the sun?
I mean, I think that's the correct answer. Like,
so we can't measure it today, though. You and I can't go out.
No, we can. Like any one of these is proofs. So
how?
Okay,
So,
asking how.
Go ahead. Do you want to describe parallax and the distance between Jupiter and the sun?
How would we know the size of Jupiter?
Well, we actually know the size of Jupiter. We've flown. We've actually got gravitational assist from satellites that have gone past
Okay, but
Jupiter.
you have to understand, from our point of view, you could be telling a fantastic story about things that are going around, things in the sky.
We will get to that. Empiricism. I promise you. We will definitely get to the whole idea of empiricism.
Okay.
Well, I totally understand that. But we
want to know how you guys came up with the size of the sun.
Yeah.
The size of the sun or the distance, right?
The size and the distance.
Okay, so as far as the distance, we would go all the way back to Johannes Kepler and his readings for how planetary motion works, and then we would also use that in combination with Principia, written in the 1680s, where we talked about Isaac Newton and his law of gravity. So if we know the distance, right, the inverse square law when we talk about gravity, when we know the distance of different objects and we have a rotational period, we can tell, okay, this object weighs this much and this object weighs this much. I won't go over the exact one.
Newton didn't have an idea.
No, hold on. Stop. Isaac Newton did not know the mass of the sun. We came up with those calculations later. But what we did understand was we understood how gravity worked, and we understood how laws of planetary motion worked through Kepler and Newton. Go ahead. Sergey.
Yeah. So the basic way you measure distances in space is with parallax. So the idea is so we have two eyes, right? And so imagine you're looking at an object that's far away. If you close, say, your left eye, and then you like point at the object, and then you open the other eye and close the other one. It's going to look like your finger's not pointing at the object.
Two different points of view. That's correct.
And so the point is that like each eye is getting data from a slightly different position.
Right.
Okay. Now that exact same thing is going to happen in space. Because imagine you have the sun, right? And now we're orbiting around the sun. And so imagine you measure where the stars are, in like January when the Earth is here on this side. And then 6 months later, we will have orbited around and we're going to be on this side. So in like June. And so we've traveled 2 times the distance or 2 times the
188 million miles,
the sun and the Earth. Okay, and using that method, we can figure out what that baseline is.
But you'd have to know the distance of the stars behind there, right? You'd have to know.
It's quite the opposite. It's quite the opposite.
Thing.
Yeah, it's quite the opposite. You'd have to know. You would determine the distance of those stars using parallax based on the fact that you had 2 reference points that were 188
we were talking
million.
about the sun.
But no, you asked about the stars. You actually said stars.
So don't we have to know the distance of the stars if we're going to use the sun?
You said. Oh, sorry.
Okay, so what are you parallaxing the sun with?
You parallax. No, you don't parallax the sun with the stars. You can parallax the star. You can parallax the sun with Mercury. You parallax the sun with.
So how do you know
Venus.
how far Mercury is?
I mean,
you can't parallax. You're telling me I could look at a tree off in the distance and I could use parallax to measure the tree?
If I had another object around it, yes, I could. I could use trigonometry.
If you had another object around it that you knew. Hold on.
I use trigonometry to determine that. Yeah.
You need to know the distance or size of one of the other object.
Right.
And you don't know that. You don't know that.
Well,
and here's another problem with parallax. 6 months later, the Earth has moved 2.2 billion miles from where it was before. And you think that just the 186 million miles that we moving on the other side of the sun is going to show you parallax when we move 2.2 billion miles in another direction and there's no parallax anywhere else?
Are you talking about the movement of the solar system? I'm talking
about the movement of the solar system, which is independent of everything else in the galaxy.
It isn't. So we're rotating inside the Orion arm of the Milky Way galaxy, which is all rotating around the center of the Milky Way galaxy at the same rate. So it's not quite independent.
So none of those. Everything's moving together. So there's no parallax there. But just moving 6 months apart, 186 million miles, we can see parallax. You're saying that you can know the size or distance of the sun by measuring the parallax on an object that you don't know how far it is.
Sorry.
Hold on, I'm finishing.
Yep.
You don't know how far it is or how big it is. That doesn't work, and you have to admit that.
Okay, so one of the issues is, I heard Jaron wrong because I thought he was asking for the distance to stars, and that's what I was using.
You would need to know it in order to do parallax, because if I'm measuring the parallax of something, and the second thing is 10 feet behind it, or 10 miles, or 10 million miles, I'm going to get a different amount of parallax on each one of those. So I need to know where it is in order to use parallax to measure it.
Okay, so I will tell you when it comes to Venus and when it comes to, we've sent probes to Venus and landed. Now, okay, empiricism. You guys don't believe there were any probes. You don't believe that the Russians landed the probes on Venus. You think all that is fake. I get it. But from our belief as Globers, by the way, I didn't want to make this a debate. I wanted to present our side and your side, and then people can sort of decide. We've actually landed probes on the surface of Venus, and they melted very quickly because Venus is 900 degrees Fahrenheit on the surface. And so that in that way, we do know that Venus is about 98% the Earth's mass. The moon is about 2% the Earth's mass. And from those things, now we can use parallax in order to determine the size of the sun in modern times. But before that, we had a pretty solid understanding of the size of the sun many thousands of years ago. Hundreds of years ago, we definitely
Newton didn't know 400 years ago.
But that's okay. Hold on. Newton was not an astronomer trying to determine the size of the sun. That wasn't his intention.
Neither was anybody else. Nobody else came up with it.
So that doesn't make the sun not have a mass. Like, I understand what you're saying, but that doesn't make the sun.
Doesn't have mass.
I'm saying that doesn't make the sun 32 miles across and 3,000 miles up. He certainly would. Isaac Newton certainly would not have said the sun was 3,000 miles up.
You just said in passing that we've known it for thousands of years. But if Newton didn't know it, so we didn't know it thousands of years, or else Newton would know it.
Again, it is not one contiguous. It is not one. Okay, first of all, because Newton didn't write it in Principia does not mean he didn't know it.
No, he says flat out the sun could be anywhere from 3 million. No, Copernicus thought it was 3 million. He said it could be anywhere from 10 to 50 to 90 million, and it will do us no matter what. We'll do fine with it no matter what.
90 million miles away. 90 million miles away.
Yeah.
Okay, got
Correct.
it. What, that's 90 million miles is still kind of close to 94.
Your point that we've known for thousands of years has just been negated.
Okay, well, my point is it's not 3,000 miles away. Did we have exact measurements?
Copernicus thought it was 3 million. So how did he think it was 3 million? That's way off.
I don't know. I wasn't there with Copernicus.
You think it's 3,000 kilometers?
We don't know. We don't know where it is. We don't know how big it is. We don't
closer to us than he is to you. Anyway.
Go ahead. Keep going, guys.
No, and then you make the claim. You know, we've landed on Venus.
Yeah.
What proof do you have of that?
Yeah, absolutely.
I mean, if you look at it
empirically, I have no proof.
Okay, empirically, there's no proof of any of these landings. And I'm just trying to show you you guys believe we landed a rover on Mars recently, right?
Yes.
And it had a helicopter that can fly in 1% atmosphere. You guys are pilots. How come we can't fly a helicopter to the top of Mount Everest, but we can fly a helicopter on Mars that has 1% atmosphere? We can also
It's a great question.
open a parachute. We can open a parachute in 1% atmosphere when we do a high jump like Felix Baumgarten, whatever his name is. His parachute wouldn't open until he got to like 50,000 feet or something.
Sergey, do you want to take this or me?
Wait. But here's the thing. What I'm showing you here is the only proof that we landed on Mars. This is what NASA showed us live. Okay? I didn't edit this. Actually, I cut out a couple sections just to make it a little faster because this is what they showed us. You guys can't honestly say that this is proof of anything. You know, Cartman, Kyle, and Kenny are laughing at this because it's ridiculous.
Okay, so
this is the only proof that we landed on Mars
because it is a digital rendering. Because there's no cameras on Phobos and Deimos to take pictures of the landing. You're correct, but because that doesn't mean it's not real. And so for you to use the word ridiculous is not exactly scientific. You're just throwing stones at people. So here's the first thing. Second of all, let's go over the other part about the helicopters and the landing. For as far as the parachute thing was concerned, in 1% atmosphere, if you're going fast enough, and they were traveling at a tremendous speed downwards. When they landed, the entire crate where the rover was completely covered in like protection. I can't remember, balloon type packaging. And when it hit the ground, one of their concerns was it was going to destroy the vehicle. It wasn't a soft landing. This thing hit. The other thing is, hey, Sergey, what is the gravity on Mars compared to the Earth?
38%.
It's 38% the Earth's gravity. That's the other reason why this whole thing happened. So yes, you're right. It is 1% the Earth's atmosphere, but that's the reason why. As far as the helicopter thing is concerned, when you only have 38% the Earth's gravity, and you can create enough force for an object that is light enough, you can get off the ground, i.e., drones.
Michael,
so it is possible to do this.
Michael, so you admit that they showed us a cartoon. Now, what if the data came back?
How could they show us? How could they show us anything else? How could they show us anything else?
I'm just saying, just throwing it out there, and there's no answer. What if the data said that it crashed? Did they have an animation of it crashing?
Hold on.
Wait, here's something else.
There were many probes that crashed.
There were many probes that crashed.
I remember being like heartbroken as a 15-year-old, seeing the crash, and I'm trying to think in 1999.
I get it. Think about, they do crashes all the time. It happens. This is from NASA's website. This is from Greenland.
Okay.
This is from NASA's website, and they always get a little selfie. It gets a little piece of a solar panel or the edge of the rover. This is from Greenland. NASA's lying here. This is not from.
So here's the problem. Empirically, I don't believe you. So you're telling me you don't believe in what in the photos that were taken by that Russian lander in 1975 on Venus, and empirically you don't believe in them. You believe that those are fake. I'm going to do the same.
Wait a minute.
Thing
Hold
to
on
you.
a second.
I'm going to do the same thing to you, Dave. I don't believe you.
Michael, hold on. If I prove to you that this is from NASA's website, do you think that this is a faked picture of Mars?
But you'd have to also prove to me that the other one's from Greenland, and that is not a rendered picture where you change the color of the landscape to green in the background. You use like a very simple procedure to do in Photoshop.
It's the other way around. They took out the clouds and made it a sepia tone.
Again, empirically, you were saying that. So I'm going to use the same method with you. Empirically, I do not believe that what you're showing me is that NASA did both. Okay, and by the way, even if they did, it doesn't make the Earth flat. It doesn't. So that's the issue with that. Like the empiricism argument works both ways.
I'm just trying to disprove NASA. Once we discredit NASA, once I show you that if NASA's faking things in space, you can unwind it all the way to, they never went to space. Once you understand that, then you can't use NASA as a source, because you said we've landed crafts on Venus. Well, who told you that? NASA told you that.
The Russian Space Administration told me that. It was not NASA. Also, it was the Indian Space Administration that was able to film the lunar lander from Eagle 1, from Apollo 11. It was not NASA who filmed that. So while you want to go into the NASA conspiracy, let's include the European Space Administration. Let's also include the Indian Space Administration. Let's also include the Russians. Let's also include the Chinese, and let's also include NASA. Let's put them all together. Let's make sure they're all lying psychopaths. Let's make sure the conspiracy encompasses everyone.
And nobody said they're all lying psychopaths. You said that, so that's called a straw man.
Okay.
Wait till we make a argument, and then you can comment on that rather than make up arguments over
it. Okay, got it.
And then here is China landed on Mars the other day, and this is what they showed us. Now, again, I'll use your argument. Well, they showed us an animation.
Yep.
This is the only proof that they landed on Mars.
How else are they going to show this? How else are they going to show this? They don't. They don't
put a camera.
Where's the camera? They don't. There's no lander. This is the first time they landed on Mars.
Let me finish.
What about the skyhook footage from
Let me
NASA?
finish.
Let Dave finish.
Let me finish. Okay. You guys are talking over us a lot, and it's very difficult to make points, and we don't talk that long. So what I'm showing you is you believe in all these other space agencies. What if they're all run by the same group? What if the division of countries, our entire history, is all made up to divide us? Because this is something we will agree on. They're dividing us. They divide us by countries. They divide us by religions, by sexes, by political parties, by sports teams, by genders. They're dividing.
Sure.
They don't want us coming together. So again, when you look at all of the logos from all of the space agencies, they all have the same symbolism in them. They're all made with the vector symbolism, okay? And when you look at it like, that's interesting. I'm not saying it's proof of anything. I'm just saying it's very, very interesting.
Honestly, this is the most optimistic thing that you've said.
We're hunter-gatherers.
This is the most optimistic thing you've said. So, like, according to you guys, the Cold War was the Russians and the Americans working together to both convince us. Like, honestly, this is like world peace that was created from this lie that you guys believe is round Earth. The Russians, Nikita Khrushchev and John F. Kennedy were buddies this whole time, and this whole thing was made up. Like, this is actually, if what you're saying is true, this is probably the most positive thing I could ever imagine. We avoided thermonuclear disaster because we all needed to be on the same page to create this round Earth. Man, this is incredible. This is honestly, this is incredible. Like honestly, I'm like utter optimism for this. Go ahead, guys.
I was going to say though, when the America won the space race, right? Do you think that that's the story that's told in Russian schools?
No, it absolutely isn't. In fact, most Russian people do not think we landed on the moon. About 70% of people in Russia do not think we landed on the moon.
Right. So both nation gets to tell their people what the story that they want, right?
Correct.
So
absolutely.
Russia gets to say we were first in space, we had the first woman in space, the first dog in space, we did the first orbit. But the Americans decided to go to the moon, and they're idiots because they didn't find anything there and wasted a bunch of money, right? So it is weird that no shots were fired during the entire war. So, I mean, you're making it sound like it was some crazy battle, but there was 0 bullets ever fired between Russia
and during World War II, I believe Ford Motor Company made equipment for both sides of the war. They fund the people that rule this world fund these wars. They use them to depopulate the world. They use them to get us to kill each other. They use them to build the military-industrial complex, which is coming in very handy right now.
Got it. Okay.
So all of this is all made up.
Can I add a little bit of context to the whole Ford thing? So actually, yes, the guy, the president of Ford, I can't remember his name at the time. He actually was a supporter of Adolf Hitler at the time. So yes, some of the equipment did go over there, but it wasn't because the United States was trying to support the Nazis beforehand. So let's put a little context to there. The guy was a fascist, and then he did help both sides. I totally agree with that. But that doesn't mean. And by the way, I'm with you on the military-industrial complex and all this kind of stuff, and us wanting to spend money for this. I'm with you, but that doesn't mean that all wars were sitting there that were completely fake. And to your point, there are a couple of Russians in Afghanistan that were supplied U.S. weapons that will disagree with you about this whole idea that there were no shots fired. And there are several U.S. service members.
No, I'm not saying there's no shots fired. I'm saying in the Cold War.
He said in the show. He said in the show. I'm talking about Afghanistan in 1983, and then I'm also talking about I'm also talking about Vietnam in 1965 to 1975. There were plenty of shots fired that where we had Soviet weapons that were supplied to the Viet Cong. So yes, these were proxy wars, but this was a Cold War. Why it's called cold instead of hot is because we're sort of passive aggressively attacking each other in different places.
So what about the fact that they brought the Project Paperclip, which is a story, I believe, and we brought over Wernher von Braun as to run NASA. You're aware of that, right?
Of course, yeah, I am aware. But okay. Here's the part where you start talking about Wernher von Braun was a Nazi, and yes, technically he was a Nazi. No one held any sort of voting or political power or was able to eat or live a normal life in the late 1930s in Germany without being a Nazi. Okay, that does not mean he hated Jews. That just means that
that's the point I'm going at.
Okay,
not what I was saying.
Okay,
Sharon, you want to say something?
Well, I mean, he did supervise killings of slave labor. Right?
Got it.
He every day saw people hanging.
I'm not saying he was a great guy, but I also am saying that the alternative for him was to become the slave laborer.
Yeah. All right. So that's not where I was going with this anyway. Wernher von Braun in the 1950s wrote a book called Project Mars about a group of people that went to Mars to populate it. And that group of people was run by a guy named Elon. That's a weird name, Elon, going to Mars. This is Elon's ship going to Mars that he's planning on taking people to Mars on. And he tweeted a couple months ago that he wants to redesign it and make it pointier.
Yeah.
This is called predictive programming, just like Arthur C. Clarke.
That's a joke from The Dictator.
Yeah, that's a joke. That's a joke from the movie The Dictator with Simon Baron.
Yeah, whatever. But the fact that he wrote a book about an Elon running, taking people to Mars is a little bit too much of a coincidence for me. Doesn't prove anything. Right. Just a coincidence.
But it's even more wild because think about what was the original prediction for who would go to the moon first, right? This was written like 100 years before they actually went to the moon. I think in the 1800s. And it was predicted that the Americans would do it, and they would launch from Florida, and they would land in the ocean.
There would be 3 people.
Yeah, there would be 3 people, and you can go wild with this. Even further back. You don't have to restrict yourself to the 1930s.
Hey guys, I'd like to move on to eclipses. Is there anything else you guys want to talk about this? Because we've already gone 52 minutes on this one thing here.
Well, real quick on the Galileo thing, I heard you the other day saying something about Galileo was put on house arrest. He lived in a castle and he was blind.
Listen, I'm not saying that Galileo didn't live. He was nobility, but it was like the Catholic Church wasn't like, hey, that was a great idea. And I'm sure he didn't prefer being on house arrest. And they did not forgive him until 1992.
Yes. Well, he was gone by then. So I mean, I
Yeah,
get what
yeah,
you're saying.
he didn't really appreciate it. Yeah,
The story that they always tell is that he got house arrest and he was jailed, but he was blind and he was old and he lived in a castle.
Well, what about
He had servants.
Giordano Bruno? He didn't go on house arrest. They filleted his ass. What about him?
Yes, no, I certainly don't stand behind the church's decisions.
Yeah.
Definitely not going to get me on that one.
Yeah, but he believed that there were other worlds and possibly aliens on those worlds. So that he was filleted for that. So yes, I mean,
Right.
the point is, there's the stripper at the Rhino who's listening to this podcast right now. She's not like following us along with some of the historical stuff. So if I'd like to get onto eclipses, if there's something else about this we can come back to, or do you guys want to talk about anything else when we talk about the shape of the Earth?
I guess the one question would be like Werner von Braun, though. Do you take that as like an acceptable thing? That what we did bringing him over, or do you think like today he should be tried for war crimes?
Right. I think personally, I think Jamie Dimon should be tried for crimes. Like I don't know. Like it's a tough call. I don't know if it was necessarily the best, but I do know this: if he did, and again, according to our model, come up with the engineering for the Saturn V rocket, which he is credited with, and that Saturn V rocket allowed us to get to the moon. Which again, I know you guys don't believe that actually happened, but if that is the case, then it in someone's mind it was worth doing. That's the only argument I'm going to make for that. Okay, that's it.
Okay. Whether or not it's the right thing to think, though.
Well, again, the right thing to think does not make the Earth flat or round. That's the only point I make. And my argument is we did go to the moon. Your argument is that we didn't. And so my argument would be based on the fact that we used a Saturn V rocket in order to achieve 11 miles per second in order to get outside of the Earth's gravity in order to get to the moon. So if that is the case, he was necessary for that. Do I know that this man necessarily thought that the Aryan race was the superior race? I don't know enough about Werner von Braun to know that. But what I do know is that he did have the engineering capability in order to do these things, but I don't think that makes the Earth round or flat.
Before we go to eclipses, do you know the SR-71, right?
Very
the
well.
SR-71.
Not only do I know it, I was stationed at Robbins Air Force Base and refueled one of the last ones. Yes. Did you ever fly one?
Did not
fly one, but we refueled one. So one of the problems with it is that the fuel tanks were so fucking big, and they changed once you got up to altitude, that the thing actually leaked ass tons of fuel. They had to completely resod Robbins Air Force Base because so much JP-8 flowed out of the back of that.
I'm aware, and because it expands because it gets so hot.
Yes.
Why does it get so hot?
It's not just that it gets hot. It's also there's very little air pressure once you get to 100K.
Right. But it gets to over 500 degrees, we're told. Is that true?
Yeah, I'm guessing. I don't know exactly what how much JP-8 burns at that altitude.
What I read is that the skin of the. I'll wait till you come back.
Go ahead.
What I read was the skin of the SR-71 gets over 500 degrees, and that's why there's no paint on it. That's why it's so aerodynamic. It's pretty aerodynamic when you look at it from the front.
I would think at certain points going through the stratosphere, it would maybe get hotter. I don't know about 500 degrees.
Okay,
but
so
once it gets up super high, I don't think it's
Let me make my point. Let me make my point. So why is it able to go so fast? Better than that. Why can't a 747 go that speed?
I'm going to leave that up to Lieutenant Butel. Why is it that a 747 can't go the speed of the SR-71?
I mean, a 747 is optimized for fuel efficiency, not speed. And also it's not going nearly at the same altitude, where at a higher altitude, the air density is going to be less, which is going to allow you to go. So it's going to allow you to go much faster for the same true airspeed or indicated.
What about if we can get a 747 up to that height, we can give it an infinite amount of fuel? Can the design and we can give those engines an infinite amount of power? Could it go Mach 3.2?
If you had the same engines and the same, like, probably not with that aerodynamic profile, but the engines are completely different. A high bypass.
That's where I'm getting
bypass
at.
airliner is more fuel efficient, but it's not going to go as fast.
It's not right. He's not shaped correctly for 747.
It's not shaped correctly. This is my point. It's not shaped correctly to go that fast. Could it go twice that speed, Mach 6.4? Absolutely not. I think we can all agree on that.
So a 747
with infinite power, with infinite fuel, it's not aerodynamically shaped to go that speed.
To be clear, if you can get high enough, you can make that thing go supersonic.
Yeah, if you can get high enough and you get outside of the Earth.
So supersonic is 700 miles an hour.
On the surface,
3,000 miles an hour.
on the surface of the planet, at sea level, it's 700 miles per hour. It's 660 something on the surface. Hold on,
whatever.
Let's go back.
3,000 miles an hour.
I flew a Boeing 707. That's what KC-135 is, and our wings are kind of tilted back like this for lift. And same thing with a C5. It's tilted back even more. He flew an F-18. What are the wings like on an F-18?
I mean, they're
a barn door, basically.
Yeah.
Yeah, they're flat and they're just plain in one level like this. So they're aerodynamically. So the problem is, as we increase the coefficient of lift with the same amount, with the same body shape, we increase also drag. So that's the reason why. But what he said is correct. Once we get to a certain altitude, then all of a sudden that drag doesn't work anymore. And now we're just pushing air out the back. But of course, we can't do that because we need oxygen to go into the engine and then create combustion and then push something out. Just like the.
That's not where I'm going with this.
Okay.
That's not where I'm going with this. All right. So at this high altitude, thin air, the thing heats up. I'm told that it expands up to 6 inches, and that's why they have the loose fitting panels. So look into that. Whether that's true or not, I assume it's true because it's coming from the Air Force.
Yeah.
So it's super slick. It's like a razor blade. It's cutting through the air. It has the minimal wind resistance, unlike a 747.
Yes.
You know what's less aerodynamic? This hunk of junk. This thing goes 10 times the speed, and that's when it has the external tank and the booster tanks on it all together. And if you look at it, there's PVC running down the side. There's mounts that are flat, not pointy. They're literally like this, okay? And this thing is going 17,000 to 25,000 miles an hour through our atmosphere, and somehow it can do that. That's magic. And then the other problem is when this thing's coming back in, they say it comes in. What, Jaron? You know the speed that it comes in at? It's like 10,000 miles an hour or something.
Sure.
Whatever speed it comes in at, the panels on the bottom have to, they're like, oh my God, one of them exploded because one panel was missing.
Absorb the heat.
Yeah,
correct. Yeah.
Absorb the heat. But on the way out, when it's going 25,000 miles an hour, it doesn't need to worry about the panels.
Okay, so
this is all nonsense.
Right, so let's talk about that. That's a great thing. So I'm going to let Sergey Dida go to this first part. Dr. Dida, we talked about this. The escape velocity for the planet Earth is 11 miles per second. And why is that number false? Do you remember we talked about this on our interview?
I mean, for the rocket to launch, it basically has to punch through the atmosphere.
Yes.
And then once you're through the atmosphere, and the density is low enough, then you actually just want to start going horizontally, and then just build up enough speed so that you can reach orbit.
Yeah,
and the way to think of orbit,
orbit is 17.5. So these are two different things. Orbit is 17,500 miles an hour. You don't even go anywhere near that speed inside the atmosphere. That's number one. Number two, the atmosphere of dense air is 60 miles going up. Going up, you are receiving less friction as you increase altitude because you have less air, less air density. So your answer about the panels, that's the reason why you're getting, as you increase speed, you incur less resistance. On the way down, as you decrease speed or you decrease altitude, you incur more resistance, and that's the reason why you need those panels. But as far as the speeds are concerned, you don't get to 25,000. 25,000 is like you're leaving the leaving the low Earth orbit at that point. Once we get up into space, and then once we get rid of the two fuel tanks or whatever, and it's just the shuttle by itself, then we're going to the second one. We're going to increase to 17.5, and then that's when we're gonna find orbit at that point. I hope that answers your question. That is our as an amateur astronomer, that's our answer for that question.
Yeah. So the acceleration going from 0 to 200 miles an hour in 5 seconds is pretty good. I don't know what the exact G-forces is, but it's pretty pounding on the body. And with the amount of time that the shuttle has engines burning to get up to 17,500 miles an hour, I believe it has to go faster than that to get out.
Of course,
that would be
no. It doesn't have to go faster than that to get out. It just has to keep going up.
Whatever it is.
Yeah.
At 17,500 miles an hour, for the burn time on some of these rockets, I believe the shuttle, it has to increase 200 miles an hour every 5 seconds. Okay, 200 miles an hour every 5 seconds. And when we watch a shuttle go up, it goes up, it rolls on its back, and then it goes parallel with the ground. And they say that's because it has to gain speed to get out of the Earth's orbit.
Yes.
I get it. But if you count, okay, let's say the first 20 seconds doesn't count because it starts off really slow. But after that, now it has to make up that time. So it's going 200 miles an hour faster every 5 seconds. We are going to hit that maximum airspeed in no time. Okay, long before we get out of the atmosphere, and if you watch this thing, there's so many problems with it. And if you just Google launch of the space shuttle, this actual video will come up. And there's so many problems. One thing I want to point out here is this thing is 4 million pounds shooting out superheated thrust. Now, superheated thrust, 4 million pounds, and that fence doesn't get mangled. I've seen tornadoes tie fences in knots, 300-mile-an-hour winds, not superheated. But that's 4 million pounds of superheated thrust. I'm going to just talk for another minute, and then I'll throw it back to you. Right? And nothing is getting affected. This is just smoke coming out of the ground. Now, here's the problem. This thing,
I thought jet fuel didn't burn that hot.
Well, let's just say it's room temperature. Let's say it's not hot at all. Okay.
So is jet fuel hot enough to burn to melt steel?
I'm not talking about. I'm talking about the
sorry,
wind.
Hey, don't do that to him right
speed.
now. Don't do that to him.
I saw where he was going there. I'm talking about a tornado will splinter a tree. Will splinter a telephone pole. Will tie a signpost in knots, and nothing happens there with. It's way faster than 3,000 miles an hour, or 300 miles an hour. Thrust coming out of there. So wait, hold on. Let me just point something out here. So if you watch just there, that's the release of these external rockets. One, they're still have thrust. They should shoot away, and they shouldn't be able to go sideways at that speed, non-aerodynamic. But the problem with this is it's 30 miles downstream. If it was only 20 miles down, you wouldn't hear that sound for 90 seconds after you saw it. But we hear it and see it at the exact same second. Okay? That shows you that NASA's lying again, right? This is what they show you, and you hear it and see it. And the only explanation that you guys can come up with, well, they edited the sound in there to make it seem more realistic. And they need to do that because it's not very realistic at all.
Yeah, I mean, I honestly don't. Go ahead. Sorry, go ahead.
I think as like a broader point, this just completely illustrates like Arthur C. Clarke's famous quote that like technology, when it's sufficiently developed, just appears like magic. And I think that kind of like summarizes it. It's like you're just like, how the hell is this possible? How is this like rocket burning this super hot fuel? How's it going so fast? This must be like magic.
I'm interrupting you because we see it and hear it at the same time. That's not wow, magic. Magic doesn't answer that. Magic is the only answer for it, actually. But we see it and hear it at the same time.
Video editing.
It's not 20 miles downstream.
Video editing.
So video editing.
Could be.
You're seeing and hearing it at the same time as on video, though.
How about this? This is being filmed by the guys on the shuttle on their way into orbit. They're going up at 17,000 miles an hour, and this 40,000-pound steel tank is falling back to Earth, and it's going to burn up before it gets to the clouds.
So it's not falling at that point.
Oh, it's just going sideways with that little handkerchief. Did you watch that handkerchief go by? It's barely moving.
So let's do the math on this one. All right. So now let's say we are moving at 17,000 miles an hour at this point, going this way. That's 17,000 miles of lateral momentum that we have, and then all of a sudden we release it to gravity. Gravity is 9.81 meters per second squared, and we're moving laterally at 17,000 miles an hour, which means it's going to take a little bit of time, a few minutes, and we can film it while it drops off. Off and slowly goes back towards the Earth. But in the meantime, it's still that 17,000 miles. And by the way, almost no air friction at this point.
Hey, Mike,
go ahead.
Mike, it doesn't matter whether if you believe that this thing can go through the atmosphere at 17,000 miles an hour sideways.
No, not through. Once it gets outside the atmosphere, it goes 17,000.
Okay, it's not. This is not in the atmosphere. Look how close it is to the clouds. It's not outside the atmosphere. I've been higher in an airplane. Hold on, let me finish what I'm saying. I don't care how fast it's going. If you drop a bullet and shoot a rifle at the same time, both are going to hit the ground at the same time because they're falling. So this thing should be falling. Like if I was on a 747 and I threw a Mack truck out, it's just going to fall down so fast it's going to be out of sight like that. And this guy's filming it on his way into space.
And you see it is falling, and that's the first thing. And the second thing is when you're going on a 747,
I don't see it's falling.
It actually he's zooming in. If you watch it here, you see how it's getting less and less. Hold on, stop. I'm a videographer. You see how the image is getting less and less steady? It's because they're using a zoom lens, like probably a 1720 or a 7200 zoom lens, and they're zooming close. Do you see how it's getting more and more unsteady? That's the reason why that is because it is falling away. That's the first thing. Second thing is a 747 maybe is going 420 knots, and if you drop the fraction of 420 knots compared to 17,000 miles an hour is
doesn't matter. They both fall at the same rate.
They fall at the same rate.
But your example is not correct though. So you said, okay, let's compare dropping a bullet and firing a bullet. Let's just if you fire the bullet horizontally, right? But what if there's already some vertical motion, right? It's more like shooting a gun up and versus dropping the bullet down.
Oh, I agree with that. But this thing is going the same speed that they're going. That's how he's keeping it in frame, and it should be falling at 1,000 miles an hour.
They still have a booster going.
Yeah, so they're actually speeding up faster, and somehow they keep it in frame.
This is awesome, though. We're going to get to see it burn up here in a second in the atmosphere. It's going to be cool.
Yeah, it's not even smoking yet.
I don't know that part is actually released outside the atmosphere, though. I don't think it
It's not. But the story is it burns up before it hits the ground.
I think the last piece burns up. I think those are the original boosters that don't burn up. I think the last piece, the large part that's attached to the actual SDS, I think that's the part that burns up. I don't think the part that you're showing me is what's supposed to burn up.
Yeah, I thought I've seen video before of that thing on some barge or something, but I'll have to check that.
Yeah, so I think you're actually showing me a video of the original launcher. The other thing, Dave, I'm going to tell you is that as a videographer, once an object gets further away from me and I start using zoom, you're going to start seeing less steady focus on it, and that's what I see there. That to me looks like they're zooming in on an object that's falling away. But that's my interpretation as a videographer.
Disagree on that.
Okay. Cool.
Just another quick question on the space shuttle, on the International Space Station itself. Don't you think they should have built it on Earth and tested it first?
No, they can't.
And don't you think it would be the most filmed construction project in history? Because Mission Control would need to see what's going on.
Hey,
and there's not a single photo or video of it being built.
Sergey, do you want to take this one? Why is it that you can't build the ISS on Earth?
Well, forget that. I'll go with you. You can't build it on Earth because the structure doesn't work with gravity. Fine. What about?
No. It's too heavy. They had to send it up in pieces.
That's fine. But what about? Why is there no video of it being built?
Because it was built in
you
space.
Mean like building the individual modules,
like putting them together?
No. Because they had to build it separately because they didn't have the launch capability.
No. I'm saying when a new module goes up, the astronauts aren't going to do it on their own. Mission Control is going to be like, all right, Johnny, move it to the left. Turn it this way. Connect this clamp to that clamp.
I think Johnny's using the Canadarm.
There's nothing. There's no video.
You're saying there's no video of them attaching. You're saying there's no videos of the modules attaching. Is that what you're saying?
Or the very first thing. What did they do first? They must have set something in space first.
Well, I mean, there's nothing. Again, going back to the Mars rover thing, because the Mars rover is dropping, and that's the first thing. There's nothing to film the Mars rover. So the first module in space has no. I don't think it has a capability of filming itself. Maybe it didn't. I don't know. The ISS.
What dropped it off? Why couldn't it film itself? I can go outside and film myself.
But I have seen video of the Hubble coming out of the SDS. So I don't know that that's necessarily proof of anything. I don't know. Again, guys, I can't tell you because I'd have to go Google it whether or not there's any video of attachment of the ISS. I'm having a real hard time believing there is no ISS. I know you guys are going to come up with some reasons why because I know it's very inconvenient for flat Earth. But go ahead.
No. I mean, we can scientifically prove that the light that we see across the sky is not the ISS.
Okay,
I mean, it's too bright. It's movement. Like we can watch it here in Connecticut. It'll take 8 minutes to go from horizon to horizon. Well, 8 minutes, it should be in California already, but people in Ohio can't even see it. Right, and then also the brightness of it. It's brighter than any star, any planet in the sky. So how is that reflecting sunlight to my eye and not every
less than 3,000 miles away?
What?
Yeah, that's why it's not that. So a couple things. Let's get a couple things.
Hold on. Let me answer this. Let me answer this. So a 747 flying at cruising altitude is literally the size of a pencil eraser held at arm's length, and you could barely see it. Okay, double the height. Scientifically, you can prove that its angular size is too small to see. Okay, well, the ISS is 50 times higher and about the same size. 50 times higher. Its angular size is impossible to see with the human eye. That's scientifically provable, but you'll just say, oh, well, it's reflecting light, and that's why you see it. That's nonsense. That's not scientific.
No one's making an argument that you can see the size of the space station. You're seeing the glint of light.
You should not be able to see it. You should not be able to see it.
Like search and rescue missions, you can see a signal mirror from miles and miles and miles and miles and miles away, even though you can't see the object itself.
Yeah, because you're reflecting the actual sun with a mirror. Is the ISS a mirror?
So, but no, it would have reflective qualities up in space, especially up in a vacuum where there's no air around it. But
how is it reflecting sunlight directly to my eyes and everyone else's eyes across the entire path of its view?
It's not always. First off, it's not always reflecting sunlight. Like,
well, how come it's the same brightness? It goes by
stop.
brighter than it looks like a piece of the sun.
You have solar panels and you have all sorts of surfaces oriented different directions.
Yes. Solar panels don't reflect sunlight.
You're going to get a glint from something.
Yes.
All it needs to be is a glint. It doesn't need to be a mirror.
Let me ask you a quick question. Let me ask you guys a quick question. How come when they show us the ISS looking down on Earth, most of the time we don't see any land? How come there's no continents?
Sometimes you do see land. Well, can we go back to a couple of things that we talked about?
I'd like an answer to this.
Can you wite that down? And I promise you, because you asked like 6 questions. So let's go back to the other questions.
You don't want to answer that one?
No, I promise you we will. Sergey, did you talk about the inverse square law for light? I asked you about that before? Did you have an answer for that?
Go ahead.
No, it's fine. It's fine. Don't worry about that. Okay, so the situation when you are up there in atmosphere, you are getting direct light without the ozone. So the light that you're receiving is very much greater than a 747 inside the atmosphere. That it has much of the light that is being broken up by ozone O3, which breaks up.
I'm talking about the light coming off of 747. I'm talking about the angular size.
Yeah, but you did mention we can't see the 747, but we can see.
No, I'm talking about the angular size of the 747.
I
double its height.
Have to resolve it, though.
I apologize. I misunderstood. But the point I'm trying to make is like the idea. What was the other thing you asked? You asked something and I had an answer for it, and I can't remember. I can't remember right now. But I don't know. We keep going, man. I promise you, when I remember here in a second. Go back to the thing you were asking.
You're making the point of what on the space station reflects light, and it's literally made of all sorts of different metals and everything. And when you're going to make the claim why can we see the moon reflecting light when that's basically rock? Like a space station made of metal, you're going to get glints of light from it.
Well, actually, that is kind of my point. Also,
I'll agree with that. We get glints of light, but when we see it,
I remember what I was going to say. It's not brighter than Venus, and it's not brighter than Jupiter. That's what I was going to say.
I saw it. It was brighter than anything in the sky. The sky was still lit. It was the sun that just. Almost just set, or maybe it just set.
Okay.
The sky was still blue, and I saw this thing go by, and it looked like a piece of the sun. It was that bright.
Yeah,
and so glints is the right word, because you get a glint, right? As it reflected the sun. You wouldn't get a steady reflection. Like you can't drive down the road in a car and use a mirror to reflect in someone's eyes unless you have a really steady hand. Right, but then you can only reflect it in the one person's eyes, not all of the other people on both sides.
Those are rounded surfaces, and they are white, and they are exposed to pure sunlight without the atmosphere.
And have you watched any spacewalks that are done in daylight? They're not. It's not bright like that. It's not reflecting light. And then you have to remember the inverse square law of light. No, it's not. You watch these spacewalks; they're absolutely ridiculous.
The ISS
they're absolutely ridiculous,
is the brightest thing in the sky. Well, I mean, the third. After the sun and moon.
Well, no, it's not brighter than Venus. Guys, I'm not gonna. No, I'm gonna win this one tonight. Okay, tonight when if you want to go see sunset or sunrise and you see the planet Venus, you will not see the ISS anywhere near the luminosity of Venus, and it's not even close to Jupiter. It is not brighter than Jupiter or Venus, and it's not brighter than the moon either. So
I'll look it up.
Okay, we will. No, it's not look it up. I'm an amateur astronomer. I look at it every night, and I try to look at the ISS. To be honest with you, I can't really see it with the naked eye. The ISS is kind of maybe where you guys live. I live in Las Vegas. Obviously, it's the brightest fucking city in the world, but I can't see the ISS. I can see Jupiter and Venus every single night.
Oh, you'd be able to see it.
Okay, well, I'll try to. I've tried a few times and I can't really see it. Maybe if I go up to Mount Charleston, but I disagree with you. Now, here's the thing: I don't care. Like it's fine. I understand that you guys. The problem is the empiricism, right? You guys don't even want to start with the existence of the ISS even being there. So us having this argument where like I'm doing Brazilian jiu-jitsu and you guys are doing kickboxing. We're not even like arguing on the same plane of existence at this point. I do believe the ISS exists. I think there's plenty of proof for it, but I also believe we landed on the moon in '69. So we can go into that. Keep going.
Did you know that there was 5 shuttles launched at the same time? There's proof right here. Amateur. These are amateur videos.
That doesn't necessarily mean that those are shuttles.
No, these are 5 shuttles at the same time. And they're letting go of their tanks right here.
I believe
this is absolute proof, because
I believe those are missiles out of Vandenberg Air Force Base.
No, there's not. These are people. These are ISSs, 5 of them at the same time with people on them looking down at the Earth.
Aren't you having your cake and eating it too, though, when you're telling us that these videos are proof, but then discounting our videos?
Well, what I'm telling you is you're totally missing the point. Look, you can see there's one, there's another one, and there's a third one, and there's 2 more. What I'm showing you is this is stuff that you guys believe. We don't believe this. This is fake as fuck.
Okay, so before we go into this, Dave, because you got Mr. Kelly up there, and you're going to show the video where.
But notice that he started to show you something that completely is fake, and you started to make excuses for why it's real.
No, I'm not making excuses for why it's real. It's just I've heard.
You said, "Oh, I think those are missiles. I think that they're this. I think that you just wouldn't even take the step of, oh, maybe that's just a fake video." Right, which it is. It's just, there's no 5 shuttles that have ever gone up. Somebody with a VFX program made that.
Maybe, I don't know, but I do know that there was missiles that came out of Vandenberg Air Force Base that people thought were UFOs. That's why I said that, and also Vandenberg's right. Yeah, that's essentially why I said that. But going back to the other thing, keep going. I don't want to interrupt you. Go ahead. No, but to your point, Jaron, I have to be intellectually honest. I've listened to so many of you guys' podcasts. That's why I'm preempting these things. It's not because I'm trying to just not let you speak. So I apologize. Go ahead.
Thank you.
Yeah, no problem.
Can I go back to why we don't see land? Does anybody want to say, why you believe this is the Earth? And where's the land?
It's really, again, we're going back to the empirical thing. I would have to look at all the video from all the ISS.
Does Sergey want to comment on this? I mean, is this proof that the ISS is real?
I don't.
I mean, I don't know what part of the Earth it's over.
There absolutely are videos where you can see land.
Okay, so this one doesn't show land. Is this proof that the ISS is up there, or could this be fake?
It's proof that there's a video in front of you. It's not proof of anything.
Right. So that's. Thank you for pointing that out. So this is not proof. This is as good as what the ISS shows us, but this isn't real because we filmed this. Now, how did we film this? How did we get up that high? Right. The answer is it's so easy to fake things. We're filming up, and you can't even tell that it's up. This is filmed from our front yard.
Flat Earth, like what does it help you understand the world? That's what I'm most curious about.
So much.
Okay. Yeah. Jaron, you go first.
Oh, I wouldn't even know where to start. I mean, it's just, I think, can I talk about a quote that I heard? Because I know you guys are big into science, so I'll just tell you what got me on this path.
Sure.
First of all, Edwin Hubble, if you read his quote about the expanding universe, all his observations showed him that we're the center of the universe. That's what he saw. What he said is, we can't disprove that. Sergey, you're already shaking your head. I'll show you the quote. He said, we cannot disprove that the Earth's the center of the universe. However, he says, we have to avoid it at all costs. We must avoid it at all costs. It is the absolute horror of a unique position. So these scientists back then thought that being the center of the Earth or center of the universe was so abhorrent, was so disgusting, that they would do anything they could to make sure that wasn't true. And he quoted as saying that. That's one. The second thing is George Ellis, who's a mainstream physicist, said that he can construct a physically symmetrical universe with the Earth at its center, and it'd be impossible to disprove with observations. And he says, what we're doing in cosmology is we're choosing our models based on philosophical grounds, and he says a lot of cosmology tries to hide that. That's a quote.
That's correct.
Okay. Now, when I hear that, when you hear that, when you hear that a lot of cosmology tries to hide that, how do you not have a question about your science that you've obviously given your life to or you believe in fully, yet you've just had a physicist tell you that a lot of cosmology, which is a science, is trying to hide something from you? How are you okay with that?
No. So here's the point, right?
Okay.
So imagine we are on there's Edwin Hubble here on Earth taking his measurements. Okay. And then there's alien Edwin Hubble across the galaxy taking his own measurements. Okay. Here's the point. They would have essentially the same quote, basically saying, based on my measurements, I can't,
Right, but we don't know anybody else exists. We don't know anything else exists. Just us. So you're taking a pretty big leap, right?
Those two scientists, those two observers, okay, as they would perceive, they just see all the universe expanding out away from them.
No, but you're basing that off of what Edwin Hubble said. So you're making his statement true before you're going to the next statement.
So, okay.
How do we know
Imagine the following. Okay. So we're living in a raisin bread. Okay. You're sitting on one of the raisins. Okay. And now David is sitting on another of the raisins. Okay. Mm-hmm. And we put you in the oven and we start cooking the bread.
Okay.
And so the bread starts rising.
Right.
Okay. From your perspective,
hold on, let him go, Dave. Let him go.
Let him finish.
Yeah. From your perspective, you're going to see all the raisins going away from you, right? Because you see all that dough rising and it expands.
Right.
From David's perspective, he's going to see all the raisins receding away from him because all that dough is expanding. And so if you guys if you call each other on the phone, you're like, hey, what do you see? You'd say, oh, I see all the other raisins expanding away from me.
Okay.
Okay. So then we're left with a philosophical quandary. Okay. We can basically say, okay, the raisin that I'm sitting on is special, right? My raisin's at the center of the bread.
Correct.
Because I see all these other raisins expanding away from me.
Okay.
That would be a philosophical choice. Okay. It's actually a deep philosophical choice, right?
Okay.
That's kind of like what the religious perspective was in with the Catholic Church.
Correct. The ancient conception of a central earth.
Yes. Now, the other philosophical point you can have, okay, is you can say, well, in fact, there's nothing special about our position. And in fact, the universe should be, and these are the two operative terms, homogeneous and isotropic.
Okay.
Right? Homogeneous means basically things are spread out, uniformly, like homogenized milk. And isotropic, meaning whichever direction I look, the universe on large enough scales looks the same.
Okay.
And that's a philosophical choice, right? So when you write down your cosmology model, right, you're making that choice. You're saying, do I want to study a homogeneous and isotropic cosmology? And that's the choice that Hubble made, even though he couldn't empirically prove that, it is homogeneous and isotropic,
Right.
We could be in a privileged position.
Right.
Right. Or alternatively, you could take the Christian church position and say, no, the earth is special. Okay. And in fact, we should have a cosmology based on.
So now let's imagine that you and I live back then, and we hate the church. We see the problems with the church. The church is terrible. They're doing crusades. They are on a tear. They're sending people over to the United States to basically subject these people to slavery. Okay, so we don't like them. Just because we don't like them does not allow us to then not choose that viewpoint, because that's not science. You can't just make the decision that, well, we don't like the church, and this is what science did. Science hated the church so much that they constructed their own scientific idea, and they pushed everybody away from the church. I agree with that. I don't want the church in charge either, but it doesn't make it true, right? So just showing you this, I don't know if you can see my screen, but I'm just showing you here where this is the quote from Edwin Hubble, but he's talking about, such a condition would imply that we occupy a unique position in the universe, analogous in a sense to a central earth, right? But he says this hypothesis cannot be disproved, but it is unwelcomed and would be accepted only as a last resort in order to save the phenomenon. Therefore, we disregard the possibility. So this is your science when these guys are going out there and they're making decisions not based on any evidence. They're making decisions based on their worldview. Their worldview is religion sucks. We don't think we're special. We think we're we're just out in the middle of nowhere, just flying around space. And so they basically, and then he comes back and says this, but the unwelcome supposition of a favored location, meaning the idea that we're at the center, must be avoided at all costs. This is not science, my friends. Right. This is not science. This is the worldview.
So let's talk about two different things. Go ahead.
Hold on. Let me just finish this up. So such a favored position, of course, is intolerable. It's intolerable. That's great science. Therefore, in order to restore homogeneity and to escape the horror of a unique position. So just because these guys hated God and hated religion doesn't make them correct in their suppositions of just saying, you know what, how else would this work? And somebody said, what about if we live on a raisin bread? And they're like, you know what, that's it, that'll work. Let's live on a raisin bread. That's what they did.
Well, here's the point, right? When you're constructing your model, right, of the universe, you do have to make these philosophical choices, right? And often
why not study both?
Well, hold on. Wait,
that's what you do, right? Well, you do study.
Sergey, before you go on, there's his observations, and then there's his interpretation of those observations. Those are two different things. His observation shows that these galaxies were receding away from us. His then interpretation that means he could not. It doesn't mean he proved we were the center of the universe. He said we could not disprove. He could not prove or disprove because, like he said before, with the raisin perspective, where we're sitting on different raisins in the raisin bread, I cannot prove or disprove that I am the center. What I can do is look at Proxima Centauri and Vega, and I can look at Betelgeuse.
If it was real science, wouldn't you at that point say we're going to study both because we can't make a decision yet? We don't have the proper evidence?
Edwin Hubble was not part of NASA. Like, it's not real. Like, while I'm with you that Edwin Hubble, his opinion may have been that he is not the definition of what real science is, and there's a difference between his observations and his. Edwin Hubble said some racist shit too. Okay,
but
everything is based off that though.
If you go and you decide, okay, we're going to study homogeneous isotropic cosmologies, you're going to go ahead and make a whole bunch of discoveries and predictions about what does happen in the universe.
Mm-hmm. But it doesn't make it right, correct?
No. He is saying it makes it right. He's saying he found a predictable model by doing the isotropic homogeneous.
If you have two models,
and
right,
one must be avoided at all costs.
One correct prediction, and the other one makes 10. The
What
one that
about
makes
if one
10 correct predictions is better.
What about if one it must be avoided at all costs?
It doesn't make it not true. The idea that he wants to make it avoided at all costs. You're right. If you're trying to make
you're basically saying we did study both.
Time out.
Did we study both?
If you were trying to make the assertion that Edmund Hubble did not want the Earth to be the center of the universe for his own anti-religious beliefs, I am not going to disagree with you on that.
What about all of science? What about all of science?
What I'm saying is, if there was a hypothesis where it was the center of the universe, we would try to disprove that hypothesis, and we have, because let me finish, because of Betelgeuse, because of fucking Rigel, because of Vega, because of Proxima Centauri, because of all these other stars that we can see that have, and we can tell the size of these stars, we can tell the chemical makeup of these stars.
Hold on. How do you tell the size of the stars?
Spectroscopy.
Wait, hold on. I just have to ask. So you're talking about the not Edwin Hubble, but the other guy, Martin. You're saying that he's wrong when he says he can construct a spherically symmetrical universe with the Earth at its center, and it cannot be disproved by any observation. So
I am saying
that physicist is wrong.
I'm saying that that physicist is wrong. Yes, I'm saying, like, listen. Here's the thing. If here's one thing else we could do. You ever use Steadicam, or you use a video and you can actually go in Adobe Premiere and you can apply Steadicam to it. You can make the center of that image the center of the screen, no matter where the image goes. And so, from a philosophical standpoint, like exactly what Dr. Dida said, if you want to choose and say, hey man, no matter what I learn from cosmology, no matter what I learn from science, I'm going to believe that the Earth is the center of the universe. You could do that and just say the universe sort of rotates. You could, in some weird form of philosophical way, you could say, well, yes, I mean, the Earth does go around.
It's not a weird form. It's just relativity, right?
What do you mean?
Relativity says that you cannot choose whether we're going around the sun or the sun goes around us.
Okay, that's fine. That's okay. What I can say, though, is the sun has a greater gravitational mass than the Earth, and that the Earth is affected by the sun's mass and then goes around in a circle with relative to the sun. Yes, I can say that. I can also say that the moon's mass is 2% the Earth's mass, and I can say that it goes around the Earth every 28 days. Now, if you want to say now here's what we do. Now we make the moon the center of the galaxy, and now we say now the entire solar system is rotating around the moon. If you want to make that, if you want to make that perspective, that's fine. But we're going nowhere because that doesn't prove the Earth is round or flat. Like
so, the Michelson-Morley experiment in the early 1900s showed that there's no preferred frame.
Correct.
But these people came after Edwin Hubble.
Why are you teaching students that we go around the sun if there's no preferred frame? Why would you ever teach that if you just disproved it with your previous sentence?
I didn't know.
So
the Earth does go around.
There's a difference between
but there's no preferred...
one object going around another and saying that there's a preferred reference frame, right? So preferred reference frame means that there's a privileged observer that observer, his measurements are correct, and other observers, they're not correct. They have to be taken relative to that preferred observer.
Right. So somebody on Earth can say the sun goes around them, and somebody on the sun can say the Earth goes around them, and neither one has a preferred position. Neither one can be considered correct.
So you're taking.
Wait, we're still talking. We're in the middle of a conversation here. So why would we teach children that then?
I'm confused. I don't understand what you're saying.
I know preferred position. You just said that neither person can say that they are correct. If you're standing on Earth and you're making measurements, you can't say that person's correct. And if you're standing on the sun taking measurements, you can't say that person's correct. So therefore, even though somebody on the Earth thinks the sun's going around them and somebody on the sun thinks the Earth's going around them, neither one of them are correct. There's no preferred position. So therefore, why are you teaching children?
There is a real answer. So, okay, this is a misconception, okay? So there is a real answer, right? So, okay, let's say we're both on Earth, right? And then you get on a boat, right? And you start going, right? And we wait like 10 hours. 10 hours later, right? If we can ask the question, okay, am I going away from you or are you going away from me, right? Now, if David didn't hear the little spiel I gave before, right, he'd be like, well, there's no way of me knowing, right? Maybe Sergei's on land and the land's receding away from the boat, or Jaren's on his boat going away from the land, right? But in reality, we know what happened, right? There is a history of what happened, right? You got on the boat, you accelerated, and then you were going at some velocity away from the land. And so objectively, the boat is moving away from the land, not the other way around. Okay? So what I'm trying to say is that the universe is consistent. Okay? There is a correct answer. the philosophical point I was making earlier is that there are no preferred observers, right? What that means is that if you go and you write down your physics equations of while you're on the boat, and I go and I write my physics equations while I'm on the land, okay, those two are going to tell a consistent story. And we can't say like objectively Sergey's right, Jaron's wrong. Both those descriptions are correct. And they in fact have to agree. That's the whole point of physics.
Okay.
The point of there not being any preferred observers means that there isn't a preferred frame of reference. You can't just say, oh, like my measurements are right and yours are wrong. They both
Why
have to be
are they
consistent.
teaching that we go around the sun?
No. So yeah, you're missing
Because
the point.
objectively we are.
So here's the point, right? The reason why
How can you say
How do you
that?
mean objectively we are?
Time out. The
Can
reason
we keep talking to Sergey? Okay.
Okay, hold on. So here's the reason why. So going back to what he said, because he said it twice, and you guys didn't really hear what he's trying to say. He's trying to say there is no preferred, there is no privileged. What is it? Reference or privilege? What did you say
Observer.
before? There is no privileged observer. So like you guys are like, well, there is no privileged observer. Therefore, I can say that the sun goes around the earth. Wait a second.
No, that's not
No,
what
we
we're
didn't say
saying.
that. We never said that.
That's not
I
what we're
just
saying.
asked you, why are you teaching?
Actually, Jaron, you did say that a few minutes
He did
ago.
not say that.
Okay.
Say that.
He said, "Why are you teaching the Earth goes around the sun? Why is science teaching a preferred reference frame?"
Well, in this case,
No. So that's different. It's not saying that there's a preferred reference frame. Okay. What that's saying is that objectively, the Earth is going around the center of mass of the Earth and the sun, and the sun's much more massive, and so it's much closer to the sun. So the sun.
How do you know what size the sun is? Again, you're assuming the sun is more massive than the Earth when it doesn't appear to be. I mean, when we look at the
you
sun,
can measure it by measuring what the orbital period is and Kepler's law.
No, you can't because you don't know whether
You're
the sun
taking
is
Kepler's
circling
laws.
around us. Right. When the sun being 93 million miles away is just a made up story on an assumption that we live on a ball with a radius just under 4,000 miles. But how did you get R? Where did R come from? Okay. Nobody knows. The way we got the radius of the Earth was, or because we think we're the same size as Venus and it transited the sun. It's all nonsense.
They got lucky
Okay?
though. Then it was the same size as Earth.
then we got unlucky. Then it's 98% the size of the Earth. One and number two, we got unlucky.
Well, how do
because
you know that?
Because
How do
Mars
you
is
know
much
that?
smaller, and because the Moon is 2% the size of.
How do you know that Venus is almost the same size as Earth?
I mean, we know that from.
You can resolve it.
No, you can't resolve it. You don't.
Yeah, you can.
Venus-
It looks like a
Venus could
circle
be-
in the sky.
Venus-
Yeah.
Venus
How do you
could be-
measure it? How do you measure it then if it looks like a circle? In the sky?
So a couple of things you can
Wait, hold on, Michael. You got to let us stay on a point, okay? How do you measure it if it looks like a circle in the sky? And does the moon look like a circle? Are these all circles? Are these spheres? Okay, is this one a sphere? Sergey, is this a sphere? The second one before he picks it up.
I mean, okay. So,
Is that a
so
sphere?
You,
wait.
you
You
can make
said
these
hold
arguments.
on. It looks like a circle, but it's not.
Yeah, but
okay.
you can make these arguments all day. Like you could say, oh, the government put the dinosaur bones in the earth, or the God put the dinosaur bones.
I don't
in
make
the
those
earth. They put
arguments.
just the right amount of carbon
Those are
14.
Stop strawmanning us. Stop
They
strawmanning
put
us.
just enough carbon 14 to make it look like they're 65 million years old.
Stop.
No
but
carbon.
that's-
Hey, just Sergey,
us.
Sergey, for right now, let's just stay off dinosaurs. But keep going.
Yeah. Don't put words in our mouth that we never said.
Yeah, but
No.
it's a philosophical point of how you see the universe, right? I see it as I'm going to try and predict what the world is like based on my models, and you can always like come up with some like conspiracy theory, like, oh, this is not a circle, this is a sphere, it's a hemisphere, like it's messing up the perspective.
He's
But that
asking-
doesn't help you understand what the world is like.
There you go.
It just-
Well, so you have a theory. What is your number one proof that the Earth is a globe? What is your number one proof? Just give me one proof that the Earth is a globe.
Can I give three?
Because let me start, and I'll say we can
I
see
take
farther than a
planes.
spherical.
Okay, so
Wait a minute.
Let's not
Wait,
laugh.
hold on
Let's
a
be
second.
serious here. Go ahead.
Let's answer. So you take an airplane, words very interesting, that flies straight and level over the Earth plane. How does that prove that the Earth is a spinning ball? I mean, how can a plane fly in the direction of the spin of the Earth or against the direction and still make it to its destination.
Because the atmosphere
Flat Earth predict?
Because the atmosphere that is on top of that part of the Earth is also moving with the Earth. That's the reason why.
Doesn't it thin as we go up though? It's still carrying the plane. I mean, the fact that you guys think the Earth is spinning,
it is thin once you get above 60 miles. Yeah, then it's exceptionally thin. But before that, no, you can actually use the atmosphere that you're in, which rotates along with the Earth.
The 30,000 feet up, that air is being carried along with the Earth.
Absolutely.
It's still one air mass.
Absolutely. Yeah. All right. So let's go over that. You wanted 3 proof? Can I give you the 3 proofs that I have that are empirical that have nothing to do with science for the Earth being round?
I'd like to just go. I just like to go a little further on Sergey's his proof that he flies in an airplane. If you have an airplane on the runway at in Ecuador, it's moving 1,000 miles an hour with the spin of the Earth.
About 1,100 miles.
Okay, whatever. I'm just rounding off 1,000 miles an hour, whatever. And if you have a plane sitting a mile from the North Pole, its relative speed is less than a mile an hour, quarter of a mile an hour, an eighth of a mile an hour. It's less than a mile an hour because in 24 hours, it's only going to go 3.14 miles in its circle, while it's sitting on the runway. So 24 hours divided, into 3.14, it's less than a mile an hour, way less. So you got an airplane in a mile from the North Pole. You take off and you fly down to Ecuador, and you want to land on a runway that's going north-south. How does that plane gain that 1,000 miles an hour of sideways speed?
Because the atmosphere is flying through.
The atmosphere is rotating with you, though.
Yeah, Dave, you're flying through the atmosphere as it gets keep push because you're getting into the heavier,
So as I'm flying down the Earth, I'm just speeding up sideways.
Yes.
What if I was flying east?
So if you're flying east,
what if I was flying east into the atmosphere? So
backwards.
Yeah.
You're being carried back.
I mean,
right. So we've actually
think that it's.
Yeah,
how does a summer breeze blow the air left and right, up and down?
So are you worried that if you go to Ecuador and you jump up, you're going to land in the Pacific Ocean?
No, because the Earth isn't spinning.
No.
But if it were spinning, you'd fall flat ass in the
because
Pacific
that's
Ocean.
Too quick. But you certainly would in a helium balloon when that helium balloon goes up to 120,000.
Using your argument, right? How fast do we think the Earth spins?
1,000.
20, 1,000 miles an hour.
Okay.
Right. So if I jump up, I can be in the air for I don't have as much hang time as Michael.
So your belief is that the air is carrying you with you.
1,000 miles away.
The air is carrying you with you, though. That's what you think, correct?
Well, give or take what the wind is, the east or westerly wind, yes. So for instance, in navigation school, I was at the 562nd Navigator School at Randolph Air Force Base. There's a wind triangle. So we have our bearing, right, and then we have our magnetic heading, and then we have to correct for wind, and that's the wind triangle that we have to do whenever we're flying.
So why is it that Neil deGrasse Tyson said that during a football game a field goal was kicked and it hit the upright? And he said that was because of the spin of the Earth. So why isn't the football carried along with the atmosphere like the plane?
So I don't know about that. So I think what about the spin of the Earth causing the football? I think that you could talk about the spin of the Earth with artillery, but I don't know about with the football. That we're talking way too short a distance.
Some minor effect from the Coriolis.
I mean, it could be it's not zero. The effect would be not zero, but for a football, I don't know. And also, Neil deGrasse Tyson was a wrestler. He didn't play football.
Yeah. So we can all agree Neil deGrasse Tyson is just a failed actor.
No, right? Neil deGrasse Tyson is a Longhorn. He's not a failed anything.
Right.
Go ahead.
All right. So during the break, someone brought up the Felix Baumgarten jump. He jumped from 127,000 feet, I think was the height. And there was 2 jumps that he did before, 2 practice jumps where they used regular cameras. Now, I heard you say that Dave's just going to say it's a fisheye camera, it's a fisheye lens. Well, Felix said in an interview, I saw the curve of the Earth. Was he lying? Was he part of the conspiracy? Or did he think he saw the curve of the Earth? Could be either. I don't know. He's wearing a curved glass helmet that's going to show a curve even when he's on the ground. But the many Globers use this as, hey, this is the Earth. Well, if we look at all these rivers and land features, all of this is New Mexico. So this is clearly a fisheye lens.
I don't disagree with you. Yeah, I don't disagree with you.
Good.
But you have to use a fisheye lens there.
Here's the problem. No, you don't. Because inside, hold on. Okay. Inside, from over his head looking out the door was a non-fisheye lens that when he opened the door, it showed the horizon at eye level, at the camera level. And then there was also a shot of him getting in when it was on the ground, and that same camera showed the horizon at the exact same level. We overlay them, and they're exactly the same level. So from ground, the horizon on the runway is the same height from 127,000 feet. There's no drop. 127,000 feet, I can't even calculate the drop right now.
Okay, so
right, but here's the main issue I'm bringing up is the Earth is spinning to the east. He went up in New Mexico, up there for 3.5 hours. Now, with some Coriolis, he should end up out in the ocean, but he landed east of where he took off from. Okay. So somehow he went up to 127,000 feet. He sped up and outran the spin of the Earth.
Right. Okay. So the explanation for that, you do admit like it is a balloon, right? The balloon exists because it has a lower density than the atmosphere around it. So it is traveling in a pocket of air. Pockets of air at different altitudes. This is one of the things we learn whenever we're flying. We call ATC for weather guidance. ATC was going to give us wind directions, and it changes at different altitudes. So if you had an easterly wind, he could have landed somewhere further east, or he actually could have received that eastward push on the way down while he was parachuting. Going back to what you said before, because that camera angle, you see this a lot of times with GoPros, I'm trying to look at him and I'm trying to look at the atmosphere around. I'm going to use a lens. When we say fisheye, what we mean is usually from videography, 12 millimeters, 10 millimeters, 8 millimeters. We do that, we're just going to get a fisheye. I don't believe Bumgardner was trying to say that image proved that the Earth was round. Now, if he's saying he saw the curvature of the Earth, maybe he did, maybe he didn't. But unless he was 250,000 feet in the air, I don't think he did see the curvature of the Earth.
But that never seen there. You've never seen it.
I've never seen it in my plane. No, I will not. Yeah, you're not going to get me on that one. I'm not going to say just because I was at 40,000.
You know, there's a lot of people who say that,
and they're incorrect. But because and the reason why that they say that is because, you know, again, going to the same thing you say before. If you look out and you see the horizon fall off, yeah. For those of you who are asking, yes, those of you who are at 40,000 feet, you are not seeing the curvature of the Earth. Maybe if you had some sort of microscopic, sort of measuring material, you might be able to if you looked wide enough. But the fact of the matter is, you have to be at about 50 miles in order to see the curvature of the Earth. 50 miles.
Plus, the horizon would be, it's not a physical location, so it could be refracted, could be up or down. You wouldn't be able to verify the horizon is actually where you're going to measure it.
Okay,
and
so
go ahead. The other issue is it's the way that we see. So we see whatever the conditions, whatever that horizon is, that's where the sky merges with the land and our eyes can't separate it anymore. That's our apparent horizon. But if I zoomed in, I could open that up and see farther. But so we see a certain direction. So I see the same distance at 12 o'clock, 1 o'clock, 2 o'clock, 3 o'clock, right? And so if I'm standing here, I see the same. This is the limit of my vision. But if you draw an imaginary line through the sky, you're going to see a curve. And global believers will say that's the curve of the Earth. No, it's not. This is the limit of your vision. It's how our eyes work.
Okay, so
and that is not. It's not curved.
So you've mentioned this before about an angular size and stuff like that, and then you've also talked about that. So let's just get into this real quick, and then we can go into eclipses because you brought up this part. So in your model, because we have a plane that we are existing on, and then there is a sun and a moon, and these things are moving in a way that not all flat earthers agree on, but they're moving in some way. But they have to be moving in a way where if I am on this side of the plane and the sun is over here, I cannot see the brightness from the sun, and vice versa. In that case, there is a finite distance at which light can travel. Is that what you believe?
Well, if this light can't even light up this whole wall and there's no atmosphere blocking it, the far end of the wall is in the dark because light is very local, right? But I can still see the light from this point of view, but you start adding atmosphere in there, clouds. Like when you look up through cumulus clouds, you see the blue sky. But as you look farther and farther away, 20, 35 miles away, those clouds are merging with the horizon, and you're looking across them, and it just becomes opaque.
Dave, can you show that one slide that you have where you show the sun going down and next to the
next to the you mean the Flat Earth Kitchen?
Yeah, just because it's good to show.
So guys, let me show. This takes 60 seconds uninterrupted.
Sure.
Okay. So this line, you have to pay attention. This line is a level line, and we're watching it from a celestial point of view, from the height of the line. So here's the sun moving along this line. Now, this is either mountaintops, city skyline, or it could just be the atmosphere cloud deck. And this sun never goes behind it, never goes below it. The counter is down here, okay? So now I have a camera on the counter at the far end watching that same thing. And if I showed you this first, I said, is this line level? You would say, no, it's sloping down quite severely. And am I going below this opaque barrier, which looks like it's at eye level somehow? Okay. And now look at it. I zoomed in more. It's almost going straight down, but this is a level line. And this deck right here looks like a horizon, even though we know it's higher than it. So now watching this compared to an actual sunset, here the sun goes away. It went down, and look what it's going behind. It's not going behind here. It's going behind this atmospheric deck. It's just the density of the atmosphere at that straight level becomes opaque, and the sun just goes beyond it. It's just going beyond it. It's not going below. But if I zoomed out, that difference between that apparent horizon and the horizon that it's going behind disappears. You can't see it because its angular size is too small. You see the sun going down behind what appears to be an eye-level horizon, but it's really a cloud deck 10,000 feet in the air.
Okay.
But it looks like it's at eye level.
Sergey, so
that's how our eyes
work.
work.
How does it come back up the next morning?
So if I turned around, if I just turned around and brought that sun back, it would be rising. Because when it comes...
It's going to come from the other side.
But it's going to come from the other side.
Can you show, Dave? Show the app.
So let me show you this. And go ahead.
I was going to say, Dave has an app.
I need the screen share, please.
Yeah,
because we can't see forever, right? I mean, this is something that they've taught us that we just need to get some tubes and some glass and curve it, and we can see 35 trillion miles into the sky.
So for those of you who are watching this and you're like on the fence, or you're a flat earther or a round earther, this is where we're going to disagree. Me and Sergey and Adam, we do believe that I can view Proxima Centauri, the light from there, 4.1 light years away. It's 24.
Wait, hold on. How is it 4.1 light years away? How did you determine it? You know the size?
No, can we focus on the simple things? Like, let's talk about sunrise right now.
Yeah, okay. We're going to talk about sunrise, but you can't make statements that you can see a light 4.1 million light years away or whatever the number is because you don't know how far it is. You're making it up.
So we know the size. We know the size through spectroscopy, and we know the distance through parallax.
I still can't screen share, guys.
And when you say we know, it's like really weird to me because you are believing in other people.
So are you. So are you.
How am I? Wait, hold on, time out. When did I believe in another person? I'm believing things I can see myself and I can test myself.
There are things that you have learned from Flat Earth that you have heard from other people. You are believing things that are from other people.
No, but I'm not repeating things here that I'm telling you that I've learned from other people.
Okay. Well, I mean, that maybe that's true, but you did.
We get a lot of people that try and tell us. I heard you say it the other day that we're in some sort of religion or it's a religious belief. But really, there is one group here that has men that they believe in from long ago.
Yeah.
That they hold as very high stature. That Newton, very high stature, and on the shoulders of giants. Mm-hmm. And then there's another group here that believes in books. That they read a book and whatever that book says in it, they believe 100%. So that's your side. So be careful about calling us a religion when we don't have any dogma. We don't have any holier-than-thou people that we can't question. We don't just make statements like, well, the sun is up in the sky and it's this big and it's this size and the stars are this distance and we know because of spectropsy. You can say those things all you want, but you've never actually gone and looked at a star observation and looked at what they do for spectropsy. You're just taking it as at face value as being true.
So you wouldn't do spectroscopy. Sorry, I have a hard time with that word. You would do it on the Earth in a laboratory, and then you would from that being able to see which chemicals or which atoms on the periodic table, elements on the periodic table exist here on Earth, and then you would be able to extrapolate that. From that, again, I know you guys aren't going to believe this because you don't believe in gravity, so it doesn't make any difference.
Right, though.
Go ahead.
Jaron's right, but at the end of the day, you can't go and reproduce every experiment personally.
True, I agree with that.
At some point, I just get in my car and drive around.
We do too.
I don't need to know how my car works.
Right. So that's what we say too, right? Because my phone works, I don't need to question that science.
Right. So proof for me that my car works is that I can drive around and then go do things with my car. Right. And so as a scientist, all these things that people have discovered, I can try and build on that foundation. And you're right. I didn't personally go and verify all these things. But I'm going to say, okay, assuming all that's right, because I trust you guys, I'm going to try and do one more step. And if I can do one more step and make progress, well, I call that a win.
But it doesn't prove the initial. You have to have the correct foundations for things to be true going forward, right? If you have the wrong foundation, you might still have things that match that wrong foundation.
That's 100% correct.
Okay.
That's 100%. But this is the point. Let's use like the car analogy, right?
Okay.
Like so far we're going to assume, okay, everything about my car works well, right? And then I'm going to say, okay, I'm going to try and like add like a feature to my car. Like, oh, maybe I'll add like windshield wipers because for some reason my car doesn't have that, right? If that feature, adds something to the car, I'm going to say, okay, look, I've made progress, assuming that like cars are a good mode of transportation. Of course, we can go back later on and revisit that hypothesis. We might say, oh, you know what? Cars are a little slow. I'd rather have a hover pack, right? And we find out that, oh, hover packs are actually more useful because not only can you like travel to the grocery store, you can also, travel cross country, right? Let's just say. It's the same with like scientific theories, right? You're saying you can't like prove a specific theory to be correct, and that's true. But
not the things that we can touch and play with it here on the Earth. We can prove that. The science of the internet works. The science of high-speed cables works in fiber optics, right?
But the test, in a sense, of whether the theory is useful or not, because I that's basically my criteria.
Okay, so tell me, if we're talking about the stars, what useful has come from us knowing the elements on the stars? Because let's be honest here, that it will never matter at all to anybody alive right now. What the stars are doing, how far away they are, we can never get there. It's a complete waste of time and waste of money.
So that doesn't make the Earth flat. I'm with you.
I'm asking if we can agree to that, though.
Yeah.
No. So let me give you an example, right?
Okay.
So by figuring out what's the physics of what's happening in stars, understanding those nuclear reactions, that's what allows us to go and build nuclear reactors. Like it's true that like I don't have a little sun in my house and it's not like powering my humble abode, right? But that kind of understanding what's the physics at play out in the star, that lets us build kind of like
we can build a nuclear reactor.
Yeah,
we can build
exactly.
a nuclear reactor, and that doesn't mean that a star is a nuclear reactor. That could be totally different things. So if you look at
correct.
scale,
in principle,
right.
it could be completely wrong. But assuming, a star is a nuclear reactor, let's see what
I don't assume anything.
From that. Let's see what we can figure out from that. We get this useful model of, this is how the elements interact. We have these radioactive particles. We can use those radioactive particles.
I could assume that there's no shadow on this stick and there's a shadow on this stick, so I can assume it's a sphere.
Hold on, Dave. But what he's talking about is he's created a testable model by looking at what the stars did to predict how nuclear
reactors work.
And it worked. That's the point.
But here's the thing. A neutron star is told to us that a teaspoon, think of how big a teaspoon is, weighs 21 trillion pounds. Now, if you believe that, you need to admit to yourself that you believe in fantasy just because men have told you that it's true. And you have to recognize why I'm going to say I don't believe that.
Hold on a second. I recognize why you say you don't believe that, but when you say it's fantasy and I shouldn't believe that, if I understand the standard model of particle physics, then it does make sense to me. I know for you it doesn't make sense.
That a teaspoon of something weighs 20?
Absolutely makes sense to me because we've burned off all the electrons and all we're left is the neutrons, and there's not enough pressure from the what you call it, the thing is the electron pressure from before. We understand how atoms work, and because there's not, the neutrons all collapse in on each other. Yes, that would make sense because what happens now in our standard model of particle physics, the reason why there's so much space between these particles that we have right now has to do with quantum mechanics. In a case where we took all these neutrons and there wasn't all this empty space and we put them all together, yes, there's no reason why you can't have neutrons that close together that create that much density. There's no reason why that happens. Just because you don't see this.
Hold on, guys, it's my turn. This is something that we're never going to be able to prove. It's theoretical, and we'll just let that go. But let's talk about scaling, sizes and scaling and variance, whatever. What do you call it, Jaron? Scaling and variance?
Yeah.
So, you say, well, spectroscopy, you can tell what the star is made out of. Well, if the star was twice the size and twice the distance, you would get the same exact results. Or if it was 1/10 of the size and 1/10 of the distance, or if it was right here within the Earth system and very tiny, you get the same results. So again, saying I can't even say the word.
So it's a combination of spectroscopy and parallax.
Yeah, I got it. But again, you're spectroscopy and parallax. You need to know how big or how far it is. You don't know either.
So we would start with our sun and then other stars that are close by.
But you don't know how big the sun is. Again,
you keep saying that. You keep saying that we don't know how the sun.
So hang on. how do you know the distance of the sun? Because you know the size, or you know
we can use parallax, and we can also see because of the orbital speed of Jupiter, we can tell how far away the sun is by doing that. Jupiter, we can actually use the other planets too. We could also use Mercury and Venus.
Again, scaling and variance. All of them could be right here within the Earth system. Okay. Yeah, again, you're refusing to see that, so we could just move on. But you need to know the distance of one of those things to make the other ones work.
Yeah, they basically
don't know other.
They've gifted you a model. They've gifted you a model. They've told you how great it is, and everything works. And then all you guys are just partying and having a good old time, saying that.
To be fair, Isaac Newton gifted us the original model for the formula for gravity, and parallax came before that. I believe it was the Persians who came out with that idea. So this model that was gifted to us has been tested and proved.
Can I ask a question about starlight? Does the inverse square law of light work in space?
These are tremendous. So the inverse square law would work with a certain amount of luminosity, but what happens?
So if you had let's say I have a light bulb, and the surface of the light bulb is 100 lumens, right? So as that light goes out, it spreads out really fast. So it's getting thinner and thinner and thinner. So it's getting dimmer and dimmer and dimmer. We can all agree on that.
In the atmosphere that you live in, yes.
And how about in space?
It's space. So you're going to have. So again, this is, and I know we might get into this later, but like the reason why in the videos of the landing on the moon, the reason why the sun looks different there and it doesn't look as dispersed is because of the fact there was no atmosphere on the moon, and so you're going to get more.
That's not my question.
I understand. My point is the atmosphere does have some effect. Go ahead, Sergey.
So I think David's point is that if we see a light bulb, we don't know, is it a 60-watt light bulb that's close or a 100-watt light bulb that's further away? Right?
So that's kind of the point. But my question is, as you're seeing it farther away, it's getting smaller and smaller. Its light is spreading out, so it is getting dimmer and it is getting smaller. We could agree to that on some scale, right?
To a point. At some point, there's no more angular size, and so all the stars will look the same size.
Michael, I'll let you interrupt me, but you only get one sentence per interruption, okay? All right? I'm just trying to make a point, and I don't want it to take forever. So if our sun, that the size that they tell us was just a mile over our heads, and you looked up, what would you see? You would see the sun filling the sky from horizon to horizon. Does everybody agree with that?
If the current theoretical size from from our model. Okay, got it. Yeah.
Yes. Okay, so it would fill the entire sky. So then we move the sun from right here, and we move it away 93 million miles, and it gets really small. It gets so small that it's the size of a coin held at arm's length. We could all agree with that, right?
Agree.
Just like we see it. So it has shrunk in 93 million miles that much. If I doubled the distance, do you know what its angular size would be? It would be really small. But I think the number is 3 times the distance. Its angular size would be too small for the eye to see. But let's just be safe. Let's make it 24 times the distance. Its angular size is magnitudes too small for our eye to see. Okay, we can all agree on that. So now let's look at Polaris. They tell us Polaris is like 46 times bigger than the sun. Let's make it 48 times bigger than the sun, right? So 48 times, so the sun being 24 times farther away is 3 light hours because it's 8 light minutes times 24, 3 light hours. Polaris is 48 times bigger. That's 2 days. 6 light days away. It is scientifically provable that Polaris would be magnitudes too small to see. But they tell us Polaris is 433 light years away, and I could see it with my naked eyes on a cloudy night. Okay? That's impossible. This is science. This is actual science that I don't know. There's no denying it, but somehow I have a feeling you guys are going to deny it.
But to Sergey's point, like, what is the intensity of that light bulb? Like, just because
it doesn't matter. I don't care if it's a billion
you also
light.
have to factor in the intensity.
So it does. Go ahead. So hold on. Let Sergey go, and then I'm going to go. I got an answer for this. Go ahead.
So to be able to like see the light doesn't mean that you're actually resolving it, right? So resolving, what that means is if there's like 2 light sources, you can tell them apart. So you look across the street and you're like, oh, there's 2 street lamps, right? But if you walk far enough down the street, you just see the light, right? You see, oh, there's light on that street, but you can't tell that there's 2 street lamps or 1. You see the difference?
Well, no, the light gets dimmer and dimmer, and there's a point where I can look over, like you can see, I think a candle flame. I think it's a mile or 2 miles, whatever the distance is, but then it just gets too small and too dim to see. Okay,
But
it's the same thing. It's the same thing with what we're looking at stars. At 6 light days away, you could not see Polaris, but we're supposed to see it at 433 light years. That is a completely different. I mean, there's no. It's such a big number that most people just short circuit and don't process the information.
2.6 quadrillion miles.
Got it. But the point is, what you guys are saying, that the angular size is so small that we wouldn't be able to see it. That is not the point. That's for us to resolve it. The reality of the situation is we would still see the light, and that's the reason why we see all the different stars that we see, from Betelgeuse to Rigel, those other massive stars. So the reason we see them. What about? We still see. We can't tell the shape of it. We can't see the planets around it. We could just see the
how come it? If you use the inverse square law of light, at 6 light days you wouldn't be able to see it.
No,
but
that's
somehow
not true.
We can see it at 433 light years.
That's not true. We wouldn't be able to resolve it. We would not be able to tell the features of it. We would be able to give some idea of the color, and from the color, and using spectroscopy, we could tell from that. Say, okay, well, this star is probably this old, and we can tell from those things because we can see other stars. We say, well, these are other stars in different periods of their life and death cycle, and we can predict from those things. We can predict from those things, and when we take that model and we use that model to predict other things, it tends to work out. It works out every time. That's the reason why we use it. So going back to what you said, no, we cannot resolve detail from Polaris, but we can resolve the light. That's the reason why you can still see it.
And going back to like search and rescue, that's the same reason why a signal mirror you can see from miles and miles and miles away, even though you would never be able to break out and resolve.
Would you be able to see Would you be able to see a signal mirror if it had any obstruction at all? If that mirror had any obstruction, could you see the flash? Or do you have to have a direct line of sight to the mirror?
Direct line of sight.
Okay, so we've done mirror tests where we go 25 miles, where there should be hundreds of feet of curvature. Somebody sits on the beach with a mirror. When the sun's setting behind the person observing, he zooms in with a camera, and we pick up the mirror flash. There's supposed to be hundreds of feet of curvature there. There is a clear obstruction.
So there's not hundreds of feet of curvature. You guys refer to this something over 8 squared. I forgot what it is.
8 inches per mile squared.
We don't refer to that. That is the mathematics of the curvature of the Earth.
Absolutely not. There is no 8 inches per mile squared. Is not used anywhere in astronomy. It's not used anywhere in geology. It's not. That is number.
Because the Earth is flat.
Guys, time. Everybody who's can you? I'll bring up the number and I'll put a link in the description. What that mathematical formula describes a parabola, not the curvature of the Earth.
We don't need to go. Yeah, but hold on here. We use that because you're talking about once you get 1/3 of the sphere, it starts wrapping underneath itself. So if you kept using that formula, you'd be incorrect. But we're only measuring as far as we can see, which is really a couple hundred miles at most. So
it's way too much, and that is not accurate. You should not be using it.
It is absolutely accurate. Up to 3,000 miles, it's a perfectly accurate. I'll bet you anything.
It is not.
Bet me money.
Mike, we can bet that. But there's also Globers. Most of them agree. But there's one site. I think it's Nick West, whatever. He says no. You have to cut that number in half. That's false. But let's cut the number in half. We can still see it.
Yeah,
even if you cut the curvature in half, we can still see it.
A parabola with incorrect numbers is still a parabola, and you live on a sphere.
Hold on a second. It's not. I'm telling you that if we do 10 miles, 100 miles, or 1,000 miles, 8 inches.
You're starting the curve of a parabola, which is a parabola. It is not. So
what is the curvature at 25 miles?
We'd have to look it up, but I don't know. But that number you guys time out. That number you guys came up with.
No, we didn't.
No, we didn't. We're using your.
That's AutoCAD. I'll show you the AutoCAD for it. I'll give you the exact link so you can go look at the AutoCAD, which gives you a sphere of 24,901 and then predicts the amount of curvature for every location from 12 o'clock. Now, you can't go past 3 o'clock on the clock because now you're coming underneath yourself. You would have negative curvature. But we don't need to go that far. We can only see 300 miles.
Think about what you're saying, guys. You're measuring
curvature. You're saying there's no curvature, right?
No, I'm not saying there's no curvature. I'm saying you would have a different equation that would be closer to measuring a circle than a parabola. That's what
Michael, we're only talking 10, 20, 50
doesn't matter.
miles, 100 miles.
But you're still wrong.
It doesn't matter.
You begin wrong.
You're not wrong because our number matches exactly whatever you come up with. You go figure out what your curvature on any mathematics that you want. At 250 miles, I guarantee you it's less than 1% different than 8 inches per mile squared. And then you'll have to admit that you were wrong.
No, I won't have to because it's still wrong. You're starting by using something in order to come up with these equations.
You can use anything you want. And with it, if you do it with 250 miles or less, it'll come up within 1% of our number.
You said if you predict something and if it comes close and it's useful, that means it's true. So there's 8 inches per mile squared.
You're using a formula that did not come from astronomy.
So what is the formula? So
again, I don't have the astronomy, but I do know that
we're gonna have to move over. We're gonna have to move on.
That's fine with me. That's fine.
But here's the thing. Go ahead. This is your challenge. Go show us what the curvature is at 250 miles, and then you'll see. So
and I'll do the 8 inches times mile squared, and we'll see if it comes out the same.
So you're asking about the sunset. We're going to go back to that a little bit, but before I share the screen, can one of you explain to me how seasons work on your globe?
Go ahead, Sergey. You want to do this?
Go ahead.
Well, okay, I'm asking you. I'm asking you. Like what causes summer? What causes winter? Let's talk about here. I'm in the north. You guys are in the north.
Let's do it. Right?
How do I get? How do I get winter here?
We have a planet that's about 25,000 miles around, oblate spheroid, and it is rotating at once every 24 hours, and it is 94 million miles away from a light source, the sun. It is angled at 23.5 degrees, and on June 21st, it is the North Pole is facing as much as it ever will towards the sun, and
direct angle.
And on December 21st, the South Pole is the I'm sorry,
the Tropic of Capricorn is facing the sun. I get it.
Not the magnetic North Pole, but the actual pole that the pole of axis is facing as close as it will directly on December 21st towards the sun in the South Pole. That's how we would get seasons. So that means on September 21st and on forgive me if it's March 21st, that would be the solstice. Equinox. Sorry. Yeah.
No, those will be the equinoxes. So June 21st and December 21st are the solstices. Yep. So June 21st is the height of our summer, and that's because we're angled towards the sun. So the sun rays are coming parallel to the Earth for 94 million miles, and then that little bit of tilt causes the spread out, causes them to hit a wider area, and it's less intense, right?
It would be more intense. Right? You said June. Or are you saying December?
No, I'm talking about December.
Yeah, December. Right.
We're tilted away.
Correct.
So it spreads out because we're tilted away.
And from
like if I put a spotlight on my hand, it covers a certain area, but if I tilt it, it spreads over a wider area, which has to spread out that heat. That's what you're saying.
The difference the difference between summer and winter from an astronomical standpoint is not a great temperature difference. But yes, that is what we're saying.
The difference between summer and winter.
So summer in Las Vegas. Let's just say.
Let's talk about a more temperate zone. My Connecticut.
Okay, so Connecticut,
Massachusetts.
Do you guys get up 100 degrees in the summer?
We get 100 degrees in the summer, and everything freezes in the winter.
So below 32 at winter. Okay, from an astronomical standpoint, like for instance, like temperature changes on different planets, that is not a great change, but for here it is a great change. And I guess we could get into human evolution, but evolution would state we exist on this planet because to like for instance,
Mike, you're going way off track.
Got it. Off track. Go ahead.
Okay, so you're saying because that little tilt, the sun goes farther away. The sun spreads out, and that's why my lakes here freeze in the winter.
Energy dissipation. Yes.
Right. Okay. So. Is in the northern winter, are we close? In your model, are we closer, farther, or the same distance from the sun than in our summer?
On January 3rd, we are nominally closer, but it has no effect on the amount of very little effect on the amount of light that actually gets to the Earth.
So 3.5 million miles closer is the actual answer, but over 94 million miles, it's only a couple percent. Makes
Correct.
No difference because the light it's just going and that heat. Is heat going through through the solar system and hitting the Earth?
So it's heat. It's radiation from ultraviolet.
Radiation.
Yeah, it's radiation.
All right. I got it. I just want to see where you're coming from. So can you tilt a ball in one direction or any direction? A ball can tilt in any direction. Okay. So here's the thing. On June 21st, here in Connecticut, I can go down to the water, and when the sun appears on the horizon, I can feel the heat on my face. Okay, that is the most severe tilt, way more than the seasonal tilt of the Earth. That's an 89-degree tilt. So I'm seeing the sun at an 89-degree tilt, and I can feel the heat on my face.
I don't understand what you're saying. You're talking about at the sunrise, the sun is 89 degrees from the zenith?
Hold on. Yeah, 89 degrees.
1 degree, Dave. 1 degree.
It's 1 degree. It's 1 degree.
So 89 degrees from the zenith or 1 degree from the horizon.
Correct.
Okay, got it. Okay.
Right. So that would be the Earth would be tilted. It should be that's like with the poles. I mean, that's worse. So the sun is right there on the horizon, and I can feel the heat on my face. Mm-hmm. I can get a tan within 10 minutes. I'm getting sun. I can get a sunburn. I can feel the heat. We're 3.5 million miles farther away, but you say that doesn't make a difference.
No.
Then 6 months later, in December, when we're closer to the sun, but that doesn't make a difference, at solar noon, when the sun is at its highest point for the day, maybe 50 degrees up in the sky, a much more direct angle, I could look at the sun and I can't even feel the heat on my face. That completely 100% negates your tilted ball season model.
No, it doesn't.
And then, yes, it does. 100%.
The environment around you is colder. You are in a pocket of air that is colder. That's the reason why you don't feel that heat.
That is not true.
Why is it colder?
That is incorrect.
There we go. NASA's after me. Go ahead.
What was that fell? I'm interested in symbology. Something fell that's like you need to pay attention to whatever fell.
Right. Hell yes, man. The Selfish Gene by Richard Dawkins. 3 hours on evolution coming up later.
There you go. All right. So wait, this is just I'm getting to my screen share real quick. So this is the heat map of the Earth. We got the equator right here tilted.
Yeah.
We have our tropics. But the red area is the tropical zone mostly. How can these sun rays? Why is it heating it at this angle? You look at it on a flat Earth. The sun circles around here, migrating in between the two tropics. This heat map, which is the same as this heat map, makes perfect sense. So now let me share my screen, and I'm going to show you how seasons work, right? And then we're going to go from there. So this is the Flat Earth Sun, Moon, and Zodiac Clock app. You guys can see that? Is that on everyone's screen?
Sure can. Yep.
All right. So the sky is a perfect clock. The sun goes around once every 24 hours. And it laps the moon. If I speed it up, you'll see that it's catching up to the moon. The moon's getting more full. And after 28 times around, the sun will lap the moon. So the moon, its phases and its position dictate, keep track of the weeks and the months. The sun keeps track of the hours and the days. And you'll see the moon is waning right now. And that gets into a whole other thing. When the moon goes new, how come no one ever sees it for like 60 hours? That's another insane thing. If I slow it down, I'm going to turn on the stars. The stars are spinning in the same direction. Sun, moon, and stars all rise in the east, set in the west, no matter where you are on this earth. Okay? Rise in the east, set in the west. Now, the stars are moving at almost the same speed as the sun, but just a little bit faster. Okay? How little? Well, they lap the sun once every 365 days, give or take. Okay, so right now we're exiting this zodiac, and we're moving into the next one where it'll migrate through there, and the zodiacs will lap it once a year. So the stars keep track of the seasons and the years. The stars never change. You go out tonight, sit down on a bench somewhere, and chart the stars and say, okay, that one's near the corner of the building, that one's there, that one's there. Mark the time, set your calendar for the same time, same day, next year, 10 years. Every star will be in the exact same position. But we live in this beehive spinning galaxy with stars at distances that you can't see, but somehow they reset every year exactly. We get into eclipses. I don't think we forgot about that.
Most of them do. We've actually seen supernova, and we've actually seen different things.
Dave, I have a question looking at your model right there real quick. So when it's a flat disk like that, the stars,
Not a disk.
Okay, sorry. Flat plane. The stars overhead should be rotating counterclockwise no matter where you're at on the Earth in that sense, correct?
Not if you're in the south. Think about it. If you're in the south looking up at the sun and the moon, everything is rising from your right hand and setting on your left hand.
I'm talking specifically about the stars. So if
So listen to what I'm saying. If you're in the north and you're looking south at the stars, they're all rising on your left, the east, setting on your right, the west. If you turned around, now they're all rising on your right, setting on your left. They go the same direction.
Clockwise and counterclockwise are just relative to your position. If we all point up right now, we're all pointing up. If we all point down, we're all pointing down. But if I say point left, we could be pointing in different directions. It depends on where we are. So if
so then why didn't at the equator do the stars go directly overhead from one spot to the other? Whereas if I'm in the north, the stars are apparent to be counterclockwise, and in the south they go clockwise.
Okay, so let me turn the stars back on.
Go ahead.
Whoops.
I'm just trying to understand.
Mm-hmm. Yeah. So, and this is something that they don't teach you in school. So, you see my mouse? I'm inside the Tropic of Cancer, which is this line right here. So, I'm looking outwards. and the stars are coming from my left shoulder to my right shoulder. Can you all see that? Can you visualize that?
Kind
Okay.
of. Yes, I'm trying.
All right. I'm standing in the center circle area, and I'm facing the outside edge in any direction. And the stars are coming from my left shoulder to my right shoulder.
But you're looking straight up, correct?
I'm not looking up. I'm looking out. I'm looking towards the edge of the circle, right? And I could look up too.
So from our globus
from the
reference
left to
south.
the right.
From our globus the south.
Yeah, well, the flat Earth. South is every direction away from the center.
Got it, okay.
So if you're in the center looking outwards, the stars are coming from your left to your right, from your left shoulder to your right. Now, if I'm outside, I'm out here, let's say I'm in Santiago, and I'm looking towards the North Pole, the stars are coming from my right shoulder to my left shoulder. They're going clockwise now versus counterclockwise, but they never changed direction. I just changed my orientation. Let that sink in. This is not an argument. This is a fact. Look at it as many times as you need until you get it, okay?
Why does the northern hemisphere and southern hemisphere have different
stars? Let's talk about that as soon as I finish season.
Hey, time
Right.
out. Can I take 2 minutes to go to the bathroom real quick? Does anybody else need to go to the bathroom? I drank a bunch. Give me 2 minutes. Go on a second.
So we're told that the sun, the moon is going the opposite way around the Earth. The stars are going one way. The sun goes, we're orbiting around the sun. But when you look at everything rises in the east, sets in the west. We've gotten rid of clockwise and counterclockwise because that's just relative to the way you're facing. So now let's just talk about seasons. The outer yellow line is the Tropic of Capricorn, and the inner yellow line is the Tropic of Cancer. June 21st, if I jump forward, 1, 2, 3, 4, where are we? March, April, May, June. So in June, the sun is over the Tropic of Cancer. Now, when the sun is closer to you, just like a streetlight over your head, it's high in the sky, but the streetlight down the road is low in the sky and farther away. So when the sun is over the Tropic of Cancer, we here in the north have our summer, we have our summer. It's really hot in Miami. Why is it hot in Miami? Because the sun goes right over Miami. Look at that. Right over Miami. It's super hot. Aristophanes could do his experiment there. Hot in California, Jaron, over 100 degrees. He's complaining all summer long. Okay? But at the same time, Australia is having their winter because the sun is farther away from Australia. If I jump, the sun migrates out in December. Now Australia's having their summer, and here in Connecticut, everything's frozen because the sun never gets close enough, right? And it's a heat lamp that comes closer and then moves farther away. It's a heat source. Don't quote me on heat lamp. I don't think it's a lamp in the sky. What the sun is, that's a whole nother thing. But that's how seasons work. That's why the map looks like the map looks. And that's why we have shorter days in our winter because the sun is farther away, it's lower, and it sets behind that apparent horizon quicker due to perspective.
Why does the apparent light from that sun reach further along the edges?
Hold on. Let's do Adam first and then Sergey.
Go ahead.
So go back to that depiction. I'm just curious, why the apparent reach of that sunlight goes further the more you go outboard. Why is the shadow, if you will, the lack of light? Why is there cylindrical shape?
Yeah, so during December, it looks like the light wraps around a little farther, and it actually does. Versus 6 months later, when the sun is in the Tropic of Cancer, the sun the darkness kind of wraps around, and that has to do with the optics of the sky. I personally believe that there's a dome. And as the sun gets out closer to that dome, it wraps around. And we can see examples of this if we, doing experiments with lights inside of domes where the light will spread. Let me see if I have that.
And I believe something a little bit different than that, but it's the stratosphere is lower at the poles than it is at the equator. So the equator is the highest point, and the poles is the lowest point. So it creates essentially a dome, but not a dome over the entire plane, more of like a bundt cake pan. You've seen a bundt cake?
Yes.
I'm trying to, I don't know if I have, but yeah, go ahead.
It's kind of like a tube that goes around the cake.
Okay.
Yeah.
If you look it up, you'll see it. It's basically like a dome, but a dome that goes around everything. And that's what the atmosphere tells us. I mean, go ahead.
So let's talk about the angular speed of the sun is the same, but when it's December, the sun is going faster because it has to make a bigger circle in the same amount of time, right? We can agree with that. And so Globers were like, well, how is that possible? And it's just where that focus point of energy that we call the sun is. It's still going at the same speed, the same angular speed. And so, so what is the sun? I believe, and Jaron, you can tell me, maybe he has a slightly different opinion. I believe that the sun that we see is an apparent position. It's a reflection or projection of the real source of that sun. And there's a lot of evidence that this is true, where sometimes during an eclipse, you can see the source of what we call the sun. So if I'm standing around and I turned around, if I had a flashlight and I pointed it 3 feet in front of me, and I turned around in 1 minute, I just drew a 3-foot radius circle in 1 minute. But if I just angled that light out 6 feet and I spun around at the same rate, I just did a 6-foot radius circle spinning at the same speed. So is the sun really speeding up? I think the sun that we see is changing speeds. Jaron, you have anything to add to that?
I think I agree. And I think we have a personal relationship with the sun, which if you think about religious undertones, there's something to do with that. And the fact that the sun walks on water and that the sun turns water into wine, there's a lot of allegory there on purpose about what the sun actually is. Right. So the sun, we see, because picture this, if you and I are both standing on a beach and we're 100 yards apart from each other and we're watching the sun set, there's going to be a glistening coming to our feet. But I can't see the one going to your feet, and you can't see the one coming to my feet. We can only see the one that is specific to us ourselves, right?
Got it. Okay,
yeah.
Awesome. So,
and then also, like if people say, well, how do we see it in different positions? This is the reason you can't triangulate the sun. Imagine we're in a room, and I hang up a thin blue sheet dividing the room in half, and we're both on one side looking at that sheet, and we're 10 feet apart. On the far side of that sheet, we have a light source. Okay, that light source is lighting up the whole blue sheet with daylight, and then we can look through the sheet and we can see that bright spot. We can see the source of that light, and we'll see a bright spot on the sheet, and we can send a third person to the sheet, and I say, draw a circle right there. That's exactly where I see it. And then they do it for you. They're going to draw another circle 10 feet from where mine is. So we're both seeing the same thing in a different position relative to our own.
Right, unless we can get on the other side of the sheet, but you guys don't think space travel is possible,
right.
so we can't get to the other side of the sheet.
Correct.
Okay, got it. Okay.
So listen, I'm going to get out of the app.
But yields testable prediction, though.
Real quick, while we're
absolutely
while we're still looking at this app, though,
what you can do,
Let
right,
Sergey talk.
is if I understand correctly, is at different times in the year you can measure what's the angle that the sun makes in the sky when it's at its maximum brightness, right? And what you can use to calculate is like where along the radius is the sun on this clock hand, correct?
Yeah. Well,
and so now you could do that at different positions in the sky, and then you can test whether this model is correct.
Well, absolutely.
Like
it yields a testable prediction.
But hold on, but your sun cannot be triangulated, right? Triangulated.
Well,
You cannot go outside and measure the angles to the sun, and then he go outside and measure the angles to the sun, and you guys get the same answer.
It's too far away, but like we could we could if we couldn't do it to the sun, but we could do it to other objects 6 months apart.
I'm saying, like, wait, try and pause the video right now.
Okay.
I pause the sun.
No, pause. Yeah, your clock. Pause the clock.
Maybe I misunderstood.
All right.
Pause the clock.
Okay, that's good enough. Okay, so you can see here, right? So imagine I can't point at this screen, right?
No.
Okay,
Just give us a location. We can
here.
So imagine you're at like 9:30.
Okay.
Okay. So what you can do is you can measure. Okay, what's the angle, right, that the sun makes in the sky, right? If you were directly, like you were saying,
if you're right underneath that sun there, and
it would be right above
90 degrees. Okay.
Right? But if it's like, say, halfway on the because as the seasons evolve, right, the sun's going to move up and down that radius. Right?
Yes.
It's going to go from the edge of the hand up to the inside of the hand.
Correct.
And so as the time goes along, right, as the year progresses, you can measure what's the angle that the sun is going to make.
Yes.
Yeah, we know that number. That's your latitude.
You can calculate what's its radius on this clock hand. Right?
Yeah, but that's your latitude, right? So we know that. That's already a known thing. They've known that. The latitude is the angle that it is to the sun. So if you're at 37 degrees north, it's because the sun is 37 degrees high, right?
I don't want the latitude. I want the radial position. So I want the distance.
Well, here's the thing. Like right now, if you're in northern Australia, right where the sun is, you would have no stick. You would see the sun in the bottom of a well, like Aristophanes. And we can test this all the time. On June 21st, every place underneath that yellow line at solar noon will have no shadows on anything that's vertical. So yeah, this is testable and it works. But guess what? It doesn't prove the flat Earth
because at different times in the year you can measure the angle, and from the angle you can get what's the distance along the clock hand.
Okay, and what good? Yeah, so we already know that distance, but what good does that do? What does that do?
What is the distance that you guys think the sun is? You didn't say it before.
It doesn't tell us
the real sun, or are you talking about the apparent sun?
So can you talk? Yeah. So there's a real sun and an apparent sun. I guess I didn't understand. So the real sun is what distance?
Right. So he was just telling you about the sheet, and he said there's a light behind the sheet.
Yeah.
Okay, so the sheet is what you're seeing. That's the light that you're seeing, but there's a real sun that's behind that.
Okay, so how?
Right, and if you start moving, if you started walking towards me, your sun is going to move and intersect with my sun, but the real sun didn't move at all. It stayed right where it was.
Do you have distances for either one of those suns?
No, we don't, because again,
the parent sun, the parent sun triangulated is about 3959, which is weird because that's your guys' radius. That's what it comes out to when you do the trigonometry on it.
3959
miles. Yes.
3,959 miles.
Correct. So and 32 miles wide is what it would mathematically come out.
So the image that we see that's projected on the dome, it would be 32 miles wide, and it would.
Some don't believe in a dome, but okay.
4,000, 4,000, around 4,000 feet up. Okay, got it. Okay.
No, not feet.
It should also be testable.
4,000 miles. 4,000 miles.
Let me show one other thing on here. So here in Vegas in June, when the sun sets, how long is the sky still lit up? How long do you have twilight for? Here in Connecticut, it's like 90 minutes, maybe 2 hours.
It's weird here because we're in Las Vegas. Literally means the meadows. We are surrounded by mountains here, so we kind of get like a weird effect. It's probably not the best example.
So, all right, so here in Connecticut in June, the sun sets and it's light for another 2 hours. Right, and that's because the sun would be on this inner track. Hold on, let me bring it in. The sun would be on this inner track, and it's kind of arcing around us. See, it's arcing around us, right? I can bring it in a little farther. April, May, June. So the sun is arcing around, so it's not going that far away. Now, out here in Central South America or Central Africa or Southern Africa, the sun is going a lot faster because its apparent speed is making a bigger circle. When the sun sets in December and January, 5 minutes later at an equal southern latitude, according to, on the ball, an equal northern latitude 6 months earlier should have the same amount of sunlight. But when the sun sets in those southern latitudes, it's pitch black in 5 minutes in many places. Okay? And that's because the sun is racing away at almost twice the speed.
Oh, you think? Okay, I see what you're saying. You're saying there's less twilight because the sun is moving at a different speed.
The sun is moving. The apparent sun is moving.
And what we would call our southern latitudes or your Tropic of I keep forgetting Capricorn.
Right.
And yet it's still moving at 15 degrees an hour.
Okay, let me get out of the app. But I just want to show you a couple quick things so I can get out of the app. This is for people that are like, hey, this is interesting, but I don't believe the Earth is flat. That's fine. Every day there's a new featured video, and I tell people just get the app, watch the featured video every day. Click this thumbnail. If you want to go back, click the video archive button and start watching these videos. Just watch a video every day for 2 weeks, and then you too will lose the respect of your family and friends and those podcasters because you'll realize
podcasters
isn't a globe. But and I'm offering 3 Bitcoins for 1 proof of the globe. But before you do, you have to hit that question mark, and up come stuff that Google will not feed you. Hey, what about eclipses, right? If I clicked what about eclipses, up comes videos that YouTube doesn't want you to see. They're still there, but but you can search for them by name and they won't show up.
Got it.
And these are videos that'll show you, about that stuff. Last thing I want to show you, the app does a whole bunch of other things, but people think, oh, there's a couple of flat earthers, they're crazy. If I hit that handshake, this is just the people that have my app that have registered for the Friend Finder. These are all people that know that know the Earth is flat.
No, I'm fully aware. That's why we're doing this podcast, because something that we will agree on, because I have 3 questions to ask you guys, but something we'll agree on. I think it is a very, very, very horrible mistake for science educators to be like, we're not going to engage with you. I think that is, those people are fucking stupid. And I think part of the reason why there has been so much growth in your movement is because they choose to look the other way. And anyone who doesn't deny science has been able to gain a foothold, whether or not you believe it's true or not. Go ahead.
You talked about censorship. Why are they sitting there? They're allowing Bigfoot. They're allowing, all sorts of crazy stuff on the internet. But, they're censoring Flat Earth. During the Senate hearings about fake news, they use Flat Earth as their example on how they're going to hide it and replace it with authoritative comments, authoritative, wiki links and whatnot. One of the biggest Flat Earth videos out there is called The Stranger's Guide to Flat Earth 21 Questions. Pretty unique name. You search it by name and channel name, it doesn't come up. You get the same results. When you search anything Flat Earth, you get the same results. You get
I can show that.
I believe, and I've seen this. Yeah. I've seen the exact same thing. I'm not definitely.
You get Professor Dave.
Yeah, I definitely
you get nonsense.
I definitely agree, and let's get to that in a little bit. But I definitely agree that yes, the ideas that you guys have are 100% centered on YouTube. That is definitely not up for dispute. But a couple things. Let me ask.
Actually, one of the one thing we'll all agree on is that censorship on the internet is really bad.
Yeah, it's not only bad; it's pointless. I'm not trying to equate you guys to this.
Not pointless.
I'm not trying to equate you guys to anything like this. But if someone had a belief about eugenics or racism, I would rather them not be covert about their beliefs. I'd rather them be overt, so at least I know who I'm arguing with. And that's why I have a very difficult part when people say, "Well, you can't speak on this campus because you because of gender studies or because of whatever." I have a very serious problem with that, even if I agree or disagree with you, because I want to know where everyone stands. And if you ever read the book Homo Deus by Yuval Noah Harari, at the end he talks about dataism. Anything that speeds up the bandwidth is good. Anything that slows the bandwidth down is bad. Even if it's something that you don't believe in, it's still better that more people know. Sergey made that point during our podcast. Isn't it better all the people that are educated? Can I ask you guys 3 questions? Just 3 questions here, and then we'll go back and we'll talk about eclipses afterwards. The 3 questions are going to be this, and the first one is going to be flights in the southern hemisphere. Okay, so we're both aviators, and Sorry, we had something there. We both and we've looked up flights in the southern hemisphere. Santiago to Sydney is one, and the other one is going to be Buenos Aires to Johannesburg. Those flights go off every day. There are flights. Originally, I was listening to Flat Earthers saying there were no flights in the southern hemisphere. Now it seems like they're recanting that and they're showing our southern flights in the hemisphere.
Well, there wasn't a direct flight, but now there is a direct flight. Okay, so and we actually tested it.
Okay, so Santiago to Sydney is about 12 hours one way and 13 hours the other way. And both of these places are in the southern hemisphere. If you guys want to pause the video and look at these 2 places, they're in the southern hemisphere. According to the map that you've shown us, those places are significantly further away in your flat Earth plane than they are in our round Earth globe. Can you explain the discrepancy of why you can make that flight in 12 hours or 13 hours?
Darren, you want to go first?
Sure. So there's the winds aloft, right? The jet streams. And in the south, they are the fastest that they are. They go anywhere from 200 to 300 miles per hour. And the plane would not need to account for that because it's being carried along by those winds, right? So you're still going a certain airspeed. The jet stream is carrying the plane around. So, yeah, if that plane does 600 miles per hour, it could be doing 9.
So you'd be using less fuel, though, right? You have
they only think they're going 6,000 miles when they're actually going 10.
The problem is they don't think anything. So we have what's called a ground. We have a ground radar, and that whole ground radar tells us our ground speed at all times whenever we're flying. So we would be able to see that we're going.
Run by NASA.
No, no, it's not a GPS thing. It is literal a radar on the bottom of the plane.
NASA. Well,
okay, so this is
the radar. The radar goes to the ground and tells it how far it is from the ground.
Negative. It does not. That's an AGL radar.
No, I was asking you. I'm sorry, I wasn't saying that.
Yeah, it's not an AG. So that's how you get AGL. You can get ground speed based on a radar that goes over the ground. Okay, that's ground additional. Radar. Now there's another radar that works with the GPS. That's separate. So we know that when we're making that flight, we're not going at 900, 1100 miles an hour. And by the way, those numbers, 900 miles an hour, still does not make up the difference in distance between the globe Earth and the flat Earth. In the flat Earth, there is a tremendous amount of difference that goes on, and also the flight plan would go up through South America, down through North America to get to that place. And in the globe Earth model, it just goes west from San Diego to Sydney. So that discrepancy doesn't really seem to be described in your model.
Well, they have to fly in the south to keep the jet stream, so they wouldn't go north. That would make then they're crossing the jet streams and getting crossed.
I'm with you, but there is no evidence of a jet stream that goes that high. And by the way, you're saying there's an opposite jet stream.
What do you mean? There's no. What do you mean?
There's no, I'm sorry, higher speed, velocity. There's no evidence of a jet stream with that high of velocity that would go in both directions. That's the problem. So
there is. There just is. You can just look at the different levels. Like sometimes the level at 32,000 feet has the wind going 200 miles per hour this way. At 36,000 feet, you might have the wind going 100 miles per hour the other way.
Yeah, but it's still not enough to make up. I agree with you about 100 mile an hour winds, but we're talking 100 mile an hour, 200 mile an hour winds. I have 700 hours, 500 combat hours. Okay, I can tell you.
But Michael, you haven't flown that flight. There's only one plane that does it, run by a small handful of military pilots. And that plane, we found information that it has 7 layers of heat-resistant paint on it. Okay, so it must be doing something a little bit faster. And also, you said there's a 1 hour difference. Sometimes there's a 5 hour difference from their scheduled.
We actually looked it up.
Their scheduled time and their actual time. So now, hold on a second.
No, that's me.
Sometimes they go around the outside and they follow these winds. And I could show you. We have a live chart that shows you these winds. But other times they go all the way up across America and down, crossing the equator twice. On a flat Earth, it makes perfect sense right here, which is pretty much a straight line. So here's what we did. We didn't just look at flight plans and believe flight routes. We actually tracked somebody. We did I think it was 14-hour live stream where Max Egan was going from Santiago to Australia, and he flew, and we did a live stream where we never turned the live stream off, so no one can accuse us of anything. And he got him on the plane all the way to the plane taking off, and then he took measurement.
He wasn't on the whole time, just so they know that, because that sounds.
Because we tracked the plane. We had professional tracking, right. And then when he landed, he logged back onto the Hangout while he was still on the plane. Proved that he made this flight. So there was a lot of flat earthers that thought that flight did not exist.
It's fake, yeah.
Yeah. So we proved the flight was real, but the problem was his compass readings, when he gave them to us, we laid them out. I'm just trying to find it because I don't have OBS, Jaron.
You wouldn't have learned it that fast anyway.
Here it is. So he showed us that his plane was going northwest, and then right here is west, and then right here is southwest, south, pretty much south, right? The yellow ones are south, the purple one is west, and these are northwest. And so we plotted it, and this is the route he went. He crossed the equator twice. If the Earth was a globe, I'm not really sure his
magnetic heading is going to determine his route. You're not going to be able to, unless you have a stopwatch and you were able to look at his ground speed. I don't know necessarily that's evidence that was the route he took.
He took headings and they weren't matching what the seat back was showing. Okay, they weren't matching.
He was in the cockpit when he did this?
No. He was a passenger, and and somehow coincidentally, if you're saying that the headings are all wrong.
No, I'm not saying
it matched the flat Earth map. It matched the flat Earth map, right? The plane went, and the compass has to turn because the North Pole's here. Mm-hmm. So there's west only for a second. No, you can't point west. When you point west, you're pointing south. Just so you know that, okay? And this is the direction that his plane went according to the compass readings, right? There's no need to cross the equator twice if you're going from any two southern locations or any two northern locations, for example.
But then there's no jet stream either, right? So you're saying now there's no jet stream because...
Oh, no. There's also a jet stream in here also.
So now there's north and south jet streams along with east and west streams.
There's counter-rotating jet streams. There's counter-rotating jet streams.
I'm aware that there's jet streams that go at different speeds at different places. They're rarely are they north and south, though.
No, they're not north and south. They circles.
So here's a route from Sydney to Peru, and it crosses the equator twice, right? But on a globe, it goes all the way up here and all the way down. Why didn't they just cut across here? It's almost the same distance, okay? Why on your globe?
So here's the thing. When you're going from Sydney to Peru, that's different. What I would like for you to see is Sydney to Santiago. The reason why it goes from Sydney to Peru is because you have 2 third world countries. I'm sorry, not Sydney to Peru. The reason why you're doing that is because the likelihood of you needing to go to Lima, Peru from Sydney is not enough to justify the route.
That's incorrect. There's plenty of people that want to go to Lima, Peru to see the pyramids.
Correct. They do.
Stuff.
They do. So they go through Los Angeles. The problem is there's tons of places in the United States where there's no direct flights. Trust me, people tell me all the time. The idea that there is no direct flight is not a problem. There are, however, direct flights from Santiago to Sydney. And those are
Sydney to Johannesburg. Why does that cross the equator? Okay.
Sydney. Okay.
So here's the thing. There's countless southern flights that cross the equator twice. There are 0 flights that are within this circle. Okay, that go any 2 northern locations, origin and destination. Never, ever do they ever cross the equator.
We're going to disagree on that because I believe Johannesburg to Buenos Aires does not cross the equator. And I also
it does when it stops when it stops here.
It doesn't. I don't believe. No, you're saying it doesn't stop there.
Yes, it does.
Okay, you're talking
These
about
are
a different
actual
flight.
flights.
Okay,
these are actual flights.
You're talking about. Stop, guys. Let me finish. Yeah. You're talking about an actual flight that does have a stop there. There are actual flights from Johannesburg to Buenos Aires that are nonstop that do not go to the northern hemisphere. There are actual flights from Sydney to Santiago, which you are not showing, that do not go to the northern hemisphere.
Santiago to Sydney. I got it up here, and if I go to stops and go nonstop only, there's no flights. Okay, so I'm not saying they don't exist.
Hold on. Can we pull those up? Because we actually found several of them. All right.
Sure.
So they do exist. Actually, we can
didn't
do that.
say they didn't exist.
Okay, cool.
That's what I'm saying.
We can pull it up, or we can put it up in the notes later. If you have them, we can pull it up. But the fact of the matter is, yes, there are actual flights that go from Santiago to Sydney. They do not go in the northern hemisphere. They are nonstop, and the times do not match up. The times do not match up with a flat Earth. A flat Earth plane. They do not. It's 1505 for this one right here. This is what the ETA is. Okay, the headwinds are 40 knots. Now, according to you guys, all of the people. It's not just ATC. It's not just the FAA. It is the FAA for every single country is in on this because they have to be in order to lie about the distances, because the distance right there is 6,000 miles.
There's not very many flights that go just in the south. It wouldn't be every flight.
That happens to be because 90% of the Earth's population lives in the northern hemisphere and 15% of the Earth's land mass is in the southern hemisphere. So that's the reason why. But also, several of those countries in the southern hemisphere are poor. That's why not a lot of people go from Buenos Aires to Johannesburg, but they do.
So what I'm saying is you just made it sound like everybody would have to be in on it, everybody at the FAA, but do you understand that you're talking about a very select, you're talking about 10 flights a week.
No, I'm talking about 10 flights. I'm talking about 10 flights. Well, obviously everyone from the FAA would be on it. How would they not be on it?
You mean everyone at the FAA? That's the most ridiculous statement ever. What do you mean everybody?
Yeah, everyone at the FAA because they believe in global positioning system. How in the world are they supposed to navigate aircraft if they don't believe in north, south, east, and west GPS? Of course. They would have to be in on what you guys are saying. Why would they not?
No, they don't have to be in on it. The computer flies the plane. It's just like saying a pilot's in on it.
Oh, I'm sorry. 2 guys here. The computer doesn't fly the fucking plane.
Yes, it does.
No,
a
stop.
passenger jet.
Stop.
We have
maybe
pilots
not a passenger jet. But
they can read a book. They can read a book the whole flight.
Hold on. We both had to get PPLs beforehand. Okay, we had to do navigation over the Earth. And when you do your PPL, you are not allowed to use a computer to fly shit. You have to. You are instructed on how to fly long distances. That's what your solo means, and you do so without the use of a computer, totally with a bearing and a heading, and you use the wind triangle. There's a MB4 whiz wheel that you have to use in order to make these calculations. That's why you guys are, no offense, you're never going to convince me the Earth is flat because I'm the one, because I actually got a solo pilot's license from doing this, and this guy's an F-18 pilot. So we know that wind triangle works. We know the great circle routes work, and we also know that you can fly in the southern hemisphere. We talked to too many pilots that have flown to the southern hemisphere to believe this idea that they go north up into the northern hemisphere and come back down. That is simply a fallacy.
We're not saying every time they fly they do that. They do fly
all in the southern hemisphere, and those distances are not the distances that you guys have, and nobody's going over 1,000 miles an hour ground speed. That is not happening. I'm sorry, that is simply a fallacy. That isn't happening. I understand.
Sure. What about the Concorde? The Concorde
every
just did it.
Every pilot would have to be lying about a 600 knot.
Not every flight. Not every pilot. Not every pilot.
Every pilot going Santiago to Sydney would have to lie.
What percentage of pilots? What percentage of pilots fly there? What percentage of pilots fly in the south from Sydney to Santiago? Because it's like less than 1%, right? So stop saying every pilot when we're talking about 1% of something.
No, we're talking about every pilot. When two different things. Sorry, every pilot from Santiago to Sydney. That's one lie. When you get your PPL, that's a whole different situation because north, south, east, and west are real places. Those are real directions that you have to use bearing and true airspeed.
But they work on a flat Earth, right?
They don't work on a flat Earth. They absolutely don't work on a flat Earth.
What do you mean? So do you know that the way this map that Dave is showing right here is how they direct radio signals. They use that map.
Direct radio signals. I don't understand.
Yeah, they use that map, and they can pick the direction of where radio signals need to be sent and pick them up.
Who is directing? I'm sorry. What radio signals are we talking about? Out of what? And which frequency?
From shoreline to the maybe shoreline to a boat that's out in the water somewhere.
I'm sorry, I'm confused. Radar signals or radio signals? I don't understand what you're talking about. Radio waves is a long spectrum. So exactly what are you talking about? Radio signals.
Radio waves, yes.
Okay, so you understand there's shortwave radios that submarines use, and then there's long wave radios, and there's FHF, UHF.
Okay,
VHF.
so if you're trying to send something from Spain to the east coast of the United States, you could point the direction from this map and pick it up.
Okay. I think you probably use satellites, but you guys don't believe in satellites, so I don't know. There's also fiber optic cable that's run under the Atlantic Ocean, so I'm not really exactly sure.
There are fiber optic cables under the ocean, and what's amazing is there's no cable from Santiago to Australia. It goes all the way up.
Yeah,
it goes because it's too far apart. Because it's not at the bottom of the ball.
On both, even in the globe Earth, it's too far apart. In globe Earth or flat Earth, it's too far apart.
No, they run the cables all the way up along the Philippines, all the way to Alaska, all the way down the east coast, the west coast of the United States.
Because there are other land masses that are nearby there for them to do that. With Australia and South Africa, those places are individually far enough apart from each other that you wouldn't want to run a fiber optic cable under the Seychelles and the Madagascar and all that other shit. It doesn't make any sense for you to want to do that. I mean, we can argue the semantics of this, but the first question was, and I believe we're just going to have to agree to disagree, that those times are accurate from Santiago to Sydney, and they do not fall in line with a flat Earth model. The second question,
I would say that as long as you're being honest about it, they're not an hour difference. It's far beyond that, and they're not as easy to find.
But it still doesn't make those numbers work. And so what you're saying is the flight plan that is presented by those pilots is a fraud, and that they're actually going into the northern hemisphere and coming back into the southern hemisphere.
Never said that either. I said they stay in the south because they stay with the jet streams. They program in where they're going, and the plane gets them there.
Okay,
that's
correct. But during that time, you get three indicators. You get IAS, TAS, and GS: ground speed, indicated airspeed, and true airspeed. Those three things would indicate that they are not getting a headwind of 300 miles an hour.
So here's the thing. NASA's in charge of GPS, radar, and flight routes.
These are inside the aircraft. These have nothing to do with GPS or NASA.
So I'm talking about you say that they know the route that they're going. Pilots, on these flights, they turn their knob to 670. They press a button and they play.
Absolutely not true.
Well, they'd probably do a couple other things, but they're not in charge of their route.
We've talked to pilots who say that they have constantly. We're not saying they're sleeping.
Again, you engage autopilot, but you're 100% backing up that system to make sure it's operating correctly, and you 100% know.
We're not taking anything away from pilots. We're not taking anything away.
So hang on. Taiwan to LA. So here is the route that they show on flight radar. Here is the route that they showed the people on their seat back cushions. Here's Hawaii right here. Right here, there was a medical emergency. I'm not sure which one it was. Maybe it was
I think a baby being born.
Someone having a baby or whatever. And they needed to land the plane. So if you're a pilot, where would you land? Maybe Hawaii. Maybe you'd continue over here. I doubt you'd turn around and go back. But instead, they went thousands of miles out of the way to Alaska. Okay, why did they go to Alaska?
Because that's not an accurate depiction of that route. That's where flight radar showed the plane. That's what they showed.
Hold on. Let me finish my point. That's where they showed the plane, right? But in reality, they were right here when it happened. They landed in Alaska. Hawaii is all the way out here. Okay, they lie about where they are, and this has happened 17 times now. But there's a book that documents all of them. 16 emergency landings that prove the Earth is not a ball. Every single one of them, they landed on if you drew a line from the destination, from the origin to the destination, every single one of them landed on an airport right on or next to that line. But if you look at it on a globe map, it's way out of the way. They landed up in Moscow or wherever.
Right.
Insanity.
So that line that you showed me, and I don't believe under either model is the accurate flight plan for that route. And so you would use, just humor me here, Great Circle route. The Great Circle route would have taken you closer to Alaska. That's why you.
And that's true.
That's essentially what it would happen.
Why is that the Great Circle route? I think that the whole idea of the Great Circle route, this is a Great Circle route. It's not a, listen, my fingers look like they're a straight line, but if I turn it, you can see that it's a curve.
Correct.
Right?
But that's
there is no straight line. There is no straight line on a ball.
Okay, all right. So here's the problem. So because you are north of the equator, then you would have a pitch up, an upward curvature on that depiction right there. If it was a great circle route, you have to, because you're looking at a two-dimensional
wait. So
image.
why doesn't
this is a great circle route? A straight line.
No.
Airplanes fly straight level.
Again. Your assumption. I'm humoring you that the Earth is flat. In my assumption that the Earth is round, a great circle route north of the equator, when I'm looking onto a two-dimensional, I'm looking onto a three-dimensional object, but I'm only seeing a two-dimensional object because that's what I'm seeing. Then that's going to be represented by a curve, an upward curve, and in the southern hemisphere, it's going to be a southern curve. That's just geometry. That's how it works. Just humor me that the Earth is a globe. That's how a great circle route would work. In no case would you ever have a straight line like that in the northern hemisphere to describe any sort of route anywhere. And dude, listen, I know I've flown all the way from fucking Robbins, Georgia to Iraq. I'm telling you, it is a great circle route in order to get there. They did not plan this for things to be weird, for me to take extra long times. And like I said before, the rescue mission from Anderson Air Force Base to Hickam Air Force Base, we took a great circle route to get back. I do not believe that their intention, or my computer's intention, was to kill this child. I don't think that's what happened, for us to take another hour to get there. The reality of the situation is we had to take a great circle route because the Earth is
where were you going from? Where were you going from?
I was going from
Iraq?
Anderson Air Force Base in Guam,
which is
to Hawaii.
Where's Guam?
Guam is it's closer to Japan. It's like kind of close to Japan.
Okay, so Japan is over here.
Uh-huh.
Okay, right along this route.
I mean, listen, you're
hold on,
zoomed out. Okay, all right.
Hold on. Let me ask you a question. So here's Guam over here, and then where were you going to? Alaska?
I was going to Hawaii.
You're going to Hawaii. Okay. Well, Hawaii's out here. So there's is that your great circle route?
I mean, like you're pointing at something where you're zoomed out at 25,000 miles, and like I know I can't zoom in right here.
Yeah, no,
I feel you.
Go look at a flat Earth map.
We're kind of
draw your route on it, and that looks like you're then plot that on your globe, and you'll see that you're taking this great circle route, but in reality, you're taking a straight line on a flat Earth map.
It's. I mean, in a perspective, if you took a small enough area, maybe that those two things equal up. But the reality of the situation is, we were flying on a round Earth, and we were flying a great circle route because that is the fastest way to get from one point to another.
But if you rotate the globe towards you, it becomes a straight line.
Yes, and in the photo that you showed me, the Earth is not rotated towards me. That's the reason why I'm saying that's not an accurate depiction.
Hang on a second. This is an accurate depiction. The emergency landing proved that. But now let's plot that on a globe, right? And this is not a great circle route. To make a great circle route, like you said, we have to go all the way up like this.
Not that high up. You definitely don't have to go that high up.
Okay. All right. So you go like this, and that's more like the actual route. So here, a straight line on the globe, right, going around the curve, the shortest distance between 2 points is a straight line. Okay, it's not a great circle route. But in reality...
On a globe, it's not a straight line.
On a sphere, they say it is.
Yeah. Well, no, on a sphere, it can't be a straight line because... Anyway, go ahead. In three-dimensional space,
if you get two locations on a globe... You want to draw a straight line on that globe. Yes, it's a curved line.
There you go.
Right? There's no need to make an arc above that straight line.
So there is, because you're looking at a two-dimensional object. You're looking. I'm
talking about a physical globe. You draw a line from Taiwan to L.A.
Correct.
That's the shortest line possible.
And if you were directly over that route, it would not look like a curve. It would look like a straight line.
Of course, it would look like this. But they don't do that. They do this crazy great circle route, and they say, oh, it's a great circle route, and you just believe it, but in reality, it's a straight line. Okay,
we know it's a straight line.
Hold on. That great circle route is a straight line on a flat Earth map. You just think that's a coincidence. I can't help you.
Actually, no. Well, let me help you. It is a straight line on a globe as well if the orientation of that line is directly over the route. But when we go look at maps, when I go to base ops and I pull out one of my charts, that orientation is not going to favor wherever the fuck I'm at. It's just going to be wherever it is, which is usually over the equator.
Let me ask you a question. Huh? If you got a piece of string and put it on Taiwan and stretched it over to Los Angeles, that is the shortest route on the globe. Okay, and then you arch that string up over here, you're going to fall short. It's not long enough. So you're saying that they're going to take a longer great circle route?
Absolutely not. No. That's not true. Again, this is a function of perspective. If you go above the string will look straight. The reason why it's you're again we're I'm kickboxing.
Yeah, there's no proof here because
I'm kickboxing and you're doing jiu-jitsu. We're just not talking the same language here. You're saying because it happens to work in your formula, this one thing in the northern hemisphere works. That's proof. It's not. It doesn't disprove what I'm saying. On a great circle route, if you are over the great circle, it looks like a straight line. That's it. We don't have to go about this anymore. I just wanted to ask a question. I got 2 more questions, so let's go to the others. The second
and you're going to give us your 3 globe proofs also at one point.
Right. No. It's the first one was the flight in the southern hemisphere. I'm sorry. To me, that proves that the Earth is round. Now, I've talked to enough people who've flown in the. We're going to agree to disagree. That is proof number 1. End of story. As far as I'm concerned, that's the proof number 1. You can fly in the southern hemisphere. There are not jet streams that equal these distance that you guys are claiming they do. And no, there is no proof that these flights are going back into the. I'm talking about the nonstop flights. Just the nonstop flights. There's no proof that Santiago to Sydney goes into the northern hemisphere.
No one claimed it.
None.
Nobody claimed that, though.
Actually, he did.
I'm showing you
not nonstop flights.
Yeah, not nonstop.
Okay, cool. All right, the nonstop ones do not go into the northern hemisphere, and there's not enough. There's not enough jet stream.
They might.
There's not enough jet stream to make up the difference. To me, that is a proof. Sorry.
Can I ask you a quick question? Do you think that airplane technology has increased since the 1970s? Probably.
Aeronautics. Okay. Hold on. The laws of aeronautics have not changed since the 1920s. No, that have not changed. Now, have the laws of avionics changed? Hell yes, they've changed. Avionics have changed. Aeronautics have not.
Do you think there's a possibility that they can build a plane that can go faster than the average plane?
For sure, but once you break the speed of sound, it's pretty fucking noticeable. Why don't you ask this guy? Once you break the speed of sound, which is what you'd be doing, it's pretty freaking
Nobody in the plane would know. Nobody in the plane would know.
Absolutely.
Nobody in the plane would know, and if flying over the ocean, nobody on the land would know because you're out over the ocean.
Lieutenant, would you know if you broke the speed of sound?
I mean, you're not going to know from like a sonic boom or anything in the aircraft, but like
you're talking about your dials.
When you approach this transonic region, like airplane design becomes completely different. And no, we do not have airliners that look in any way, shape, or form like they can go supersonic, other than the Concorde years ago.
And the only difference between it is it had a pointy nose.
No, there's other reasons. It has to do with the
design is different. Compressibility starts taking effect with air molecules and everything.
Right. So if you look at the shape of the wing. Long range 787, right? Is that the one, the Dreamliner that goes to the southern?
Yep.
Yeah. So that it's a long range flight. It has all composite materials. It's all redone it's way different than every other plane.
It doesn't make it supersonic.
It's not built.
No, but it's still interesting that the one plane that has to fly in the south this long distance that you're using as proof has to have all these modifications to get. That's
not the only plane that flies in the south, and those modifications do not make it supersonic.
So, what plane flies from Sydney or from South America to Australia that's not a Dreamliner 787 long range plane?
I don't know. We'll take a look. I don't know. I'm not like you, I'm not going to disprove a negative right now. We can take a look right now and try to find that out. Let's go to the second one. To me, that is not enough proof that you guys have given me that those distances.
Okay, it's not disproving a negative when you brought up the claim that there's other planes that do that, and then I ask you for proof of that, and you say I don't have to prove a negative. That's not how that works. You made a claim. Why wouldn't you back it up with evidence?
You made the claim that.
Yeah, but you're making the claim that
they're all 787s and that 787 can go supersonic. You made the claim. Yeah, so that's not accurate. So anyway, let's keep going. The second one would be so if the moon, I'm also guessing the moon is somewhere between 3,000 and 4,000 miles and 32 degrees. The image of the moon that we're seeing is 32 degrees and 32 miles. 32 miles, and it's also 3,000 to 4,000 miles above the Earth. Is that correct?
If you believe it to be a real item like a rock, then that's what it would equate to with mathematics.
Okay, so my second question would be, if I am in Australia or if I am in Alaska, I am seeing the same face of the moon, and this moon is only 4,000 miles away from the surface. Why am I seeing the same face of this sphere, even though I'm on different place? Even if I'm flat Earth or round Earth, why am I seeing the same face of this sphere?
So go ahead, Dave.
No, you go first, Sharon.
Just going to say, if you think of a light on your ceiling right now, or let's say there's a circle and you mark an A on the top and a B on the bottom, and you stuck it to your ceiling, you on one side of the room would see the letter A being on top, but somebody on the other side of the room is going to see the letter B on the top, correct?
Yeah,
it's going to be a flipped image.
Right, but the image is going to be distorted based on where I'm looking at it from. Like, so for instance, if it's a circle and I'm far away, it's going to look like an oval. So
but we can, when you project things, kind of like what Dave was talking about. Let's say you're behind the blue sheet and you've got a shining light on it, and you've got the moon lit up. That from people, everybody in the room is going to see the same face.
Well, it's a little different with the moon because I can see a distinct face. Whereas the sun, I'm kind of looking into this
just like this guy.
light.
just like this guy in the pool here, this body is not facing us. It's facing the way straight out. But for some reason, we see it facing us, right? The optics of the sky are no way to prove the Earth is.
But
look, I'm showing you as I'm moving around, I'm seeing the same front-facing chest of this guy, right? Even when I was off at the side, I saw him facing me. Look, he's still facing me.
Got it.
He's facing me, and as I move over, he's turning. Perhaps the optics of the sky are reacting similar.
The sky
to
is
that.
moisture.
Okay.
Right.
All right, but a moisture or a dome that is causing the same face of the moon to face in every single direction, no matter what your perspective
just like
is.
This is doing it. Just like this is doing it.
So the thing is, I'd have to go back and watch that guy and make sure that he didn't turn his torso when he's not just because his head is not facing in this direction does not mean his torso isn't.
Is there
facing.
anything that we could show you?
Is there anything that we could show you that we landed on the moon in 1969? No. So
yes, you can show us the original footage. You can go back. You can do it again. You can go there and actually jump the height that you would jump if you weighed 60 pounds with the muscle mass of a 250-pound man.
Time out. Go ahead. Sorry, guy.
Okay, so the reason we see always the same side of the moon is refraction.
Yeah, he's asking a question. You're saying it's refraction off the dome that is the reason why, or whatever you believe, dome or moisture.
I'm saying the optics of the sky are no way to prove the shape of the Earth.
Okay.
Right? This is an example of one way that we see the same face from different angles. I'm not saying this is exactly what's happening up there. We don't know because we can't go up there.
Some people believe there's a superfluid up there, a superfluid like helium-3 or something that could give crazy properties that we wouldn't know, right?
Okay. This is inside or outside the dome, the superfluid?
I don't believe in a dome personally, so you'd have to ask Dave.
Would you guys agree on a firmament? Like what is the thing? Is there a flat Earth thing that you guys agree on? Is what is the cover out there?
I think that there's some sort of barrier. It might not be physical. It could be energetic.
Okay.
It could just be atmospheric. It could be temperature ridden. It could be plasma. Mm-hmm. I don't know.
Okay. So that would be the second question that I asked. And then the third question I have to ask you is if I am standing in facing away from north, so what we'll consider south or facing towards Australia in all three cases. If I am in Buenos Aires, if I am in Johannesburg, or if I'm in Sydney and I'm facing towards Australia, in all three cases I can see the Southern Cross. But I cannot see the Southern Cross when I am in Las Vegas, Nevada. So why is it that I can see a different, if the Earth is flat, why can I see it? And I am facing, in these perspectives, I am facing in completely different directions in all three of these locations because these continents, according to the Flat Earth model, are facing in three different directions, which is not north. But I see the same Southern Cross.
I think you explained your thing. You said facing Australia. What you mean is if you're in Australia, you're facing south.
Australia. I'm facing south. But I didn't want to use the word south because it's confusing.
South is just away from the center.
Yeah.
So if I go back to the clock, so let's say right here it's midnight and you're looking out here and you see the Southern Cross.
Yeah.
Right? Santiago, well, it's noon there. Okay? It's noon in Santiago. They're not going to see the Southern Cross, but 12 hours later, the stars have rotated 180 degrees, and now it's midnight over here, and the Southern Cross is over here.
So the South Pole has rotated, but the North Pole doesn't.
No.
Hold
on. Let me show you. Okay. So here we go. So you have your southern. Let me just turn on the stars. So let's say I'm in Santiago right here, and we'll just say that this bull is the Southern Cross, okay? These two stars here are the Southern Cross. 1, 2, right here, okay? It's midnight there. Actually, it's noon there. So over here, it's midnight over here. Here's the Southern Cross, these two stars right here. It's midnight, but it's noon over here. They don't see any stars, right? 12 hours later, right? These stars are coming over. So 6 hours later, it's midnight in Santiago, and here they are. The Southern Cross is there. Hold on. And now 6 hours later, the Southern Cross is right here.
But if I take long exposure photography, what I see is that the sky, the sidereal, the celestial sphere rotates around where the Southern Cross is. It does not rotate sideways laterally with the Southern Cross.
Darren, do you have the star trails shown from the different latitudes at the same time? We have video that show how the stars appear to go in curving rays.
So you're telling me
again,
that it's going to rotate. The Southern Cross is going to rotate my perspective in different places, but the North Star does not. The North Star stays over. It stays over that part in the Arctic Ocean, but the Southern Cross, it changes its perspective. It rotates around during different times of the day to match up.
So like anti-crepuscular rays, you've seen those on the other side of crepuscular rays? Right, have you ever seen the rays coming down from the sun? And then sometimes you can turn around and you see what's called anti-crepuscular rays going the other direction. It's kind of the same thing as the stars do. So it's very confusing because you're taking a very materialistic look at it rather than understanding that just because it appears a certain way doesn't mean it is that way. Right? So what he's saying is that as these stars are rotating around, there's a big difference between the stars in the north, which are doing this circle right above your head, coming around, going, okay, and then the south, which is a much larger track. And you're saying people in 3 different places can see the same thing at the same time, which just isn't true.
I didn't say they say the same thing, but in a 24-hour period they can, which means you're postulating that the Southern Cross goes to the south of Australia at one point, the southern part of South America at another point, and the southern part of Africa at another point. Okay, that's what you're postulating. To me, that is not enough. That would be my third proof. I'm sorry. I'm just agree to disagree. To me, that would indicate to me that at the southern tip of all 3 of those continents, I'm facing the same direction because the Earth is round. That would be those 3 ones. That's it. Okay, that's it. And then let's go on to the other thing, which would be eclipses. I would just like your explanation. We can skip ahead. Your lunar eclipse is because of what?
Great question. So the lunar eclipse in your model is because the Earth is in perfect alignment with the sun and the moon, and the Earth is casting a shadow on the moon. Correct? That's your.
I can give you a little bit more detailed explanation. So the way it works is the moon travels 5 degrees north or south of the ecliptic. And during certain periods, when we get into a full moon and it is sitting directly on the ecliptic, then there's a shadow there that is cast from around the Earth onto the moon. One of the reasons why it's red, though, is because we're getting the atmospheric burn, or the light going through the Earth's atmosphere then goes and it shines on the Earth. That's why you get a blood moon or a different color eclipses because of that. Anyway,
colored shadows?
They're not colored shadows, but you can actually have a piece of paper. Like, so for instance, if I took a colored piece of paper and I shined a light through it, I would get a colored light that goes through it. So the outside would be a colored light. The inside would be a shadow. That's what we have, a penumbra and an umbra. Those are 2 different parts of a shadow.
So you would agree that they got the sun on one horizon and the moon on the other. If
we're standing at sunset, we're somewhere on sunset. Is that what you're saying? Where am I standing when I see the Earth and the moon on the horizon?
You're always standing from your point of view on the top of the Earth. That's just from your personal point of view.
Okay.
And for you to see an eclipse, one of them would have to be below the horizon. Would you agree with that?
To see a lunar eclipse, the sun would have to be on the complete opposite side of the Earth as the moon. Yes, correct.
Correct.
Okay. So have you heard of the Saturnian eclipse?
I'm not sure. Do you know what that is, Sergey?
There's over 50 documented eclipses where the observer can see the sun and the moon both above the horizon, and the eclipse has already started. Sometimes the eclipse comes in from the top, where it really should be coming in from the bottom. Sometimes it comes in from the side. Sometimes it comes in from the bottom. What this proves is not what is causing it. It proves what's not causing it, and that's the Earth. Okay? Also, if you take a sphere and projecting a shadow from one sphere to another location far away, I don't think it can be done. It just fuzzes out. But we're seeing this perfect cutout. Now, this is not a real eclipse here, but we see this perfect cutout go across the moon. But if you take a sphere and move it through, with a single source light, move its shadow across another sphere, you see this long ellipse, right? This long parabola come in, and then it spreads out, and then it leaves as a parabola again, okay? And so what we're seeing is not a sphere that's causing this apparent shadow, right? Yeah. You can take a straight edge and eclipse that sunlight onto a sphere, and you get very close to what we see. Now, I'm not saying that it's a straight edge or a flat Earth that's doing it. I'm saying that a ball cannot cast a consistent shadow that crosses another ball. That's scientifically provably impossible. You'd have to go out to get some balls and get a light and get a dark room and do it, and then you'll see what I'm talking about.
Yeah, I don't know. I don't know that that's scientifically impossible. If you
well, I've done it. I've tested it. You haven't.
Right, but you don't. I don't think you have the same ratios. So the moon is 265,000 miles away. The sun is.
How do you know that?
The sun is 94. But we'll just humor me, man. Humor me for my globe Earth, okay? Huh? Okay. The moon is 265,000, somewhere in that area. The sun is 94 million miles away. And if you do the experiment with those ratios, then it does seem to work.
I don't see it working that way.
Sergey, do you have anything to say about the shadows and the ellipses and all this other kind of stuff? Because it looks to me like if I took a sphere and I put a sphere in front of another object, the shadow that I would get would be a circle, no matter what the angle would be.
No, but if you did it from a sphere onto another sphere and moved it across, you should try it because the angle that it's landing on is changing. So, it starts out really steep and then it's centered. If you take a baseball and go do it over a basketball, you'll see that it comes in as a long ellipse, then it turns into a baseball, and then as it wraps around, you'll see it wrap away, and it doesn't look anything like what we see.
Cool. I don't know if that's
for your app.
Go ahead.
That'll make a really good video for.
It's actually on my app. There is a video on the app. I'm not 100% about eclipses.
I'm not 100% positive that your experiment correctly renders these three things, right?
I'm showing you a sphere with a single source light projecting a shadow onto another sphere. I can show you that it doesn't work in the distance, but we'll say we have the scale wrong, but it doesn't matter. A sphere putting a shadow on another sphere doesn't give you a consistent curve just like we see. And then also with the sun and the moon being above the horizon, that means that the earth is not in line with the sun and the moon. So how can the earth be casting a shadow unless you believe that the sunlight is diving down, grabbing the earth's shadow and refracting it up through space? Okay, that's your only explanation, and that's ridiculous.
And again, I mean, when you go searching for flat Earth eclipse and all you find are the same videos that you find when you search flat Earth proof or flat Earth debunked or anything, then we realize why it's kind of hard to get this information out, right? It's kind of hard to get out the information that the 8 inches per mile squared is actually correct because whatever you did in your research, you found somebody saying it was incorrect, and you've just adopted that. You haven't tested anything for yourself. You haven't verified it.
I could see that it's a parabola. That's. I didn't have to adopt that for myself.
So I sent to you guys the AutoCAD. Do you see that? I think the producer has it. So if you go to the AutoCAD formulation, you can see that it shows. Oops, hold on. Now it's not going to be big enough. Hold on, right, this one's good. All right, there you go. So you'll see that this is AutoCAD telling you the drop in geometric construction and then the difference in trigonometry. And if we go to, let's say 100 miles, so they have 1.26 miles, 669 feet. When I do 8 inches per mile squared, I come out with 6666 feet. So it is accurate up to as far as we're going to see. You can go all the way down to 3,000 miles. If we do 3,000, I could do the math real quick. It's not going to be off by enough to be saying that it's incorrect. It is correct. And so telling people that is what we have to deal with. We have to deal with debunkers going on their channels that get promoted, saying that this equation doesn't work when it does work. And then people going around saying flat Earth is dumb because the equations don't work.
So what I said was that equation did not come from astronomy, and that equation measures a parabola. If you want to say that the equation is to some degree of accuracy within 300 miles, that's fine, but that's not what I said.
Up to 3,000 miles, as far as we can see. So what difference does it make if you point out that it's wrong? Well, what difference does it make if we're measuring? We're never going to measure the curve of 7,000 miles.
That didn't come from us, and you guys keep debunking. You guys keep trying to use a formula that did not come from globe earthers in order to make your decision.
What do you mean it has? So we can only use things to disprove the globe that comes from globe earthers? Think of how ridiculous you're sounding.
No.
That's what you said. You said I can only use math that comes from globers to prove the globe wrong.
So once again, your hyperbole is not going to work here. So
what do you mean hyperbole?
Hyperbole meaning you said every time I said I'm supposed to use things that come from globers. That is not what I said.
Okay, so when measuring the Earth,
that's what hyperbole means. You use the hyperbole.
So when measuring the Earth globe, I have to use the math provided by the Earth globe proponent.
Absolutely not. But this was an example you gave about that specific formula, and so now my job is to debunk point out the fact that describes a parabola. It does not.
People have been trying for the last 5 years to debunk this, and they can't. And they've given up, and they've agreed that it's correct. Let me ask you another question. If the moon is 238,000 miles away, how far are the clouds?
No, I mean, I don't know how far those clouds are, but I mean, they could be.
Are they 200,000 miles away?
Maybe
Okay,
6 miles away.
So 230. You get a light and make any scale model you want and shine it on something that far away. It's going to light up all of them. But I want you to go out on the next time there's spotted clouds and the moon is in the sky. You'll see that the moon only lights up the clouds that are right next to it. And that reason is because the light that we see in the sky that we call the moon is very close to those clouds, right? And as you look into the distance, there's no light on these other clouds. Okay?
It's very close to those clouds. So you think we don't have the capability of flying an airplane to get to 4,000 miles? Very close. You think 4,000 miles is very close to those clouds that are 30,000 feet up?
I don't think the moon that we see is 4,000 miles away. Again, the real source of the moon could be 4,000 miles away, but the light that we see is close, and as we move, it moves. As we go up, it goes up.
So we could never fly to it. We would just fly up, and it would just keep moving away
and it would keep moving, just like when it follows you in the car. Have you seen the Go Fast rocket? This is something that NASA doesn't do. This is taken off in Arizona, right? And NASA always cut. They would have had 7 cuts by now, but this is a steady shot looking down, and this thing went up 73 miles. Now, at 73 miles, it appears to hit something. It made this noise, kind of like it went into a thicker medium, not quite water. I don't know what that is. That's not the point of the story. It was floating very weirdly, right? Uncut video. But when it turned on its side, all of a sudden, we could see the moon. Here it comes. Boom. The moon's right there. Okay? Now, this is over Arizona. At the time of this launch, the moon was over New Zealand. Okay? New Zealand is on the bottom of the ball. If the world was a basketball and Arizona was on the top of the ball, this rocket is a fraction of a millimeter over the ball, and New Zealand is on the bottom of the ball. And all of a sudden, we can see the moon.
Okay.
That is impossible.
Got it. Okay, cool. Got it. Love it. All right, here's a couple things I need to ask you guys about. Just a couple of things. The vastness of, and I really wish we could have got to this a lot quicker because a lot of these explanations were long, and I apologize. There's so many people on here. A couple of things I want to know is, like, obviously for Gemini and Apollo, all the people who worked on Gemini and Apollo, they were fooled into believing that it was true, except for the people that were prosecuting the launch. Like, who was in on it, who was not in on it with Gemini and Apollo?
Go ahead, Jaron.
Yeah, I mean, you named it. As few people as possible, right?
Okay.
And there's some guy who did a mathematical study into how long secrets could be kept, which is a joke in and of itself because you would never know the secrets that have not been released, right? So if you and I have a secret that we've never told anybody, it would be impossible for some researcher to calculate that we have that secret that we haven't told anybody. So it's a completely flawed science anyway. But he's doing his mathematics, and he came back with a you'd have to have less than 1,000 people to keep the Apollo hoax going for 100 years. And so he said it's impossible. Yet none of us have ever claimed that more than 1,000 people need to be on the know. They did weird things too, like, right, they spread out the construction of everything Apollo to 400,000 people, 20,000 companies.
Yeah.
You would never do that. If you were trying to get astronauts for the first time to the moon, you would want everything controlled. You would want control of everything. You would not pass it out to 20,000 companies. Like, you build a switch, you build a circuit breaker, you build a wire. The reason they did that, hold on, let me finish, is because you get a buy-in. All of a sudden now, everybody in the country knows somebody who worked on Apollo. It's not proof of anything. It'd be like me saying, hey, I drove my Ford Focus from California to Hawaii. You would say bullshit. But what if I said, well, my uncle worked on the muffler of that Ford Focus? That doesn't prove anything.
Okay.
It doesn't prove I drove my car to Hawaii.
We have to wrap it up pretty quick. That's correct. Another idea would be like the F-22 when it was built. There was a component built in all 50 states because of governmental reasons. That's the reason why. So I guess the other question I have to ask is, like,
wait, the government had every state build a component of the F-22?
Yeah, that is true. You should look it up. Yeah, the government.
Why?
Because that. So just imagine you are a senator and you have to vote on the approval of this incredibly expensive program. What are you going to get out of it? You're going to get jobs. How are you going to get jobs? Because the tires are made here, and the struts are made here, and the ailerons are made here, and the avionics are made here. That's essentially what
there are 100,000 states. I mean, 100,000 different companies.
Time out. There's 100,000 people. I don't think there was 100,000 companies that worked on. There was 400,000 people that worked on Apollo and Gemini. And my next question is, like, so now when we go into things like, so now here we go aerospace, and here we go physics, okay, and then we go aeronautics, and then we go then we go NASA, then we go all the other space administrations, and then the government. Okay, and then there's several other components here, but mainly all of the sciences. How many of these people are fooled, and then how many of these people are just in the know? You're saying fewer than 1,000 people when you add up all the physicists and all the meteorologists and all the geologists.
Yeah, because everything still works. There's no difference, right? It's not like you need to know those things. It's it would be a very small club that would know it. The astronauts, I'm assuming, know. Now, some people think that they were brainwashed or hypnotized, because if you look at it, only NASA says 1 out of 4,000 applicants become astronauts. Look at some of these astronauts. Like if you go watch Don Pettit, the guy is borderline mentally handicapped. So you cannot say he's the best out of 4,000 applicants. It would be insane to say that. Go watch any of these astronauts speak. Find me one astronaut that I bet you Sergey speaks better than every astronaut. Every astronaut I've ever watched on the ISS, Sergey can speak better than that.
Got it. Okay.
There's a problem with that.
Hey guys, we have to wrap it up. I would go another 5 hours.
Hold on. Let's go another 3 minutes. I need to show you guys something, and especially the guys that have aeronautics experience, like the Harrier jump jet. Okay, that type of rocket or jet. How stable is that? Is that super stable? And real quick on that.
I feel like we're getting outside of the thing is because neither of us flew a Harrier.
So here's the thing. I want to show you. This is uncut footage of a SpaceX rocket. This rocket is a test flight that's going to take us to Mars. Now, tell me, is this a movie or is this a real rocket going up? Now, look, we have no smoke trail, which is interesting. And now look at the angle of the camera. We have a side view, far shot, close shot, and then we'll have this is pretty close. This thing is taking off. Now look how high it is. And then edit, it's low again. And look at the smoke. Just look at the smoke. Now the engines are going to go off. Now all of a sudden it's super high again. Now watch this. Look at the smoke and compare it to its speed. This thing is free falling. It's like a tractor trailer thrown off the Empire State Building. Okay? It's free falling. Watch the smoke in 2 seconds. Now look at it. It's barely moving, right? This thing is free falling. And then it's going to turn on its engines. Now look how high it is all of a sudden. This is straight from the live launch. This is unedited. Okay? This is free falling. Now the engines are going to come on and watch this incredible shot. Oh, look, it's all of a sudden it's up in the clouds. Okay? The engines are going to come on after this next shot, and it's going to magically turn over, stabilize itself. All right? Just hang with me. It's almost over. 15 seconds. And then 2 of the 3 engines are going to turn off. This thing weighs 40,000 pounds. Okay, that's if it had no fuel. Mm-hmm. Now it's got 1 engine. Look at this smoke. Look at this fire. And all of this CGI smoke. And it's going to land upright. Now, I would love a yes or no answer. Is that a real rocket launch?
Yes. I believe that is a real rocket launch. I do believe that. I do believe there may be they may have edited some parts in order to show it differently, but that is absolutely a real rocket launch. Yes.
That is amazing.
Yeah. Sorry. It's pretty amazing.
All right. You can find me at flatearthdave.com.
For sure.
Anybody that has a show that has an audience that wants to have this discussion, flatearthdave.com. You can say book Dave right there. Check out my app, the Flat Earth Sun, Moon, and Zodiac Clock app. Blue Water Bay. Buy Blue Water Bay. Don't get the rip-off one that's on Android. flatearthdave.com. The links to the app are there. It's going to be available on Amazon soon, App Store, Google Play. And what I say is, don't let them control your mind with cartoons, because that's what they're doing. And that's why the world is in this screwed up place that it's in right now, because people are lost in space, spinning out of control in a theoretical physics of a universe.
Got it. Jaron, where can we find you?
Yeah, Jaronism is the YouTube channel. I'm also at rockfin.com/Jaronism, so you can check out all my stuff there. And yeah, I'll just back Dave up that I think it's a lot of fantasy, a lot of cartoons for adults. They've placed little pieces of evidence for people to find, and then they think that they've proven something, but I don't think that's the case. And I think anybody who doesn't think for themselves and allow them to at least admit that, yeah, everything I believe about the globe Earth has been handed to me. They sat us down in desks and taught it out of school books. And if you really think about how truth should be ascertained, I mean, that's just not the way it would be done. It's not the way that the elite would ever have people learn anyway. They wouldn't want them to become great, get smart, take over their money, take over their power. They would want lemmings who are tax slaves, who do what they're told, who listen to teachers who don't talk back. If you talk back, you go to the principal's office, right?
Got it.
So there's no free speech. There's no free thought anymore. We're being shut down on YouTube for speaking about the flat Earth, and that's ridiculous. Why not just do what these guys did? So I give them some credit at least of saying, let's talk about it.
Well, dude,
but,
I'm sad because I wanted to go over the conferences and like what's it like dating in flat Earth and all this other stuff. We don't have time.
Amazing.
We don't have time, but I definitely want to get to that next time. We're going to next time I really want to talk about like maybe we do this maybe in 6 months or something like that. You know, who doesn't like who and what the whole social scene is like that. I'm very interested. Thank you guys. I appreciate it. I still think the Earth is round. I'm sorry.
Just remember, we've got the majority of the Playboy cover models.
Yeah.
Wait, that seems the math off there.
To be fair, you might be telling the truth. All right, guys. I will thank you guys so much. Thank you, Sergey. Thank you, Adam, for joining us. I will see you guys next week.
Later. Peace.
All right, guys, welcome back. This is the wrap up for the episode that you just made it through. Congratulations for those of you who made it through. John, first of all, your impressions, you got to see it live. What did you think about it?
That was a marathon. That was absolutely one of the most intriguing, compelling, provoking podcasts I've ever seen. And props to you. You know, it's so hard. We all know, especially this last 3-4 years, right? On social media, we've all seen how a post on Facebook or a post on Instagram can blow up and divide families, friends, colleagues, right? And having civil conversation is almost a thing of the past. Somehow, you were able to take a very controversial subject and keep it on the rails, which I didn't think. And I'm one of your biggest fans, as I think and I remember saying to Travis and a couple other people before you did the show, I was like, man, that's a lot of people on, and it's a lot of people on Zoom, and it's really hard. When you one-on-one's easy.
Yeah.
3 is great.
Yeah.
When you get to 4 or 5 people on a podcast and not have people talking over each other and cutting people off and, mother effing each other and whatever, it's really hard to do. And somehow, I don't know if you gave them a disclaimer before you started, like, hey, let's keep it civil. Or I don't know if you did anything like that.
At the very beginning, I did, and I was also super cordial with Dave.
Right.
I think you have to think about it from Dave's perspective, right? So again, for those of you who are watching it, you just expected me to bash these guys for 3 hours. That's not what I did. I knew, for whatever reason, you get to flat Earth somehow, right?
Yeah.
How did we get here? Something happened in your life. I would imagine in Dave's life, because he makes a joke about it in the podcast, you lose the respect of your family and friends. He was joking about that or whatever.
Right.
But you can understand, these guys are in a way, no disrespect to you guys, but a little bit whipped dogs. I can imagine that society just shits on them a lot.
Right.
And I didn't, so I knew that they would be a little bit, I didn't want them to be defensive. I wanted to legitimately, it was almost like the Silmarillion from Lord of the Rings. I wanted to know, what is your physics? Explain to me the rules of your existence,
right.
Or the World of Ice and Fire in Game of Thrones. These are books that set forth the physics of what's going on. I still looked at it like it was make-believe, and I'm not going to lie to you. There were points where I was just I'm going to be as open-minded as I can. The problem is I have too much of a background in physics and aeronautics for me to believe that the Earth is flat. So that was part of the issue. And the other thing is I wanted to give them actual responses to it, and I felt like this is the issue, right? Neil deGrasse Tyson won't debate with these people. He won't, right? And I was disappointed when I heard that Neil deGrasse Tyson wouldn't. But the problem is this, and I'm just going to be real straight up about this. Neil deGrasse Tyson has some things that happened in his past, and sometimes definitely not Dave and Jaron. I'm not talking about them, but there's some people in the flat Earth community that have doxed individuals. They've made threats to people's lives, and for Neil deGrasse Tyson to go on and debate these people with his wife, and then the whole incident back in the 1980s. That I'm not going to say the name of it, but these things, I would, if I was Neil deGrasse Tyson,
it's not worth it.
I understand. What I think is there may need to be a separate subset of science educators. I don't have a degree, so I don't know if I'm qualified. Maybe I am.
Yeah.
But just for debate. I think that if you have a separate subset and we're just set up just to debate these guys, because I've been pretty quick on my feet when I came up with the answers.
Yeah.
And I had done a lot of study. And the other thing is, one of the things, and shout out to Dave and Jaron for doing this, they studied me. I really thought that they were going to come in here and think that I was some schmuck who hosts bikini competitions, and they were going to walk all over me. And I think there were a couple of times, especially with the space shuttle, especially when he started talking about, the Southern Cross rotating laterally around the sky, which, I'm sorry, it made no sense. And he was talking about corpuscular rays. I was just I don't think that they expected this much of a fight where the answers were this quick. And then again, guys, if somebody asks you, how can I tell the size and the distance of the sun? It's gravity, parallax, and a spectroscopy. You can tell the difference, the distance of the sun. The problem problem is it wasn't empirical. Then I gave the empirical examples of like flying in the southern hemisphere. Well, how come the moon keeps showing us the same face at every place in the planet? And how come when I look to the south in Australia, I look to the south in South Africa, I look to the south in South America, I see the same Southern Cross? That they didn't have an answer for that. So that part I thought was really good. I will say this. I know why you pay for defense attorneys now. I know. Why do you pay $9 million for Johnny Cochran, F. Lee Bailey, Barry Scheck, and Shapiro? The reason why you pay that much money for that kind of defense is because they will keep fucking talking. And these guys did that. There were several instances where it was like they were asking me a question and the answer was pretty simple. It was like, global positioning system or something like that. And their answer, I feel like I lost control when they got into seasons. Mm-hmm. They went into the seasons explanation, and he put that clock up on the screen. Which,
to me, that was the most interesting part of that whole piece, because that, again, let me give a disclaimer.
Yeah.
Nobody swayed me.
Yeah. He still believes the Earth's flat.
Loud and clear, we're on a globe, okay for the record. But that was really compelling for me, because, I think I'm a good case study, because I probably represent the masses, right? I'm not was well-read. I'm not even read. Never mind well-read. I dropped out of college, Mike. When he showed that video of that clock, it did make me think like that. Now that's interesting. That's interesting because I wasn't expecting them to be as prepared
Oh, I did.
I know you were. I never heard of Flat Earth Dave until you.
I believe he had done 200 interviews where he's the guest. Right. 200, not to mention what he does on his, which right now they're kind of getting into vaccines and they're going in a little bit different direction. Mm-hmm. But I knew there was never going to be a gotcha with Dave.
Right.
What I expected is like, this is crazy. Okay. So if you're a part of the scientific community and you're watching this, I'm hoping that there's some science teachers and some science educators that are watching this. There was a hypothesis you guys put forward, and the hypothesis was we're not going to engage with these flat Earth people because they're so stupid. That was your hypothesis. And what happened? Now, when you do surveys, over 2%, some people say 4% of the population believe the Earth is flat, and it's mostly millennials. These were people that you could have affected, and something to the order of 7% of people are not sure whether or not the Earth is flat. That sounds ridiculous coming out of my mouth, but those are real numbers. So your hypothesis was we're not going to engage with these people. And the result was the movement grew. Your hypothesis was incorrect. It's been proven incorrect. It is time for science educators to just listen. If you need me to do it, I'll help you. If you need somebody who's a little bit more loquacious, I will help you. But the fact of the matter is, I don't think you can duck people who think that vaccines are full of poison. I don't think you can duck people who believe that we didn't land on the moon in 1969 or that the Earth is flat or any of these other things. I don't think you can duck them anymore. I think you have to get to the point where you're willing to have a debate with them, but don't call them. You don't motherfuck them. That's the only thing.
Right.
That's the main issue. So I thought that was great. But like again, I would make an explanation. Like for instance, they'd ask a question. I'd be like, so how do you tell how far the sun is? And I'd be, well, it's spectroscopy, parallax, and gravity. That's the short answer. The actual answer is you can tell the proportion of two gravitational bodies. If I can see the orbital period and the distance between the two bodies, I can't tell their mass, but I can tell their mass in relation to one another. And then if I look at the sun, if I can tell the Earth's mass and I can do it with the sun, now I can tell the Earth's mass and the sun's. And then I look at the sun and I look at Jupiter, now I can tell Jupiter's mass. And from the Jupiter-Sun system, I can pretty much figure out the mass of all the other bodies. And then once we send those satellites out there, Voyager or whatever, and then we go photograph them. It turns out those masses are correct. Turns out Isaac Newton figured it out in the 1680s. Turns out all of this worked out. And then I also have this other thing I forgot to mention on the podcast. It's called redshifting. Doppler shifts. I can actually tell the forward and backward relative motion of stars. The other part where he talked about the inverse square law, where like light shouldn't be able to get to us from Proxima Centauri or Polaris. Guys, go look at Proxima Centauri and Polaris. You can't tell where you can't see the lines of magnetation. You can't see solar flares. You cannot resolve those stars. You can just see the light. That is the point. Light travels an almost infinite distance, or it travels. We can see the cosmic microwave background radiation. That is 13.8 billion years ago where we can see the light. That's how long we know light can travel for. So the whole thing for them is if we're on a flat plane and the sun's on one side of the plane and we're on another side of the plane, their whole belief is, well, the sun has a finite distance for light. And that's where to me, the whole thing it's not testable anymore. Furthermore, the round earthers, we can protect eclipses. They can't. I'm sorry, they can't. And when we ask them, like, how far away is the sun? Well, think about this. I have my hypothesis on how the world works, and I use it to create testable models, and I predict every single eclipse with 100% accuracy. And in your model, you're saying we don't know how far away the sun and the moon is. Do you understand? But
Right.
then how am I predicting it if my model's wrong? You see what I'm saying?
Sure.
So that was kind of an issue. I know a lot of people are out there like, why are you even debating with these people? Because 7% of people are saying they don't know whether or not the Earth is flat.
Dude, so I put up a poll that day when you were doing the show. I was watching in the room next door, and I put up a poll on my personal page, and I think on the Political Junkies page.
Yeah.
Is the Earth? I've showed a little video of you. Is the Earth flat around? 20%.
Yeah.
On the poll.
But obviously, people, that's going to be biased.
Some are jokes also, right?
It's not even just jokes. It's like the people who think the Earth is flat are going to talk louder than the people who think the Earth is round, who don't even think this is legitimate.
Some won't even vote.
Yeah.
The ones that, right. Like,
Yeah.
I'm not even waste my
I
vote.
legitimately believe 2% and higher that. I'm talking about like millennials and under. The problem is like, guys, Kyrie Irving, the point guard for the freaking Nets, who has he went to Duke University only for 1 year, but he actually seriously believed that the Earth is flat. And I I think he still thinks the Earth is flat. He was just so embarrassed by those remarks that he's taken his remarks back. One of the reasons why some people, I'm not talking about Dave and Jaron specifically, a lot of people, what happened, we talked about this before. I have a friend of mine, and she was sexually assaulted. And because she was sexually assaulted by an authority figure, all authority is now bad, and therefore everything authority tells me is now wrong. And since authority told me the Earth was flat, then therefore the Earth was round, therefore the Earth might be flat. And then that's where these things get started, right?
Footnote to that.
Yeah.
She probably likes it rough, though, doesn't she?
You know her, so let's not talk about it.
Okay, fine.
Yeah, let's not talk about it.
But isn't that a weird dynamic? Do you know what I'm saying? Like, I'm not making a joke out of a serious situation, but usually the people, victims of trauma, gravitate towards that type of trauma in bed to turn them on, which is like an interesting thing. I really wasn't being insensitive.
No. Of course.
Yeah.
No, I totally understand. But that is something that happens. But like the whole situation with this man, like, I understand, like, you have to have some empathy. How did we get to this point to where people actually believe this, and this wasn't an issue before? But like, man, oh man, like, again, what was it? The name of the eclipses that they had, the Selenilian eclipse, where you can see the sun and the moon at the same time. A lot of people, and again, I can't keep up. They're going so fucking fast, and at 3 hours, my brain is melted.
Yeah.
And they start talking about the Selenilian eclipse, where you can see the sun and the moon at the same time. Well, a lot of people don't realize this. If we were in a vacuum, you would actually see the sun go down when it actually goes down. But because we live in an oxygen environment, and they even admit to light refraction through the environment, when you see it, you're actually looking. The sun has already gone down, but you're seeing a refraction of the sun that's still up there, even though the sun is actually in reality set. The environment refracts it. So because of that, now I'm seeing a raised refracted image of the sun and the moon at the same time, and that's why I can see an eclipse from both sides. I can see the sun and the moon at the same time. That doesn't.
What did you think? Sorry, what did you think when he was in his kitchen? And he showed he did that little experiment.
Did you notice at the end? And I was so tired of like, guys, listen. Dave and Jaron, if you're watching this, I have a lot of respect for you guys. I do. I know you probably don't. I have a lot of respect for you guys. When they were doing the seasons thing, there was a point in there where I was like, I was so bamboozled, bro. And it wasn't because I felt like I was wrong. I couldn't keep up with what the fuck he was talking about when he said that when he was saying like the sun was moving faster, but it still looked the same across the sky from an angular perspective. Bro, I was just like, dude, the math is so quirky on that shit. And he doesn't go over how the sun moves from one orbit to another. He doesn't explain it. But dude, when you get into electromagnetism, how they explain why the sun and the moon are even up there in the first place, it is so there. By the way, there are 4 fundamental forces in the universe: strong, weak, electromagnetism, and gravity. They only believe there's one force, electromagnetism. They think electromagnetism explains the entire universe. So that part was crazy. What was the thing you were just asking me about? The
experiment
kitchen thing.
in the kitchen. Yeah.
You guys notice, if you guys watch the kitchen experiment, you'll notice when they get to the end of the kitchen, there's this block that's right there that like sort of block, like it wasn't a flat plane. It was like there was, where you put your knives or whatever, like your cutlery stand. There was something at the end of the table and I'm not saying if it was far enough that it wouldn't look like that, but that does not prove anything. Also, guys, like, why is it? Oh my God, there's so many questions. Light does not have a finite distance of travel. Therefore, if we're on a flat plane, we should be able to see the sun, even if it's 4,000 miles in the air, from any point on the surface of the plane. And that's the other thing. And then the other one is just so obvious, man. There are not 60 fucking thousand miles of coastline for Antarctica. There just isn't. You can map it. It's not that difficult. You don't even have to go into Antarctica to go there. So there was just certain empirical thing. Well, that's not empirical because you and I are never going to Antarctica. So that was the problem.
And then the flying. the 3 point,
it was so disappointing, man. I mean, it was just like, I don't want to get into the great circle, because when I went to nav school, I was like, what the fuck is this? I don't want to do a great circle route. But then when you show, like, you're looking at a 2-dimensional image of a 3-dimensional image, there's going to have to be some relief. And the relief is that the circle, it's going to look like there's a curve upward, but it's not. If you were to able to look on a globe and get right over that path, it would look like a straight line across, and that's essentially what happens. Dude, I've flown too many times. Dude, when you fly from Atlanta or Warner Robins, Georgia to Doha, Qatar, it's this weird route that goes down like this, but when you look at it on a globe and you turn it over, it's like, oh, okay, it makes complete sense. That's exactly what we're supposed to do. And we were just like, again, there were several times where I felt like I was kickboxing and they were doing jiu-jitsu. Like
that was a great analogy too.
Yeah. Because here's the problem. Like, the ultimate issue that we were debating was empiricism versus science. Mm-hmm. Empiricism is that I only believe things that I can feel and touch. And by the way, for certain things, if I'm a boxer, that's probably a really good way to live your life. If I'm a swimmer, even if I'm a carpenter, it's probably empirical data is probably the best way. Although I am going to need some mathematical stuff, right? I'm going to need to know that this epoxy or this wood is going to be able to handle this level. But there's a level of faith that I need that this TV is going to work, or that this building is not going to collapse on me.
Right.
Why? Because of Newtonian physics, right? There's a certain level of trust that I need to have. But here's the thing that works, and Dr. Dida said it many times. Does my theory create a testable model, and does yours? Yours does not. Mine, I'm sorry, we're correct every time. That's why your GPS fucking works. It doesn't, because does it not surprise you? Like, the global positioning system works. Not even phones this expensive. Like, it works for all these phones, and and you look at it and it's accurate, and we take it for granted. The fact that there's 21 satellites orbiting the Earth from pole to pole, and that can quadrangulate your position up to 5 meters. What the fuck? And by the way, we tune it down. It actually could. The GPS could be way more accurate. Military GPS is, and we actually tune it down for certain, like, security reasons. Dude, yeah, no, it's your speed. Exactly.
Right.
Can you imagine?
I had when I first signed on the Progressive Insurance app, they did this thing. Hey, we'll reduce your rate if we can monitor your driving for 30 days. Have you ever done this? Right?
No.
And it measures your hard braking and all that stuff. And with GPS, it'll say, like, hey, you're going 27 miles. You can see, like, you're going down Sunset, 27 miles per hour. Like, it's just fucking crazy. Like, how can you explain that?
The problem is my side my side believes in relativity, quantum mechanics, and Newtonian physics, the laws of motion, electromagnetism, strong nuclear force, weak nuclear force, and gravity. That's what my side believes. And from those things that my side believes, they're going to say, well, it's not your side. You're just believing what other people tell you. Correct, until the point where we use what I believe is a testable model, and then we get the correct answer for the eclipse, and we use quantum mechanics to create lasers, and then again eventually create transistors in 1957, and then we have we go from the cathode ray tube to an actual television.
Right.
Like, this, it worked. It fucking worked. And then the other one, bro, I didn't even get to this. It was like mind blowing. There are like 9 reflectors on the surface of the moon. If you go to any astronomy department and you shoot a laser up, you're going to get a laser beam down in 2.2 seconds. If the fucking distance to the moon is 4,000 miles, that means that light travels at 4,000 miles a second. Dude, do you understand the implications of that? It is so utterly absurd. And like, how is it reflecting off this moon? How is that possible? Unless Neil Armstrong landed there in 1969 and put a reflector there. That was the point. He's an engineer. For those of you who don't know, he was an engineering professor, and his project, every astronaut, when they go up there, they almost have like a PhD thesis, an experiment that they're specifically working on, right? And they go up there, and his was a reflector a beam reflector that he put up there, still up there in the Sea of Tranquility. And there's 9 of them. The Chinese have put some up there, the Indians have put some up there. Mm-hmm. And like, the other part was the Chinese Space Administration, Indian Space Administration, the Russian Space Administration, and the European Space Administration, and the Americans were all liars. And I believe the Brazilians put people up there too. All of them are in it together. And then go ahead.
That's always the thing that gets me is for this to all mesh with what they're saying, so many people have to be in on it.
And he's saying fewer than 1,000 people are in on it.
There's no way.
How, bro?
And then what's the point of, okay, it's like, walk yourself through that. Okay, so you have to believe that rockets exist, because that we've seen, right? Yeah. People have seen that live. They've seen the rocket go up live in person, not just on TV, right? Yeah. So it makes sense to certain people that NASA and the government funded building these rockets, launching these rockets, just to get it to a certain point to then go into a studio and fake the rest. It doesn't make any sense.
It's so expensive. And then here's the thing, man. Like, why? I mean, I didn't even get to this. Why? What's the point of Columbia and Challenger? What's the point of killing all those fucking people? And don't tell me they didn't die. They did. Now, here's the thing. We avoided this. I'm not going to say the name of it, but it was a shooting up in the Northeast. I'm not going to say it. And Dave doesn't believe that shooting is real. He thinks all the people were actors. I'm not going to say it because I don't want YouTube to flag this thing. But like, he doesn't believe that's real.
I have friends that think that too with certain shootings and stuff, and the whole
even Alex
paid
Jones
trauma actors.
Even Alex Jones came off that. Even Alex Jones apologized.
Because again, it's like, okay, so I've been in the entertainment business my whole life, right? So worked in TV, worked in film, worked in everything, print, you name it. Where do those posts go exactly for those actors that they're getting, right?
Where does
it happen? And then no one comes forward that knows those actors. Like all those friends of people, they just keep it a secret. They're just like, oh, oh, my friend died. No, he didn't die. It's just he's a trauma actor. He's a crisis actor. It doesn't make any sense.
So for those of you who are curious, there were 400,000 people that worked on Apollo and Gemini. 400,000. And the belief that Jaron was saying was that it takes fewer than 1,000 people in order to keep a secret like that. No way. The truth is it takes fucking 2 and you're done. Bro, all of you use logic. How many secrets in your life have gotten out? This is a huge secret. I have what are they going to do? And again, I know for those of you who are flat earthers who are watching this, I can't wait for your comments about how I work for the CIA or the Illuminati or my last name is Rothschild. I'm waiting for it, please. And by the way, I appreciate it because it's just the algorithm's just going to pump up this episode. But man, that was interesting. I definitely want to do it again. I want next time I want to throw in some evolution. I want to throw in some other stuff like that. Go ahead.
I would love to see. I actually think you guys could take this on tour. I'm not even kidding.
No,
in
maybe,
town hall type of thing, or like Brian Howie does with the Great Love Debate. I think it's really compelling because the only component missing would be live questions from the audience on both sides.
Incredible,
right? Would be amazing.
Yeah, the problem is you can't get impartial people. Your buddy who was sitting there, I'm not going to say his name, but like he was acting like he didn't know what was going on. The dude is a full-on flat earther. I'm sorry. I don't mean to call you out, brother, but it was very obvious. Every time I made a point, you kept telling me I didn't make a point. I was like, I understand which side you were on.
Right.
I would love that. I would love live questions.
Yeah, it would be interesting because I do think some of it was compelling. Like, again, doesn't sway me, but the seasons thing I liked. I liked the whole clock with the seasons.
It was interesting.
Like, it was very interesting.
I felt like I was watching Game of Thrones.
But the thought that so what he believes we're surrounded by Antarctica, is that the deal?
Correct.
So the whole world is basically inside of Antarctica.
Yeah.
Antarctica spans the whole, but he does not believe in satellite images, right? Because that would completely dispel that theory right off the bat.
But GPS is patchwork of balloons and cell towers. That's what he believes. I mean, the thing is, guys, like, there's people, again, I'm trying to be considerate to those of you who believe the earth is flat. I don't want you to turn away from this program because you think maybe you'll learn something, man. I don't know. But the situation is like, okay, let's just real quick, for those of you who watched the episode and you're like, you just skipped ahead to the end, I would highly recommend go to Proof 1, Proof 2, Proof 3. Proof 1 is, again, flying in the Southern Hemisphere. They're a thing, and I'm not talking about when they have connecting flights that go in the Northern Hemisphere, just flying from Southern Hemisphere to Southern Hemisphere, and that is Santiago to Sydney, and that is Johannesburg to Buenos Aires. In those flights, the flight time does not match what it would look like on a flat Earth, and the distance obviously doesn't match, and their explanation was 900-mile-an-hour tailwinds, 1,200-mile-an-hour tailwinds, and that somehow the people in the cockpit wouldn't know that they're going, or that the people in the cockpit were part of the conspiracy. I will let you guys know that you have ground radar in aircraft, military aircraft, or regular civilian aircraft where I can see how fast I'm going, and it's not because of GPS. You can also see because of GPS, but those are two different speeds. Not to mention you get true airspeed, indicated airspeed, and ground speed. So those things, but that kind of negated that. There is no way to take an aircraft that looks anything like a Boeing 747 and take it above the speed of sound. You can do it, but you can only do it once. Because the plane will break apart. The plane will break apart. Like we had a we had a Boeing 707 KC-135 go into an uncontrolled roll. It went past Mach 1, and the thing was never able to fly again. It'll do it one time. It will fuck up the airplane because of the air compression. It just doesn't work. And then the other part, the number 2 was the fact that we see the same face of the moon. So consider the moon is 4,000 miles above us, and it's 32 miles across. If I am 24,000 miles away, so I'm at the tip of South Africa and I'm at the tip of Australia, which they would tell you are two different places far away from each other. Let's say I'm 20,000 miles away. If I'm looking at an object that's 32 miles across, that's 4,000 miles up, I should see a completely different face of the sun. They're saying it's a projection on a dome or some sort of like hydrogen, whatever he said, some sort of fluid that's up there, some kind of superfluid. If it's a reflection of the superfluid, I'm going to see a distortion. I'm going to see an oval. I'm not going to see a circle anymore. Even the example that he used where the guy was in the pool that you saw that was distorted. The image was narrow and then the image got into full size. That's essentially what you would see. That to me is an empirical proof number 2. And then proof number 3, this is the death knell. For those of you who are having any problem arguing with the flat earther, this is the end of the fucking argument. If you are standing in South Africa, in South America, and in Australia, and you look to the south, you see the same Southern Cross. And yes, I know he was saying that it moves from left to right. The Southern Cross will move to left or right over the nighttime. You can take a camera, you can take a long exposure, you can see, number 1, it does not move from left to right, and number 2, and this is the ultimate death knell. In northern hemisphere summer, southern hemisphere winter, when it is darker in the southern hemisphere, it is nighttime in South Africa and South America at the same fucking time, and you can see the Southern Cross in both places at the same time.
Wait, say that again.
In South Africa and South America are close enough to each other that they are in nighttime in the middle of winter. Okay. In like December 21st, it will be dark in both places at the same time. If you look directly to the south in Johannesburg and Buenos Aires, you will see the Southern Cross in the same position in both places, which that is the end of the argument. 1, 2, 3, done. That is it. There is no way to counter that. He started talking about corpuscular rays. I've seen people on YouTube talking about everybody has their individual dome that follows you around while you're walking. If you want to believe that, then there is no way for us to possibly prove to you that the earth is round, because it is round, because I have flown too many missions. I have 700 hours in a KC-135 as a navigator and 500 in combat. I know the earth is round. Anyway, what else? What else?
Yeah, the pilot point of view to me is the best. Yeah. Is the best one, right? Which is why you had the pilot on.
Let me say one other thing. There was a guy who supposedly had a multi-engine crew license, and he said he was a flat earther. They went and investigated. He does not have a multi. There's no way to get a multi-engine and believe the earth is flat. You'd have to lie on the FAA exam, basically, in order to do that. And I did say one thing. I want to catch myself on something. I want to call a foul on myself. I did say I have a PPL. I finished all the way up to my FAA examination for my PPL, and then I was medically retired from the military, so I do not have a PPL. I do have 700 hours navigating a Boeing 707 and 500 combat hours, and I have 175 landings in a Cessna 172 and a Piper Warrior. So I'm capable of flying an airplane. I just did not take the FAA exam. So,
if Antarctica did surround us, as they said,
it'd be 75,000 miles around.
And so then, but if that was the case, wouldn't you be able to drive around the world?
No. Oh, yeah, but you can't go on Antarctica because of the Antarctica Treaty with the militaries up there. Yeah, you'd be able to drive around the world. Yeah, what you're saying is accurate, yeah.
You'd be able to drive around the world.
From a physics standpoint, yes, yeah, that's correct. Yeah. That would make sense and not make sense at the same time.
Right.
Interesting. Again, dude, defense attorneys. These guys, like, one of the things that's like really sad to me is like these guys are so good at arguing this, and you wonder like what they could have done. Yeah. What they could have done, man. Dude, I'm telling you, Flat Earth Dave would be a fucking incredible defense attorney.
Super likable guy, super charismatic guy.
My God.
Obviously an intelligent guy. Like I don't feel a dummy can't argue flat Earth
here's the other thing. I've heard other people say that he's a con man. I don't think he's a con man. I 100% believe he believes this.
I completely agree with you.
100% believe that.
I totally agree.
But I just like watch Dave and I'm like, dude, this guy could have been just he could have been the mayor of some city. This guy could have been an incredible defense attorney.
And he supposedly used to believe the world was round.
Yeah, he did up into 2015. So that's another thing I want to talk about. This whole flat Earth reincarnation. The Flat Earth Society is about 200 years old. The reincarnation of flat Earth, it started in 2015. Does anybody remember what was happening on the internet in 2015 on Facebook with the Russians and all this other stuff? Okay, I'm going to postulate a hypothesis, and my hypothesis is this. These other countries know that when it comes to science, technology, engineering, and mathematics, the United States falls far behind all these other countries, which is why so many people here believe the earth is flat. We fall behind. So if I was another country and I wanted to screw up the populace of the United States and divide them, I would attack the fact that we have science illiterate individuals, and I would start Facebook groups that indicated that the earth is flat and it's a big fucking conspiracy. I personally believe that it was foreign service agencies. This is not that controversial. We know other countries were interfering with our social media during the election. I think that's why I think that's where anti-vax came from, and I definitely think that's where flat earth came from. I definitely think it was just created there to divide us, and it was just like one of these things where like you don't feel special. And I'm not talking about Dave and Jaron, but some people don't feel special, and this is a thing that you can hold on to that makes you feel special. What I'm doing doesn't make me feel special. I'm on a fucking mud ball that goes around a sun that's one of 100 trillion other suns, and that my life will end at 80 years, and I am completely insignificant to the existence of the universe. That doesn't make me feel fucking special.
Right.
I have no privileged perspective. I am just what I am, dude.
Why are you trying to check out at 80?
I'm not trying to. I mean,
okay.
That's just average. You know what I'm saying?
But why pick 80? You're above average. You're not average. You're not an average mortal.
Granddad lived.
You're going deep. You're going 100.
Great granddad lived at 105. So maybe
you're going 3 digits. Come on.
Maybe we'll see. We'll see.
Right.
But the point is, man, like that was fun.
Yeah.
I went in reviewing it. It was a lot better than I thought.
It was incredible.
I was for me on my standpoint, my blood sugar was dropping when he got to seasons, bro. Like you look on my face, I'm like, I can't keep up. And then like you saw when Jaron, no disrespect to Jaron, when I said, hey, why is it that we can't see the Southern Cross moving laterally to the different southern points?
Yeah.
And he goes, you know what corpuscular rays are? And I was like, oh, bro, it was like he had 3 heads. I was looking at him like corpuscular rays. He said, corpuscular and anti-corpuscular rays. And then I was like, it was almost like if I said, hey, what's 2 + 2? And you go orange. And I'm like, bro, I don't know. Like, is it orange? I'm so tired. It's been 3 hours. I don't know what the fuck to say at this point. I just couldn't keep up. And then at the very end, they try to get me with some gotchas with the video clips and look at this and this is faked and 5. And like, granted, man, I don't know. Are they video clips? Are they faked or whatever? We didn't even get to the ISS because I had something for that. It has to do with video codecs. Why some of the ISS things look like green screen. But I mean, dude, it was just. We did not get to a lot of stuff, and the one thing I really wanted to talk to them about is what it's like dating in the flat Earth community because it's a whole clique.
Oh wow,
dude! You and I are going to the convention when they come here.
I would go
100%.
Yeah, it is a fascinating topic that I never even thought was a topic. This first got on my radar screen with I'm sure maybe you too, Eddie Bravo talking to Joe Rogan.
Bro, I know. Yes,
that's how I first I remember sitting in shock. Maybe 4 or 5 years. Yeah, it was about 4 or 5 years ago.
Yeah.
When Eddie Bravo would bring that up, and I was like, wait, is he He's joking, right? And like I was, no, he's serious. He's actually serious.
It's just like, bro, do you remember? This is gonna sound really messed up. Dudes who look like Machine Gun Kelly and Post Malone and G-Eazy. We used to make fun of dudes like that back in high school, and now they're like super popular,
right?
With neck tattoos and tattoos on their face, and like that was like really weird. And now it's like normal.
They're bad boys,
and like they stand out. And I feel like that's what this is, bro. You're in this clique, and you're one of one. Do you understand what this means? If you're Flat Earth Dave, you know the truth, and the other 99% of us don't know the truth.
I was very surprised at the number of friends I have, and you know who you are. That believe the Earth is flat,
bro. I'm
shocked.
When you have blonde hair and breast implants, apparently it's like 10x rule. Like the likelihood of you believing the Earth is flat is incredibly high, bro. It is crazy how many of them I know that. But yeah, it was man, it's interesting. Now here's the other thing. I hope those of you, because I messaged a lot of you who believe the Earth is flat, and you didn't want to come on the podcast. So now I hope you watch this and you aren't intimidated. You see, I'm not rude about it. It's not that big of a deal. I would love for you guys to come on. Hopefully, you guys are not doctors or doctors or
This should be at least every 7 or 8 episodes.
I don't know about that, but maybe every 7 or 8 episodes.
Yeah, it's too good. Well, I think you need to start thinking about going more than once a week. I really do.
Yeah,
it's too good. You're the content's so great. You really are. Not that anyone should ever compare anyone to Joe Rogan, but I'll do it. You're very Joe Rogan-like in regards to what can't you talk about?
Right.
Like there's, I can fake it. You can actually talk the talk with just about any topic, and it's pretty incredible. You know?
This has been incredible passion, man. All the people who got on here and joined my training program, Men of Action. The ton of you guys have joined from this, and I really appreciate you guys coming on and checking it out. Again, a lot of you guys are watching this and you have not subscribed to the channel. Please subscribe to the channel. I love it when you guys write me a review on Apple Podcast. Hopefully you guys enjoyed it. Hopefully you guys learned something. I would really like to hear from those of you who are on the fence. Those of you who are flat earthers, I understand you're going to tell me to go fuck my mom. I understand that. Like, I get it. I told you're going to tell me I'm an idiot and that I didn't listen, and that's fine. Please comment because it helps the algorithm. But for the rest of you who are kind of on the fence, tell me, did those proofs mean anything to you? Did they help you in any way whatsoever? Did they help? Or was it just the more talking and the video clips of the SpaceX thing that actually means to you that this wasn't supposed to happen? I don't know, man. You guys can tell me what you think. Hopefully you guys enjoyed it. We will do this again soon. Let's do like 6 months. We'll have them back.
All right, fine.
6, but we're going to talk about different stuff.
It's a long wait, man.
Maybe less than 6 months.
All right.
We'll see. I'll tell you what. If this gets 200,000 views, we'll do it.
Might need to kick the year off with it.
If this has 200,000 views, we'll do this next week. We'll do this every week. Okay.
Yeah.
Again, tell your friends about this. If you guys are science educators, please pass this along to your physics professor. Please pass this debate along to your science professor or even your biology professor. Please pass it along to any frustrated science educator you know. Maybe I can help you out. Maybe I can help you with this debate. Maybe I can help you to where you can have a rational conversation with these people. I have people in my life. I can't get rid of them. I love them. They're my family. And they say things that are outlandish. And I'm not going to get rid of them in my life. And I'd rather be able to have cordial discussion with them and be able to move forward in life. John, thank you so much.
Yeah, man. Thank you.
Thank you for your support for Sticky Paws and for Maxim NFT helping with this whole thing. Guys, this has been a dream come true. I cannot believe how many of you are coming at me every week and talking about this podcast. Dude, on 1 million likes on TikTok. What the fuck, dude?
Incredible.
How did you guys give me 1 million? I'm nobody. You give me 1 million likes on TikTok. I can't even believe that. Man, the biggest thing I've ever done on social media so far has been this podcast. So I just want to say thank you guys so much. If you have somebody that's interesting, you want me to come on, I'm going to try to reach out to David Goggins. I'm going to try to reach out to Neil deGrasse Tyson. I'm going to try to reach out to Mike Tyson. Hopefully we can get him on there. And OJ, we're waiting on you, brother. We're waiting on you. I'm telling you. I promise you. I know more about your career in the 1970s than you would possibly believe. Please come on the show, brother. You got a safe place right here. Talk to you guys next week. Stay tuned.
You all love the Flat Earth Sun, Moon, and Zodiac Clock app. The best tool to show your friends and strangers how the Flat Earth actually works. But are you ready for a Flat Earth app game changer? A new feature has been added. But first, a reminder of some of the existing features. Video of the day. World time. See what time it is all around the flat Earth. A true Earth compass that shows true navigation across and around the flat Earth plane. Weather. Tap for detailed local weather information. Know what phase and where the moon is at all times. Watch the sun travel between the tropics for the seasons. Select an amazing background. Add a countdown to your next big date. Video playlists in different languages. See the real trade winds circling the flat Earth. Top 21 frequently asked questions with quick pop-up video answers. Access to the best photos and GIFs at your fingertips. Flat Earth books and merchandise, and more. Now, the game-changer upgrade we've always dreamed of having. After a year in development, our app just went next level. You're now able to find Flat Earth app users near you. See where they are and send them an instant message in the app. Instantly arrange for a Flat Earther meetup. When activated, blue dots mark the location of the app users near you. You have 3 choices on showing your location. PP, to pinpoint. This marks your exact location. CC, for city center, which will place you within a few miles of your current location. Or turn off, which removes you from the map altogether. Use it when traveling, or when you're out for a day at the beach, or while eating out somewhere. Find out where other Flat Earthers are and connect. Find like-minded Flat Earth app users and regain your sanity. The Flat Earth Sun, Moon, and Zodiac Clock app is the best tool to show your friends and strangers how our Flat Earth actually works.